Welcome to the Python hacking beginner level training. Now, in this particular course, let us first see what particular skill sets are required for a person or an individual or a professional for doing this course. What are our course objectives? So we go on to the course objectives wherein the participants will be able to, first thing is, understand what is a reverse cipher and a Caesar cipher. Also, how to hack your Caesar cipher. Then, how to encrypt or decrypt your transposition cipher. Then, we'll move on to encrypting and decrypting files. And lastly, we'll also look at a test program on what is transposition cipher. Any course requirements or prerequisites. So the following are your course requirements or the prerequisites. That is, you should have the core Python knowledge. You should have the basic computer knowledge. Also, you should have the basic programming knowledge. So, who are the target students for this particular beginner level course? Now, they are any professionals who want to learn how to hack using Python, or they are any individual who is interested in learning hacking with Python. Okay, so now let's understand by the end of the course what are you going to have the skill sets for. So you will understand the different types of hacking. Also, you will be able to write many programs on how to encrypt or how to decrypt files. So let's begin with this beginner level course of Python hacking. Welcome to the first session in our Python hacking beginner level course. Now in this particular course, the first topic that we would be covering is the reverse cipher. Now we need to first understand what do you mean by reverse cipher. It basically is encrypting any message by printing it in a reverse order. So for example, if we say, suppose, hello world, it should be printed as in a total reverse order. So DLROW space OLLEH. That is how it should be basically printed. Okay. So to decrypt or to get the original message, you simply reverse the encrypted message. Again, you will get it in a decrypted form. Right. So encryption and decryption steps are the same. But now we will see one particular code for a reverse cipher program, and then we will see what all things could be done in a reverse cipher program that we would be creating. So first thing what we will do is, let's just remove this. Now basically we are into Python IDLE, okay, which is basically an interface wherein you can type the programs. If you want to save it, you can create it in a new file, type the whole program, save it, and you will run the particular program which will give you the total output. So over here, we will start with, say, a variable message that's equal to, in single quotes, we give, say this is Python hacking session 1. We are doing reverse cipher. This basically we want to reverse it. So we are putting this text, whatever text you want to make it in a reverse order in a variable named message. Then we say here, say translated is equal to, again, open close bracket. Then we say I is equal to, we use the length method, and here we put the variable that we have created. Minus, we put it 1 because it should go till the length minus 1, that is the last character of your message, because here it starts with the index of 0. Then we say while I is more than equal to 0 colon, here you start the particular while loop. So we'll move here and we'll say translated, that is the variable that we have. Now that variable is equal to translated plus the value of message at the index of I. Okay. And then we say I equals to I minus 1. Now after this, we come to the next line and we say print the value of translate it. Okay. Now let us first save this. So for saving it, we'll go to file, say save. Let us save it in E drive, Python hacking beginner. And here we will give, say, demo1.py as the extensions for Python files. Okay. And then you can simply press F5 key if you want to run, or you can go here, and here also you can say run module. So once you say run module, you can see whatever text we have written, everything is coming in a total reverse way. Okay. Now, suppose you want to decrypt the text that we have already encrypted. So over here, what we will do is, we will copy down this text. Okay. Say right click, copy. Okay. Then we will go back to our program, and over here, now in this message, okay, in this line, we will paste it. Okay. Now let's save this again and let us run the module again. So again, this is how we have decrypted it. Okay. So in the first program, we have encrypted that. In the same program, just copy pasting the encrypted one in the message one, we have decrypted it. Okay. So in this basically way, we are making a short of a thing like we are hacking using Python by encrypting it and again by decrypting it. Okay. Okay. So now let's go to the program back here and let's understand what have we done this. Over here in the first one, that is we have the message variable. So whatever text you want to encrypt or you want to decrypt as a new string, we have placed it inside a message variable, and the translated variable is where our program is basically going to store the reverse string, right? So at the start of the program, the translated variable over here is blank. So it is having no string. It is just two single quote marks and not double quote. So you don't mean that this is a double quote. It is two single quotation marks. Now to find the length of a particular string, we have used here the len method, which is basically used for assignment statement storing a value in the variable I, and that value is nothing but the length of the variable message. So the expression that is evaluated and stored in the variable length message -1. The first part of this is a function, that is length function, and which accepts a string argument, just like we have this print, which is accepting a message argument into it. Okay. So when we create this particular variable, we get the integer value of how many characters are there in a particular string. That is, for us, it is in the message variable. Okay. Now we can also use this length function in a very interactive shell, for example. Now let's just go here to the shell here and we write down just len and we say hello, for example. We get there the length as 5. We say, suppose len, just open close bracket. We don't give any text in between. So we get their length as 0. Or we say a variable, say spam is equal to al. Okay. Then we say len is equal to the variable spam. Okay. We get the length as 2. Or we say in length variable, we open double quotes, we say hello, 1 text, let's give here a comma. Then we add there a space. We concatenate there with the variable world. Okay, and we close it. So here we get the length as 13. Okay, so from this particular return value, we know that the particular string that we have given in the bracket is having how many characters in it. Okay, a blank string will have a 0 character. So if we store any value apart from a blank value, you will get exactly how many length you are storing in a particular given string in that your function of length that we are using. So after this particular function that we have used, the next thing we run is we run a while loop here. Okay. So over here we have given an instruction to Python that a while loop or a while statement is basically made up of 4 parts. You can say the first is the while keyword that we have. Then we have the condition, that is I is more than equal to 0. Then we have a colon symbol after that, and the block of code which will execute if the while condition is true. That is, you will pass the value of, okay, so here a condition is basically nothing but an expression which is used in your while statements, and the block of code in the while statement will execute as long as the condition becomes true. So to understand while loops, we will need to first learn about booleans, comparison operators and blocks. So coming to the boolean data type, basically boolean has only two values, either a true or a false. Now these boolean values, or the bools we call, are case sensitive. So you always need to capitalize the T or F while leaving the rest in the lowercase. So they are not string values, so you don't put quotes around the true or the false value. Okay. Now, for example, if you want to try out something, we can say, for example, spam is equal to true. Okay. Now, if you want to print the value of spam, you will get the value true. Or if you say spam is equal to false, again you print the value of spam, now you get the value as false. Right? So like a value of any other data type, bools can be also stored in the variables. So in our case, we have used the comparison operator, that is more than equal to. Okay, so here the expression that basically follows the while, that is I more than equal to 0, contains two values, the value in the variable I and the integer value 0 connected by more than equal to sign. Okay, now this is basically also called as greater than or equal to operator. That is also a comparison operator. Now we use the comparison operators to compare two values and evaluate to true or false. Okay, that is, it either the condition might be true or the condition might be false. You might not have any other value for it. Okay, so some other comparison operators that we have are your less than sign. Okay, now for example, okay, let's see here. For example, we say hash and we write down here, say more than. This is less than. Then you have more than. You have less than equal to, more than equal to, double is equal to is for equal to, and not equal to for negating it. Okay, so these all are your different types of comparison operators which you have. Now we can check this expressions by entering them directly into the interactive shell to get the boolean values which are evaluated. For example, if we say over here, say 0 is less than 6, we get the value as true. Or we say 6 is less than 0, we get the value as false. Or we say 50 is less than, say, 10.5, we get again false. Say 10.5 is less than 11.3, we again get the value true. Or we say 10 is less than 10, again it is false. Right? So here it will just evaluate by what values you are passing on, if they are less than or equal to a particular value. Similarly, if you check for less than equal to, say 10 is less than equal to 20, will be true. But if we say 10 is less than equal to 10, will be also true, because it is not less than, it is equal to. Right? Similarly, 10 more than equal to 20 is false. Or 20 more than equal to 20 will become true. Right? So over here, we have noticed that 10 less than equal to is true, because the operator here checks if 10 is less than or equal to 10. So it is not doing, it should be less than or equal to. So either if it is not less than, but if it is even equal to, it will give you the value as true. Right? Now similarly, we can also check for some equal or not equal operators. So like if we say 10 double equal to 10 will be true. But if we say 10 double equal to 11 would be false. Or 11 double equal to 10 will be also false. If we say 10 not equal to 10 will be false. But if we say 10 not equal to 11 will be true, because 10 is not equal to 11. So that expression comes to true. Right? So this is basically just the ways we have given you that how the values would be evaluated when you look it into your interactive shell of Python. Okay. Now these operators basically work as you would expect for integers. Now comparing integers that are equal to each other with a double equal to operator evaluates as true and unequal values as false. Now when you compare with a not equal operator, it is the opposite. Now these comparisons of operators work similar with strings also. For example, if here we say HELLO, hello, if that's equal to, again HELLO in the same case will give you true. But if you say HELLO, hello is equal to, say, goodbye, then will give you false. Or for that matter, if you even try to say 1 in a first letter capital then small, the second one in a whole capital will also give you false, because this is case sensitive. So for it, a small e and a capital E is different. Right? Similarly, if you say goodbye, is not equal to hello. This will give you true because they are actually not equal to, right? So here only the capitalization matters to Python. So string values that don't match the capitalization exactly, not the same string. For example, the strings like we have done hello and the capital hello, right? So over here, we also have the difference between the assignment operator and the equal or the comparison operator. That is, if for example, like in the while loop we have done, if we go back to the program over here, see, this is an assignment operator where we are assigning a particular value to I, right? But over here, we are putting a value in the variable. Okay, like in this particular shell, we are trying to do this is or this double equal to. This is for equality and a single equal to is for your assignment, right? So both are different. Okay. Now some similar examples for assignment, if you want to check number with a string, will also give you false. But if you try to do it something like 42, suppose, equals to 42 but in a string format, will be also false because one is integer, another one is string. But for that particular matter, if you say 10 double is equal to 10.10, will give you true, right? So even though they look like integer 42 and string 42, they aren't considered as equal because a string isn't the same as a number. Whereas integers and the floating point numbers can be equal to each other because they both are numbers, right? So when you're working with the comparison operators, just remember that every expression always evaluates to a true value or it would be a false value, right? So after this, we would just go on ahead and we'll go through the loop statement that we have. So if we come back over here, after we have done with this, we go in the loop statement wherein we are putting the value of the translated plus the value of message I into the variable translated and decrementing the value of I variable there. Okay, so here a while statement tells Python to first check what the condition evaluates to, which is basically like we are saying I is more than equal to 0. You think that the while statement while I more than equal to 0 as meaning while the variable I is greater than or equal to 0. So keep executing the code in the following block. So if the condition evaluates to true, the program execution will enter the block following the while statements, and by looking at the indentation, that is after while we have given this indentation, if you can see, which means these two statements are a part of this while loop, right? So when it reaches the bottom of the block, program executes or execution jumps back to the while statement, okay, and checks the condition again. So if it is still true, again the execution will jump into the start of the block and run the code in the block again. If the while condition evaluates to false, only then the program execution skips the code inside the following block and jumps down after the line, that is after this line, and will come over here and will give you the printed result there. Okay. So now keep in mind that the I is equal to length message minus 1. The I variable is first set to the length of the message minus 1, and the while loop on the next line keeps executing the lines inside the following block until the condition I becomes more than equal to 0 is false. Okay. At the end, when we say over here, it is basically an assignment statement that stores the value in a translated variable, and the value that is stored in the current value of translated concatenates with the characters at the index I in the message variable. So as a result, the string value stored in translated automatically grows one character at a time until it becomes a fully encrypted string. Okay, so over here when we say I equals to I minus 1, we are taking the current integer value in I and subtract 1 from it. Now this basically also known as decrypting the value of the variable. Okay, when it stores this value as a new value of I. Now here we have made this. Okay, so after this we have made this blank, so that we are saying this loop ends here and this becomes again from indentation starts from the start, which means now we are again going to go for a next execution of line, that is a print statement. So when this loop execution completes, at the end we get the result printed over here. Now let's think about the behavior of the loop to understand how many times it runs the code in a block. Now the variable I starts with the value of the last index of message and translated variable starts as a blank string. Then inside the loop, the value of message I, okay, that we are storing is added to the end of the translated string. Then the value of I is decremented by 1, meaning that the message I will be the second to the last character. So when I as an index keeps moving from back to the front, the string is added to the end of the translated variable. So this is basically how the translated ends up holding the reverse of the string in the message. So when I is finally set up to -1, which happens when we reach the index 0, and the while loop's condition becomes false, the execution jumps back to the print statement then. Right? Now, suppose you are having trouble understanding how the code in the while loop reverses the string. We will try adding some new lines of code in the loop block. Okay, what we would do is, in the loop block, while we are saying I is more than equal to 0, we are saying translated. Okay, after this particular line, let us add one more line here, giving print. Here we say I is, comma, print the value of I here, give a comma. Then again we give, say, okay, here we again say message, message at the index I is, we close this, then we print the value of message at the index I. Then again we open single quotation marks, we say translated is, close this, and we print the value of translated here. And then we have this I equals to I minus 1, then we print the value of translated. Okay, now let us save this and run the module again. So now here you are saying how many times we are getting this. First T is added. So message I is having T, translated is having T. Then message I is having H, translated is having H. Then it is having I, it is also having I. So one value is keep on adding over here. Okay, so at the end of it, what is the value in this? This is Python hacking session 1. We are doing the reverse cycle, right? So whatever text we were having it there, one by one, we are adding it in this reverse order. One character by character is getting added if you get the output. So now we hope that the output is very much clear, that how many times the loop basically gets executed, right? Okay. Now let's go ahead for improving this particular program by giving it a more input prompt. Okay, now the program what we have designed over here is having a string that is being encrypted or decrypted, which is typed directly into the source code as an assignment statement, right? Now this is convenient while we are developing the program, but you shouldn't expect users to be comfortable modifying the source code themselves. So to make the program easier to use and share, you can modify the assignment statement so that they call the input function. You can also pass a string to the input function, so it is displayed as a prompt for the user to enter a particular string to encrypt. Okay. Now, for example, if we go back to our program, okay, over here, when we are giving this message, we would remove this particular text which is appearing here. Okay. And here we would give, say, input. In bracket, we say single quote, say enter message to encrypt. Okay. After this, we get this value in the message variable. Now we will not give this print command as it will just increase the line of code. Then finally we will decrypt this over here. Okay. So now when you run the particular program, it prints on the prompt to the screen that waits for the user to enter the particular message. The message that user will enter will be stored as the value in the message. And then when you run this program ahead, you will get that string to be encrypted. So let us save this and let us try to run this particular program. So now here it asks for us to enter the particular value, right? Now suppose we enter, say this is Python hacking. So whatever string you have entered, the same string it is reversing and giving you the output. Now for example, you want to enter this string. So let us copy this and again we'll go back here. We will run the module. Now we'll paste the same string that was encrypted to decrypt it. So we press enter. Again we get the string in a decrypted format, right? Okay, now let us try one more piece of code directly over here. We say print in bracket. We use the length function. We use here say Python. Again we use a plus operator. We use length. Again we give Python and we close it. So we get the length as 12. That is this 6 characters plus we have already added one more 6 characters. So total of this becomes as 12. So a length of this plus the length of this, we are getting it over here printed, right? Similarly, if suppose we say, for example, say I is equal to 0. Okay. We say while I is less than 4. Then we are saying print say Python. Okay. And we make I equals to I plus 1. Okay, so when we type this, we just press once more enter, we get the value printed 4 times, right? Similarly, suppose we try to do I is equal to 0. We say another variable is equal to say Python. We say while the value of I is less than 5. Then, okay, let's do one more thing. While say I is less than 5 colon. We have missed the colon part. Then we say span is equal to spam plus spam at the index I. Okay, we are again adding this value there. We say I equals to I plus 1. Then here we say print the value of spam. Say print spam. So here we see getting one value added. First thing is we had Python. Then in that we are adding one character of this variable over there. So first time it is added P, next time Py, then Pyt, Pyth, Pytho, and then we have, since we have gone till 5, N is not added. If suppose, let us copy down this and here we will change this to 6. Okay. Now, so here it is added all the values total at the end of it because it is going for 6 times, right? So now we'll see some extra examples. We will do it on reverse cipher, which will make our concepts of reverse cipher very much clear. So now we will move on with the extra examples of reverse cipher. So over here, first thing is we will go for a new file and let's write down here, start with say a message. Now here we are going to input from the user saying, say what would you like to do? Question mark /n for a new line. Here we put the text first encrypt, or on a new line we put the text decrypt. That is, we are asking the user what the user is willing to do. Either he wants to encrypt the text or he wants to decrypt the text. Okay. Then we say here if the message variable is equal to encrypt. Okay. Then we would say print in bracket, say your message will be encrypted, and then you ask for the user a message by again putting an input saying enter your message here. Okay. Then you take a variable say x1 and that is equal to, you put the value of message there. Then we take another variable say translated equal to open close single quotes. We check I is equal to the length of bracket the variable message minus 1. Then we run a while loop till I is less than equal to 0. We open the loop. We say the variable translated is equal to translated plus message I. Then we say I equals to I minus 1. And we just go back 1 and we print here the value of translated variable. Then we put the code for decrypting it. Now this code basically that we have given is for encrypting it, right? So we go back and now we go for else if part, and here we check if the user have entered initially the value not encrypt but decrypt. Okay, then in that case we are asking the or printing the value, say your message will be decrypted /n. Here also let's give a /n. Okay, and then we use another variable, say message2, that's equal to, we again give here input, we say enter the encrypted message, okay, which you want basically to decrypt it. Okay, then we take y1, that's equal to, say message2, and again say translated variable which is initially blank, we say I is equal to, use the length function but this time for message2 -1, and again here we say while I more than equal to 0, there is no need for a bracket here, I is more than equal to 0 colon, here we put translated is equal to translated plus the value of message 2 at the index I, then we say I equals to again I -1, and after which we print the value of translated variable. Okay, so let us first save this, and we save it in Python hacking beginner, name say demo2.py. okay, and if we want to run this, we just go to run and say run module. Okay, here we are checking for equality, so it has to be double equal to. Okay, so it asks for the text. Now we say here write down encrypt. Okay, it will ask for a message, we say this is Python reverse cipher. It goes on in a total reverse one. Again, suppose you want to execute it, so we go back here, we again run this module, and this time we put it that we want to decrypt it. Okay, and now we just copy down the text that we have already encrypted and we get it in a decrypted format, right? So in this way, another example where we are asking a user what is he wishing to do. Depending on the user input that he has given, we either execute the value for encryption or we execute the value for decryption by taking the message also from the user and then encrypting it or decrypting it. Now let's see another example. So we will close this and let's go for a new file. And here we would first define, say encrypt message. Here we will take the parameter, say str and some key value, so say key 1 for example. Okay, now here we are going to use, say encrypt string as a variable, that's equal to just a blank one, no value for it. We run a for loop for I in say str and we open the for loop. Here we check in the if. Now you know what is this ORD function used for, finding the Unicode character for a particular variable. So here we are finding it for I. Okay, if that is more than equal to 65, and we give ORD for I if that is less than equal to 90. If this condition satisfies, then we have there another temp str variable which is equal to, we are saying ORD at the index I plus the key value that you have given, that is key 1. Okay, after this we check here if say the temp str, okay, if that is more than 90, then we take temp str equals to, say temp str percent, say 90 plus we make it 64. Okay, so if it is in a smaller case, make it to uppercase, make it to smaller. Then we come one back and here we say the variable enc string that we have taken, that is equal to say enc string plus use the chr for your temp str. Okay, then we go on for one more back and we go here for else if part, and here we check if it is ord at the index I, if that's more than 97, and your ord at the index I, again we open the bracket here, if that is less than equal to say 122, then you will again say here say temp str is equal to, we use ord at the index I plus the value of key 1, and we check if your temp str is more than 122 colon, here we take temp str equals to temp str percent 122 plus 96, and then we say the enc string variable is equal to enc string plus convert to character of temp str. Okay, now after this we move on here and go for the else part, which means none of the above conditions are true. Then we say enc string is equal to enc string plus the character value of ord at the index I plus the key value. Okay, now after we have done this, we have to simply say return enc string value. Now there is another definition that we are defining. Now this was for encrypting. Now we have for say decrypt message. Here we take only the value of key. Okay, and in this particular definition we take a variable, say ptr is equal to, we call the encrypt message here, and we pass the value of str comma key 1. Okay, so whatever value is being returned by this function is stored in the value of ptr. Then we have say decrypt or dec string. Okay, like we have the enc string, we have say dnc string. Okay, and this is also initially equal to blank. We run a for loop, say I in the value of ptr. Here we check if ord of I more than equal to 65, close the bracket, and ord of I is less than equal to 90, then we are going to say here the variable dnc string is equal to say dnc string plus chr in bracket say ord at the index I minus k minus 65 percentage 26 plus 65. Then the next else if part, here we will be saying say ord at the index I more than equal to 97 and ord at the index I less than equal to say 122. Then we say dnc string is equal to say dnc string plus the value of chr, get the code of I. Okay, after which we say minus k minus 97 percent or modulus 26 plus 97, close the bracket, go for the else part here and use dnc string. Now that's equal to dnc string plus chr of the ord index I minus the key value. Okay, that is key 1. Okay, so here we missed this, it is key 1. Okay, so after we have done this if, else if and the else part, okay, we go back here and say here return the value of dnc string. There we end this particular function. Then we move on for print we ask here enter the string to encrypt and decrypt. Okay, then we take here string 1 is equal to, we call the input and take the value there. Then we print, say the value as enter the key, and we give here say example 11. Okay, you can give anything, just a value which you want to input it. Then we take here say key p is equal to, convert to integer the value of input. Okay, then we check if your key p is equal to key p modulus 26. Okay, and we give here print say encrypted string and close the double quotes. Here we call the function that is encrypt message. So let us copy down this here, and here we pass the value that is string 1 and key p. Okay, similarly next we give here decrypted string colon, and here we call the function that is decrypt message. Here also we just pass the value of key p because string is not required. String is already taken by the encrypt function, right? So with this we save this. Okay, so let us save it in E drive, same folder, say demo3.py, and we save it and we try to execute this. So enter the string you want to encrypt decrypt. Say this is Python hacking session 1, and some examples, say we enter here 12. Okay, fine, let us check this. Okay, we have made here a silly mistake. This also has to be the same. Say str, we are taking the input there and passing the same string in the encrypt message. So now we save it and we run the module. So now we say this is say Python hacking session 1. Okay, any key you want to enter. So taking that key, it has encrypted a particular message and it has decrypted. So we have just not reversed it, but now we have also encrypted it in a proper format and we have also decrypted the same text in a proper format. Okay, so that is how we have done this encrypting and decrypting option. Welcome to the next session in our Python hacking course, that is about Caesar cipher. Now, the Caesar cipher basically uses the keys which encrypt a particular message differently depending on which key is used. Now, the keys for the Caesar cipher are basically integers from 0 to 25. Now, even if a cryptanalyst knows the Caesar cipher was used, that alone doesn't give them enough information to break the cipher. Now, in this particular session, we would be covering the import statement, how to use it, how to use constants, the for loop, the if-else and the else-if statements, the in and the not in operators, and also the find method of the string method. Now, we would be creating a Caesar cipher program first in the new window, and we would be saving it by a particular name, say caesarcipher.py. But for this particular program, we would need to download the paperclip.py module and paste it in the same directory. So we will import that particular module in the caesarcipher.python program, and then later on we will see how to execute it. So we would first start by creating the program. Now, just for your understanding, I will show you that we have already downloaded this paperclip.py, which is a Python file. And this file we are going to import in our current caesarcipher.python program. So over here, we'll go for a new file. And in this particular file, we will first start by saying import paperclip. Now .py is not necessary as it is a Python program itself. Now after this, we would create a string variable which will have a particular message stored into it. which can be encrypted or the same can be decrypted. So we will take here the variable name as say MSG string, and that's equal to, we will give, say this is Caesar cipher program, and this is our message. Now after this we will give a key which will be also used for encryption also and for decryption also. So let us give here a key, say code, that's equal to, we give for example 30. Now we will give here whether the program will encrypt or decrypt. So here we are giving mode type is equal to, in single quote we are giving the text as encrypt. Now this you can either set it, we are putting it in a comment that says set it to YPT encrypt or decrypt. So depending what do you wish to do, you paste the particular given text in the variable mode type. Now after this we are creating one symbol variable which is going to store all the symbols, capital, small case and numbers. So we will create here say symbols type, and that's equal to, in single quotes we will save OPQRSTUVWXYZ, all in capital, now again in small. So ABCDEFGHIJKLMNOPQRSTUVWXYZ, and now 1 2 3 4 5 6 7 8 9 0. We'll give here an exclamation mark, question mark, a dot and end the semicolon there. Okay, so after we have given all the values here, now the next thing is we will store the encrypted or the decrypted form of a message in another variable. So for that we would take here say translated str, which is initially equal to blank. We are not storing there any values initially. Now for the symbol in a particular message we will run the particular loop and we will check. So now here we will run for say, so here we will be using say SYM in our MSG string. Put a semicolon, so our for loop starts here. Now in this we will check the if condition, that if the SYM in our symbols type. Another condition over here. Now we are going to create here say SYM index, that is a symbol index, is equal to symbols type dot find in bracket SYM. Okay, now we will perform the encryption or decryption option. So over here, so just below this we will check if, say let's take our mode type, if that is equal to, now this is double equal to because we are going to check for the equality, that if the value in that mode type is equal to encrypt. If it is encrypt, then we are going to say the translated, say translated IDX. Now that's equal to, we are going to take here say SYM index plus the value of key code. Now after this we'll go one step back and go for else if, that if our mode type is not equal to encrypt but it is equal to decrypt. Okay, then we are going to say translated IDX is equal to our SYM index minus the key code. Okay, now we will handle here the wraparound if needed. So over here we will go again one step back and we'll check if our translated IDX, if it is more than equal to the len of, using here symbols type, then we will say the translated IDX is equal to translated IDX minus the len of symbols type. And again, else if part, if your translated IDX is less than 0, then we will say translated IDX is equal to translated IDX plus the length of symbols type. So after this, we will go one step back and say translated str is equal to translated str plus symbols type, and in bracket we will give here the index as translated IDX. Now we'll go for the if else part for the upper if condition, and over here we will append the symbol without encrypting or decrypting it. So here we'll say translated str is equal to translated str plus the value of your SYM. And once we have done this, let's go directly here and we will give here a print command, and in print we will print the value of translated str. Now we'll use here paperclip dot, we use the copy method, and here also we put translated str. Now let us save this. We will save it as Caesar cipher.py in the program that is in E drive hacking, and save it. Okay, so now to run this, we'll directly go to run and say run module. So this is what we are getting the encrypted string as. When you run the particular program, whatever text you have written, it is basically encrypting. So the output of the string, that is, this is Caesar cipher program and this is our message, this particular text, we are basically encrypting using the key 13. So the Caesar cipher program just run automatically copies this encrypted string to the clipboard, and you can paste it in your email or the text file also. So as a result, you can easily send the encrypted output from a particular program to another program also. So now basically to decrypt the message, you can just paste this same message that is been encrypted over here, say in this particular part. Let's remove this, paste it here, save it, and now we run the module. What mistake did we do? We did we did not change here from encrypt to decrypt. Okay, only when we say to decrypt, it would be decrypted. So now if you say decrypt, it is a Caesar cipher program, and this is our message. This is what output we get when we change the value of the message str variable, and in the mode type we change it to decrypt, right? So now basically we come to the importing of module and setting up some variables. Now we already have some built-in functions in Python. Now some function exist in separate programs called as modules. Modules are basically also your Python program that contain additional functions which your program can automatically use them. So we can import those modules with an appropriate name, that is an import statement, which consists of the import keyword followed by the module name. Like in this case, here we have told that import and the module, that is paperclip, right? So now over here we are importing this module so that we can call the paperclip.copy function in the particular program. So as we are using here this paperclip.copy, if we don't import this, we are not authorized to use this particular statement here. Now after this import, the next few lines in our program, we are basically having the MSG string variable, we are having the key code variable which is having the value given as 30, and we also have the mode type which is encrypt. You can either set it to encrypt or decrypt. Now here the MSG string, it basically stores the string that is to be encrypted or decrypted, and the key variable, that is our key code, stores the integer of the encryption key, right? So the mode type variable over here stores the string encrypt or decrypt, which makes either the code later in the program, that is encrypting a string or decrypting a string. Now coming to the constants and the variables that are used in this program. Now constants basically are variables whose values shouldn't be changed when the program runs. Now for example, in the Caesar cipher program, we need a string that contains every possible character that can be encrypted with this program. Now because that string shouldn't be changed, we store it in a constant named symbols type, right? Now one more thing over here, we will make symbol type like this, and let's copy it everywhere that we have used the particular variable. Now I'll show you what is the use of this, but okay, let's save this and run again. Okay, fine. So now over here you can see the variable that we have taken. It is basically just a common term which is used in a cryptography for a single character that is a cipher can encrypt or a decrypt. Now a symbol basically is a set which is every possible symbol a cipher is set up to encrypt or decrypt. Now because we will be using the symbol set many times in this particular program, and because we don't want to type the full string value each time it appears in the program, we are using here a constant to store the values. Now why have we changed it to all uppercase? Because whenever we use any variable name all in uppercase, it means that we are using it as a constant. So the value once assigned will not be changed. It is just like any other variable that all uppercase name reminds the programmer that do not write the code that does so. So as with all the conventions, we don't have to follow this one, but doing so makes it easier for other programmers to understand how these variables are basically used, right? Then we take a blank string variable that is translated str, which is just having a blank value into it, which will be storing the translated value in the given variable. Now for it, currently we are giving it a blank value itself. Now we come to our for loop statement over here. Now we are using this for SYM in our message or MSG string. We recall that a while loop will loop as long as a certain condition is true, and also the for loop has a slightly different purpose and doesn't have a condition like the while loop. Instead, it loops over a string or a group of values. So for every value in MSG string, the SYM will go on executing itself, and each time the program execution goes through the loop, that is on each iteration through the loop, the variable in the for statement takes on a value of the next character in the variable containing a particular string. In this case it is MSG string. Now for the for statement is similar to an assignment statement because variable is created, assigned a value, except the for statement cycles through different values to assign the variable. Now let us see a simple example of a for loop. We'll just go to the interactive shell over here and we will type the particular for loop saying say for letter in say happy. Here we are saying print in bracket the letter is plus the value of letter. Okay, so here we get each and individual value of the particular character getting printed at the end of the line. So this particular loop gets, or the code loops over each character in the string happy, and when it does, the variable letter takes on each of the character in the string happy one at a time in order. So we can just rewrite the code in the loop that prints the value of letter for each iteration. Now again similarly, we'll understand a while loop equivalent to a or for a for loop. The for loop is very similar to a while loop, but when you only need to iterate over characters in a string, using a for loop is more efficient, and you could make a while loop act like a for loop by writing a bit more code like this. For example, we say I equals to 0. We say while I is less than the length of say happy colon. Okay, we open the while loop here. Here we use letter that's equal to say happy. at the index I. We use here print in single quotes the letter S plus the value of letter, and we say I equals to I plus 1. So here again we get the same values printed over here using the while loop. So notice that this while loop works the same as we had the for loop, but is not as short and simple as the for loop, the one which we have written above. First we need to set a variable, that is I to 0 before the while statement. Then the statement will have a condition that will evaluate to true as long as the variable I is less than the length of the string happy. Because I is an integer and only keeps track of the current position in the string, we will need to declare a separate letter variable to hold the character in the string at the I position. And then we can print the current value of the letter to get the same output as the for loop. So when the code is finished executing, we need to increment also the I by adding 1 to it to move it to the next position, right? So it is better for us to use the for loop in case of while loop over here, because we will make it a more shorter and a smarter loop which we can write down in our particular program. Now we move on to our next part in the program, that is coming to the if condition. Here we are using if SYM in our symbol types. Now you can read an if statement as, say, if this condition is true, execute the code in the following block. Otherwise, if it is false, skip the block. An if statement is formatted using the keyword if followed by a condition followed by a colon. The code to execute is indented in the block just as with the loops. So for example, we will try an if statement and see how does it basically work. Say we'll go back here and we will say print, say enter your password. Rather, we made a mistake here. Say print, enter your password. Okay, but now we basically need to write down in a separate file as we need to execute this together. So what we would do is, let's go for a new file and here we would write down, say print, enter your password. Then we will create here, say password input is equal to, use the input method, store whatever password the user have typed over here. Check if the password input is equal to a particular password, say admin123 for example. If it is, then you print here, say access granted, and use here print, say done. Okay, so now we save this. Let us save it again in E drive hacking beginner, and we save it over here by the name, say check password.py, and we try to execute this. So enter password. Now we enter A capital. We had given there A small. So it is not giving us the access granted. It is just giving us the value done. But suppose we go back here, we again run the module. We enter here now admin123. It says access granted and then the statement as done. So when you run the particular program, it displays you first the text that is enter your password and lets the user type the password over there. Whatever password is then typed by the user is stored in the variable that we have created, that is our password input, right? Next, the if statement checks whether the password is equal to the string that is admin, all in small case, 123. If it is, the execution moves inside the block following the if statement to display the text as access granted. Otherwise, if the password input isn't equal to admin123, even if the case is wrong, that is A capital admin or something like that, the execution skips the if statement block either way, and the execution continues on to the code after the if block to display just the statement as done, right? Now similarly we will see what happens if we use the else statement over here. Okay, now often we want to test a condition and execute one block of code if the condition is true, and another block of code if it is false. We can use an else statement after an if statement block, and the else statement block of the code will be executed if the if statement's condition is false. Now for an else statement, you just write down the else keyword and a colon. It doesn't need a condition because it will run if the condition in if statement isn't true. So you can write the code as, say, if this condition is true, execute this block, or if it is false, execute the other block. So now we will modify the same program, which will look down something like, say, after the if part and after printing print access granted, we will go back once and here we'll use else colon, and here we will print, say, access denied in single quotes. Rest everything would remain still the same. So now let us save it and let us run this again. Now again we enter something wrong. We entered A as capital. Now it is printing access denied and then done. So this version of our program that we have written works almost the same as the previous. Only thing is the text access granted will still display if condition is true. But now if the if condition is false, that is if the user types other than something like admin123, then the if statement condition becomes false, causing the execution to enter the else block and display access denied. Either way, the execution will still continue to display the message that is done because it is going to execute after the if block. Now similarly, we will come to the else if statement. Now another statement, that is else if, can also be paired with if. Like an if, it has a condition. Like an else, it follows, that is if it is false, then you go to the else part. You can also read if like else if and else statement as, if the first condition is true, run the block of if, or else check if the next condition is true, or else just run this last block. So any number of else if statement can follow an if statement. Now what we'll do is we'll modify the same program which will make it look something different. We'll first enter the password, store it there, access granted is proper. Then after this we will check for else if, and here we will give, say, password input if it is equal to either a capital admin123 colon. Here also, say we are giving print, say, hint the password is in lower case. We are giving some hint to the user. Similarly, we use one more else if your password input is equal to, we write down only, say, 123. Here we give a hint again saying, say, the password also contains a string in lowercase. Okay, just a hint to the user. Then this is the second else if part that we have given, and then we have the next else as, say, password as access denied. So now over here, let us save this and let us try and execute. Now we first add there, say, admin123. It says hint the password is in the lowercase. Okay, again let's go back, execute it. We enter just 123. It says the password also contains a string in the lowercase. Fine. We enter over here all in small, admin123. Fine. Access granted. Again we execute. We enter something different. Now say admin123. It says access denied because now this is going in neither of the if, else if, or either the second else if part. So now in this particular code we have 4 blocks of if, else if, and the else statement. If the user enters, say, only 1, 2, 3, then the type password evaluates to false, like over here. So this evaluates to false, even this one evaluates to false. It goes to the next else if and prints the particular message. Similarly, the execution for this goes to the last else if part over here. Now you can have even 0 or more else if statements following an if statement. If you have a 0 or 1 but not multiple else statement and the else statement always comes last, because only executes if none of the conditions evaluate to true. The first statement with a true condition has its block executed. The rest condition, even if they are also true, aren't checked. So in the first case, if this condition comes to true, that is if you enter admin123, you will get access granted and done printed. So these all conditions will never be checked. But if this is not true, it will go on for checking for the second condition. Suppose you had entered a capital admin123, then this becomes true. Then this block of code, that is the print, executes and the print done executes. Similarly, if this is also not true, else if is also not true, the third else if is true, this block gets executed. If none of the if or else if are true, this else part gets executed and the print done gets executed. So in this way, we have created or we have seen how the if, else if and else block, or how if and else block execute, and what are the outputs that basically are coming when you execute a certain given conditions there. So now moving to the next one. Now the next, let's first close down this particular program and go back to our Caesar cipher program. Over here, the next statement we have is using if SYM in our symbol types. Now an in operator can basically connect your two strings and it will evaluate to true if the first string is inside the second string, or evaluate to false if not. So the in operator over here can also be paired with not, which will do the opposite thing. Now just to have a look at what can we do, just we'll go to the interactive shell over here and we will type, say for example, here let's type in single quote, say Python in, say Python hacking, and over here we press enter, we get it true. Suppose we say Python not in, again Python hacking, we get false. Or we say here Thun in Python hacking is true, or we get just a blank in, sorry, this is also Python hacking is also true because we have there a space. But if we just write down this part, say in Python, will also give us the value true. So notice that over here we use in and the not in operators, which are case sensitive. So also a blank string is always considered to be any other string. So expression using an in and not in operators are handy to use as conditions of if statement to execute some code if a particular string exists inside another string. Okay. So now returning to our program back here, we check that whether the string, that is symbol type, is in our symbol string, or the SYM is in our symbol string. So if the SYM is in our symbol type, particular variable, the execution enters the block that follows after the particular line after the colon symbol. And if it isn't, then the execution skips to the instead enter the block of the else part over here. That is, if this is not true, then this whole thing will be skipped and will be gone to the else part. So the cipher program needs to run different code depending on whether the symbol is in the particular given symbol set. Now here we are also using another method, that is find. Now this find the index of your symbol type string where the symbol is or the SYM is. So over here we are saying the SYM index is equal to in the symbol types dot find the index of SYM. Okay, so this basic code includes a method call. Methods are just like functions except they are attached to a value with a particular period. The name of this method is find and it's being called on string stored or string value stored in your symbol type. Okay, so most data types like strings have methods. The find method takes one argument that returns the integer index of where the argument appears in your particular method string. Now just to find out this find in the interactive shell part, we'll go back there and here we will write down something, say Python dot say find, in bracket we give say y. Okay, so the index of y is 1. Similarly we say say Python dot find, in bracket we use here say O. So the index of O is 0. For example, we use here span variable that is equal to say Python value, and now we use span dot say find, we give here O. That also gives us the value 4. So now here you can see we have used find method to either on a string or either on a particular variable containing a string value. So remember that indexing in Python starts always with 0. So when the index returned by the find method is for the first character as a string, it is 0. And if the string argument cannot be found, find method will return an integer that is -1. For example, if you say, for example, in this you enter Python dot find the one which is not there in our particular string. So we get there the value as -1. So again here you can notice that find is also case sensitive. For example, if you try to do something like say Python dot find, we give capital P. We are having small p but we are giving there capital P. It again gives us -1. So if you pass something which is in a different case, again you will not get the value found with the help of find method. So the integer that find the return or finds method returns will be an index of the first character where the argument is found. Okay. Now again, for example, we say Python and here we use say find, in bracket we give here ON, but it finds for the first character, that is O. So O is also 4 itself, right? Similarly, suppose you use here Python dot find, we give here P, which is coming actually twice, but it will give you the first appearance, that is the 0th index, the first character. Okay, so the find string method is like more specific version of using the in operator. It not only tells you whether a string exists in another string, but also tells you whether it is there at a particular which position. So encrypting and decrypting the symbols. So now let's go back to our Caesar cipher program, and over here we have understood the if part, the else if part, the else part, and also the in operator and the find string method. So now it is easier for us to know how the rest of the program works. The Caesar cipher can only encrypt or decrypt symbols that are in the symbol set that we have given, that is over here. Okay, so before running the code, the program must figure out whether symbol is in the symbol set that you have created. Then it can find the index where the symbol is located, and the index returned by the find is stored in a particular symbol index. Now that we have the current symbol index stored in the variable, we can do the encryption or decryption on it. So the Caesar cipher adds the key number to the symbol index to encrypt it or subtract the key numbers. Now for example, if you say the value stored in your translated str or the translated idx variable, it is the index of your symbol type of the translated symbol. So after this, depending on your mode type, if it is encrypting, we are adding the key code value to our index, and if it is decrypting, we are subtracting the key code value which we have, that is 13, from the symbol index. And then we are checking here if it is more than the length of our symbol, then you are subtracting the values. If it is less than 0, that is if it goes in the negative part, you add the value of symbol types. And at the end, you are simply printing the value of what is the translated str of your values. So if over here, suppose you are giving there the values, that is, and we are also copy down the same text that is being printed using our paperclip.copy method. Okay, so in this way, we have seen how the particular program executes from the start till the end. Now let us create a new file, and here we will see some more examples on Caesar cipher. So we are going to basically define here a method, say encrypt text, which will take the parameter as text str and say scode variable. Now in this particular method, we have a result str which is equal to initially blank. We run a for loop, say I1 in the range. We use here len for the text str, and we use a char str is equal to text str at the index I1, and we check if the char str dot is in uppercase, then we say the result str plus is equal to convert to chr, use ord, say char str plus say scode minus 65. Okay, then modulus 26 plus 65. Now if this is not true, we go for the else part and we say the result str plus is equal to, use again chr, the ord of char str plus scode minus 97 modulo 26 plus 97. Now after this we say here the value as return the result str from the function, and once that is done we end our function. We take here a text str is equal to, we give here a value as say Caesar cipher extra example in Python hacking. That is our text that we have given, and we give the value of scode is equal to say 5. Okay, then we use print, and here we say the actual text is colon. We use here the value as text str to print the actual text that is being given. Then we use another print method. We use here say the shift pattern code is, and we print here the value of converting to str of s code, and then finally we say the cipher text colon, and the value of, we call here now encrypt text, which is a method. In this we pass the text str comma s code, and whatever the value would be returned will be printed over here. So let us save this as, now we have to again save it in Python hacking beginner. Let us save it as demo 4.py. okay, and if we have to run this, we go for run module and we get this particular actual text that has been given, and using this code 5 we have encrypted this in a cipher text pattern that is shown here, right? So with this, another way in which we can use the cipher code. Now similar to this, we would use another way for our accepting the value of message. We will also see how actually it is being shifted and how we are basically printing it. Okay, so we'll see another example on the same. So let's go back here, and in the same one we say a new file. So we can close the demo 4, and in this we will create first a message text is equal to, we accept the value from input saying a new line and enter your text. After this we use a shift code variable which is converting to integer whatever the value of input, that is you're asking how many places to shift. Okay, now with this we create another method, say lower alpha str, and here we are going to store all the lowercase characters, that is say a b c d e f g h i j k l m n o p q r s t u v w x y z, all in the lowercase. And the same thing we will create another one, say upper alpha str, and we are just going to say here say lower alpha str dot convert to uppercase. So that all values would be converted to uppercase and stored in a separate variable as upper alpha str. Similarly, we are going to create here say numbers code that's equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the numerical values, our basic numerical values are stored in numbers code. So now here we will take before str is equal to, say we'll use the lower alpha str plus the upper alpha str plus the numbers code. Okay. Similarly, the after str is equal to, say the lower alpha str. In the bracket, we will use here the shift code colon, which means shifted to that many code, plus the lower alpha str. Okay, and here again we use the shift code plus, let's move on to a new line so that it is displayed proper. Upper alpha str shift code and plus the alpha str colon shift code. Again here we'll add one more line, say numbers code in bracket shift code plus numbers code in bracket shift code. Okay, now after this we say another variable, say translation str, that's equal to, we say str dot make trans, and we use here before str comma after str variable, and we use a cipher text str as our message text that we have dot use a translate method and pass in that the translation str. Now we are going to print here the values, first saying the coded message is, okay, and we'll print it over here. We'll say dot format in bracket the cipher text str to be printed. Then the next print command has again a new line, say from print here the value of, using dot format, the value of before str. Similarly print, give a space, say 2 colon, again print here, give a new line, dot format the text of after str. Let us save it as demo5.py. okay, and now if we try to run this module, sorry, we have ended with a double quote, so we have to also start it with the double quotes. Let us save it and go back to run module. It asks for a enter your text, say this is another example on Caesar cipher. How many places you want to shift? Say we give 5. Some mistake here. This is, we have used after str. I think here it is str. Fine. Let us save it, run it again. This is another example on Caesar cipher. Say 5 places. So now here you see first we have the lower one, then we have the upper one printed, then we have the numbers. Okay, and here when we are saying from A, okay, now by default we are saying shifted to 5. So when we say 5, we are shifting this A, B, C, D, E, F. So 5, that is F, will be starting from here. Rest everything will be same. So over here, when you see, if we have given example of a capital T, now what is replacing capital T? That is Y. So Y comes here. What is replacing small h? That is your M. Now, just to make it more meaningful, what we'll have to do is, we are supposed to say give it like this. Save it. And now let us run it again. Say, let's take a small one. It has shifted too many spaces. Fine. Let's see by giving 2 more spaces. 5. 1 more. Fine. And run it. 5. So now it is proper. So now see, it is capital E. What is replacing capital E? It is G. So that is coming here. If we say X, what is replacing a small x? It is C. That's coming the next character. What is replacing A? That is F. So F is coming here. What is replacing M? That is R. You can see here M replaces R. Similarly, P replaces U. Then your L is replaced by Q. And your E is replaced by J. Okay, now similarly, now this is not that it has to be in the same order. Since we have given how many characters we want to shift 5, that is how it is shifting the 5 characters and then it is being replaced. For example, we go back here and we again run this. Now this time we give the value as again same example, but now we say shifted 7. So when we say 7, the first 6 characters, that is A, B, C, D, E, F, G, these all are shifted and it starts from H. So now you can see the earlier one, the encoding way and the current encoding way will be different. So every time you replace it, if you don't print this, you're not understanding how basically it is replacing a particular character with some different character by shifting some certain level of numbers or characters in the next string, right? So in this way, every time you try to use this cipher example, it would give you some different output because your number of places to shift may differ. Only if that is same, then you are able to understand with the help of this. Now, since we have printed it, but if we have not printed it, it is difficult for us to understand how basically it is executing in the background. So even the one example, that the first example we have done for Caesar cipher.py also executes in a similar manner. Okay, it is shifting by some certain characters and then it is executing the given particular code there. So now let us see another example. Let us close down this and again we will create from the shell a new file, and here we will create variable message str wherein we are giving the value over here, say as Python hacking demo. Okay, and we are using a constant by putting everything in capital, say letters str, which is equal to all the characters MN, OP, QR, ST, UV, WX, Y, Z. Okay, so all the characters also in the capital. Then we run a for loop where we give for the key code in, we are using here range, and in that we are putting the length of the constant, that is letters str. And in this for loop, we create a variable translated text which is equal to blank. Then we say of another for loop for say symbol char in your message str variable. You check if your symbol char in the constant letters str, then you create another num variable, say num sim, which is equal to letters str dot find for the symbol character, which will basically get the number of symbols there. Okay, and then you say the num sym is equal to num sym minus the value of key code. Check if num sym is less than 0, then num symbol is equal to num symbol plus the length of letters str. And then we say the variable translated text, which will be equal to, say, translated text plus the constant letters str in the index of numsym. And if it is not, the earlier one is not true, then go to the else part, and here we say the translated text is equal to translated text plus the symbol char. And at the end, in the same for loop itself, we print the key code. Say hash, we printed n %s colon %s, and there we print the value of key code, comma, the value of translated text. So let us save it as in E drive Python hacking setdemo6.py. Okay, and save it. Now if you try to run this, you will get for each an individual key code. When the key code is 0, it will be displayed as it is because we are not shifting any characters there. But as soon as the key code goes on changing, this will also be changed. So one character or the key code changes and the text also changes in a different way. So if you're using a key code 15 for this text, the encrypted text would look like this. Similarly, if you use a key code 5, the encrypted text would look like this. This is basically how we are printing the values using the key code and the encrypted text value. Okay. Now we will do a last program on the Caesar cipher example. So let us close this also and go back here and create a new file. Now here we would be creating two dictionary which will look up basically for the index of alphabets. So we would be using here dictionaries instead of the CHR or the ORD functions that we have already used. So the first thing we would create is, say, a dictionary alpha1, which is equal to, now in this we are giving, say, A in single quote is having the value 1. Similarly, say B colon 2, comma C colon 3, like that for all the other values. So D colon 4, E colon 5, F 6. You can move on to the next line. Say G 7, then H 8, then I as 9, then J as 10, K colon 11, then L colon 12, then you have M, that is, say, 13. Move on to the next one. Say N colon 14, O 15, P 16, then you have, say, Q, that is 17, say R 18, S 19, T 20, U, say, 21, V 22, W 23, X 24, Y 25 and last Z26. Okay, so let's just give a proper spacing so that it is easy for us to read it. Nothing else, otherwise everything would be same. Similarly here also. Again, this is not compulsory, but it is easy or more feasible for us to read it, hence we are making it. And also to find if any mistake we have made in the alignment part. Then the last one. Okay, now after this we create another, say, dictionary alpha 2, which is also equal to some values, but now here we are changing it, we are reversing the order or shuffling the order, basically, you can see. So say for example we take here the key code first, and here we give that is equal to, say, Z. Then let's give 1 as equal to, say, A. Then say 2 equal to, say, B. Then 3 equal to C. 4 equal to D. 5 equal to E. Move on to the next line, say 6 as F. 7 as G. Then 8 H. 9 I. Then you have 10 as J. You have 11 K. 12 L. 13 M. 14 as, say, N. Then 15 O. Next line, say 16 as P. 17 as Q. 18 as R. 19 S. 20 as T. And coming to the last line, say U. 22 V. 23 W. 24 X. And 25 Y. So we have shuffled certain characters here corresponding to the index as after shift. Now once we have done with this, we will be creating the functions to accept a string, okay, according to the shift that you are providing. So we will define here a function, say encrypt text, which will take message str and shift code, which is 2 parameters, and in this we are going to take the cipher text as initially blank. We will run our loop for letter str in your message str, and for that we will check here for spaces. That is, if we will check the letter str not equal to a blank space, then we will look up the dictionary and we will add the shift to the index. So here we will take num1, that's equal to, use here dictionary alpha 1 in the index as letter str, plus use the shift code that you have passed, modulus 26. Now that here we will look up the second dictionary for the shifted alphabets and then we will add them. So we will take here say cipher text plus is equal to the second dictionary, that is dict alpha 2 at the index num1. Now if it is not having any spaces, go to the else part, and here we will add the space by giving cipher text plus is equal to, add a space there. And once we have done that, let's move in the for loop, and we say return the value of cipher text, which means our definition of the function encrypt text is completed. Now we will have another function here, that is say decrypt text, and this also takes say a message str and a shift code parameters, and here we have say cipher text, which is equal to initially blank. Then again here we run say letter str in your message str, and in this for loop we will check for the spaces, that is if your letter str not equal to space colon enter, then we will look up the dictionary and subtract the shift to the index. So we'll take num1 is equal to, we will use the dictionary alpha 1 in the index of letter str, that's minus, we use the shift code plus 26 modulus 26, and then we will look up for the second dictionary and for the shifted alphabets. So here we'll use the decipher text plus is equal to your dictionary alpha 2 at the index of num1. Now if this is not true, we will go for the else part here, and again we will add the text saying decipher text plus is equal to a space. So once we have added this, we are supposed to also return the value of decipher text, and once that is done, we will define here another main function, which will basically is helpful for running our program. Now here we are going to use the upper function to convert the lowercase characters to uppercase. So we are going to use here a message str, and we are going to pass there a message as say, let's give here in capital, say Python hacking with Caesar cipher as a text in double quotation marks. Also we give the value of shift code as equal to 13, and then we say here the result str is equal to, we call here encrypt text in bracket say message str dot convert to upper, and use the value of shift code, then finally you print the value of result str here. Now to execute this main method, what we'll have to do is check here if say your name is equal to your main in single quotation marks, then you're going to call the main method. Now let us save this. Let's save it again in the Python hacking beginner, say demo7.py, and let us try to run the module. So this is how we are getting the encrypted one. But now suppose we want also for decrypting it. So we copy down this text, go back here, and in the same main method we say another say message str is equal to the text that we have copied down. Now we have the shift code as again 13, we have again the result str. Now we are calling the decrypt text method, passing there again the message str dot in uppercase and the value of shift code, and then printing the value of result str here. Okay, so now again let us save this and go back for executing. Okay, fine. Let's check here. we are having the value as decrypt text. So decipher text. We must have made some spelling mistake. Let's check it. Okay, so better we copy down one code and see the output now. Indentation has to be also proper. Fine. So getting this? Now, if you want to know how basically it is getting hacked, if you see the first character as P, we come back to our program here. What is the value or the index of P over here? You can just find out. That is 16. If you add 16 plus 13, you get the value as 29. Now, when the value go above that, okay, so we'll also require a calculator just to make you understand here. See, the value initially that we have given there for the character is P. So the value, if you see here for P in the first one, it coming as 16. If we take here, say 16 plus the key code that we have given is 13, it becomes 26. If we subtract 26 from that, the value comes to 3. So what is the index at the second dictionary for 3? That is C. So is that coming as the first character? Yes. Let's try it for another. Say the value of Y. Go to the first dictionary. What is the index for Y given as 25? If we go back here and say 25 plus the key code 13 comes to 38. If we subtract 26, we get 12. What's the value coming on 12? That is L in the second dictionary, right? So is that coming here for L? Yes. So that is how you are getting a substitute for every key from the first dictionary alpha 1 being substituted by the second dictionary alpha 2, and that is the value you are getting for a decrypted text. Okay, similarly, if you go from decrypted to encrypted, the value of the dictionary alpha 2 is being substituted in dictionary alpha 1, and then you get the encrypted text. This is basically how your Caesar cipher is executing. So we have not used here the CHR or the ORD function. Instead, we have created here the dictionary alpha 1 and 2 by giving some individual values and the key code for every characters, and we are using that for encrypting it and again for decrypting the particular given text. Okay. So in this way, we have seen multiple examples on Caesar cipher, okay, which will make the concept of how to encrypt, decrypt using the Caesar cipher concept very much clear, right? So that's it from this particular session of Caesar cipher in Python hacking. Thank you very much. Welcome to the next session in our Python hacking course, that is hacking the Caesar cipher using the brute force. Now we can hack the Caesar cipher by using a cryptanalytic technique which is called as brute force. A brute force attack tries every possible decryption key for a particular cipher. Nothing can stop a cryptanalyst from guessing one key, decrypting the cipher text with that key, looking at the output, and then moving on to the next key if they didn't find the secret message. Now, because the brute force technique is so effective against Caesar cipher, you shouldn't actually use a Caesar cipher to encrypt secret information. Now, coming to a new file which we will be creating for this particular demonstration. So let us go to our Python shell and create a new file here. And first thing is we would type our hacker code over here for Caesar cipher. So now here let us create first say message str, and we'll give here the text in a decrypted format. Okay. So we'll use a single quote and we'll give here some text in a decrypted format. Say 6JZ exclamation J6RP. Now this is all in an encrypted format that we are typing just to see the output that we get. Similarly, we would use here symbols str and we'll save here all the capital letters first. XYZ. Similarly, we'll store everything in the small and after that we will store also the numericals, a space, exclamation mark, a question mark, a dot, everything in the symbol str. Now we have written this symbol str in a capital because we want to make it that this is what basically we are creating as a constant which will not have the values changed frequently. Okay, then we will loop through the every possible key. So over here we will run a for loop saying, say, for key str in range bracket will give the length of symbols str over here. Okay, and we'll open the for loop, and inside this for loop we will basically set a variable to blank string so that the previous iteration values for the particular text is clear. So we'll say translated str is equal to blank. Okay, now the rest program below would be almost same as our Caesar cipher program that we had done in the last session. So over here we'll loop through each symbol in the particular message. So for that we will run a for loop again, say for sym in message str, open the loop. Then inside this we check if the value of sym in symbols str. Okay, then you say one more variable, symbol index or sym index, which is equal to, we say symbol str dot find the value of sym. Okay, then we say the translated idx, that is equal to our sym index minus the value of, now here we would be taking the value for key str. Okay, and then we will handle the wraparound. Here below we would say if our, say, translated idx, if it is less than 0 colon, then we say translated idx is equal to translated idx plus the length of symbol str. Okay, after that we would append the decrypted module. So we'll go one level back, and here we say the translated str is equal to what is the initial value in translated str plus add in that the value of symbol str index of translated idx. Okay, that is the index key that you would be taking for adding one value in the translated key. Now after this we would go for the upper if condition else part. So we'll go here for else colon, and here we would write down the value of translated str is equal to translated str plus sym. Okay, and now for displaying every possible decryption text, let's go one level back and we'll come for the below the for loop, and over here we will give a print command saying, say, key value, give here a hash, then we give here, say, %s colon %s, close the single quotation marks. Here we would print the value of key str and the value of translated str. Okay, now let us save this. We would save it in Python Hacking Beginner. Now let's give here, say, demo 8. Okay, and save it. Now to run this, we'll go for run module, and over here at one point of time you would see we are getting this particular text in a normal English code because we have given this as the key code 13 where we had decrypted that using that particular key code. So here we will also find out what key code we have used. Okay, now one important thing over here, what mistake we must have made is over here inside the message. Let us check the encrypted message that we have written. It is JV, then we have 6 JV, then it is 6 JZ, Okay, now here we don't have this exclamation mark also. Okay, whereas after 6J we have here say F RP, then 5R7, then we have J. Now here we have this capital Z R, that is 66 NTR. This also is not there. So now let us save this and let's try to run the module. So now if you check out at key number 13, we get the value as this is secret message. Okay, again here let us just check once. Okay, better ways. Let us open our Caesar cipher program, and here we have written this is my secret message. We want to encrypt this. So now let us check the output for this program. Okay, now this is the encryption key. So now let us copy this. Let's close this, and here let's copy down the same encrypted text. Okay, and now let's try to run the module. Now let's check on key number 13. Okay, some mistake again, and that mistake is over here. It is not NM, it is MN. Okay, let's save this and run it again. Now let's check. Yes, so now you can find out what is the original message and which key was used to encrypt this particular message. Okay, now let us understand the code that we have written. Okay, now over here we have seen how the output is coming. Okay, so we are getting the output in a decrypted format on the key 13, which is coming in a plain English text. So now we can know that the original encryption key must have been 13, right? So with this, now let us understand the code that we have written. So let's go back to the code here. Okay, now here the hacker program, we are creating this message str, which is basically storing the cipher text string in the program that is trying to decrypt it, right? Similarly, the next is we are having the symbols str, which is a constant variable containing every character that the cipher can encrypt. So it will be from capitals, smalls, even the numbers. Okay, now this value in the symbols str that you have given needs to be the same as the value for the symbol str you have used in the Caesar cipher program. Otherwise, you will not get the hacker program will not work properly. Even note that with the space between 0 exclamation mark has to be there as you have written in the same Caesar cipher program, right? Now let's come to the next part wherein we go for looping with the range function. So over here, we basically doesn't iterate over a string value, but instead we iterate over the return value from the call to the range function. So the range function here takes integer arguments and returns a value of the range data type. Now the range values can be used in for loops to loop a specific number of times according to the integer you give in the function. Now let us try some example of this range in the interactive shell. So let's go here and we will write down here, for example, say for I1 in range say 4. Okay, colon, and here we give say print in bracket say Python hacking. Okay, so 4 times we are getting the string Python hacking printed. So here the for loop will loop for 4 times because we have passed the integer 4 in the range. So more specifically, the range value returned from the range function call will set the loop or the for loops variable to integers from 0 to the argument that is passed in the range. So for example, here we are having from 0 to 4. Okay. So more specifically, if you want to know how the arguments are passed, another program that we can try it out over here is say for I1 in range, we give here say 7. Okay, and now we try to print in bracket the value of I1. Okay, now let's see how it is printing. It is going from 0 till 6 because we are giving their range in bracket 7, right? So over here the code sets the variable I1 to the value from 0 but not including 7, which is similar to what we have in the earlier one. Now when the first time the program execution goes through the particular loop, the key str is set to 0. And over here if we look at the program initially, okay, Now after this, the cipher text in the message str is decrypted with a key 0. Now of course, if 0 is not the real key, your message str just decrypts to anything else apart from the exact text. Now the code inside the for loops of after this, okay, now over here is basically similar to our Caesar cipher program that we have done. Now over here, after the next iteration, the key is set to 1 for the decryption. So in the first argument where the range should start, the second argument is where the range can end up. So over here you can also give 2 arguments in the particular range which will be separated by comma. Now for example, if you want to try it out, you can go back here and let's try it out in the interactive shell. We say for I1 in C range, we give here from 2 till 7, and for that we would print the value of I1. So we get the value from 2, that is starting point is 2 and it is ending at 6 because we have given 2, 7. So the variable I1 over here will take the value from 2, which is including 2, up to the value 7 but not including 7. So if we move on to the decrypting the message part, again we'll go back to our program. Now over here, the next for loop, okay, where we are creating the translated str variable which is set it to blank string, because we would wanted to add the values which is decrypted in the translated str. Okay, so over here the current key will be added to the decrypted text in the translated str from the last iteration in the loop, after which we have the next, that is the for sym in our message str. If the symbols or sym in our symbol str, we are finding the particular symbol value. So over here we are basically looping through every symbol in the cipher text, the string that is stored in the particular message str. So on each iteration of this loop, we are checking whether the symbol exists in the symbol str constant variable, and if so, we are decrypting it. Okay, so then basically we subtract the key str from our symbol index to decrypt it. Now after this, if we just see the next code, where the subtraction operation may cause your translated IDX to become less than 0 and require us to wrap around. So the symbol constant, when we find the position to the characters in our symbol str to decrypt, we check for this case, okay, and if translated index is less than 0 over here, then it can be modified. So we say the translated IDX is equal to the index value plus the length of our symbol str. Okay, so we are basically appending there the values at the end of the translated IDX. So moving to the next one, where we are saying here that translated str is equal to translated str plus the value of symbol, that is sym. Okay, so here we are just adding the unmodified symbol to the end of the translated str if the value was not found by in the symbol str set. Okay, after which we are basically using the formatting or string formatting to display the key and the decrypted message. So when we are saying here print key value hash percentage percentage and the value of key str comma the value of translated str, the argument over here in the print function calls is a string value that uses this string formatting, also called as your string interpolation. So the string formatting with %s text places one string inside another one. The first %s is a string gets replaced by the first value in the parenthesis at the end of the string. So for example, so now we can try out some string interpolation examples in the interactive shell. For example, if we write down over here, say hello, %s, exclamation mark, close this, then we write down here, say Python, and we press enter. We get there hello Python printed. So after Python we get the exclamation mark because here we are saying that this string should be printed. Similarly, if we try out something like say hello, a space, then a plus, say Python, then again a plus and exclamation mark. So we again get the same output but in a different way without using %s. Similarly, if we say the %s ate the %s that ate the %s, close this, then here we write down the values which we want to substitute, that is say dog, cat, rat. So here we get the dog ate the cat that ate the rat. So everywhere the words automatically get substituted, right? So in the first example that we have seen here, the first string, that is the Python, okay, is inserted into the string hello. Okay, it works as though you had concatenated the part of the string before %s with the interpolated string and the part of the string after %s. So when you interpolate multiple strings, they replace each other in the particular order. String formatting is often easier to type than the string concatenation using a plus operator, especially for large strings. And unlike with the string concatenation, you can also insert the non-string values such as integers into this string. For example, if we want to try it out, something like say %s had %s pies, close this. Here we write down say John and say 53. So we are inserting that integer value as a string value. Okay, or for that example, we say John plus say had, concatenate, say 53, again concatenate and end it. Here you will get an error because you cannot convert an integer object to string implicitly. So in the first one, the 53 integer got inserted easily into the string without any issues when we were using the interpolation part. But when you try to concatenate the integer, it will give you an error. Okay, so now if we move on to the print value that we had in our particular program of hacking Caesar cipher. Okay, here we have used the string formatting to create a string that has values in both the key and the translated variables. Okay, because the key stores an integer value, we use string formatting to put it in a string value that is passed to the print command. Hence, we were getting the key value also printed as a normal string value without any errors. Okay, that is how we have created a hacking program for our Caesar cipher. So in this way, we have seen one example of hacking a Caesar cipher. So now we'll create another example on a brute force technique in Caesar cipher. Okay, so let us close down this, and in our main Python shell, we'll go for a new file, and we are going to define here one constant, say max key size, that's equal to, we are giving a limit as 26. Then we are defining a method that is getMode. So in this particular getMode method, we will say while true, and we are going to print here first a message, say do you wish to say encrypt or decrypt or say brute force a message. We are going to ask a particular user what does he wish to do. Then we accept that value in say mode str variable, which is equal to, we say input dot accept it in lowercase, hence we are using lower method. Then we check if the mode str in, if it is say encrypt e, decrypt d, brute b, dot, we are going to use split. Okay, now split basically will split and check whether it is encrypt or it is E or it is decrypt or it is D or it is brute or B. Fine. Then we are going to say here, say return mode 0. Else we are going to use here print and say enter
either say encrypt or E, or decrypt or D, or say brute or B. So basically we are going to give a user that what he wish to enter, that is if he is not able to understand, then in that case. Okay, now after this we'll go back to our definition and we will define another method, say get message str, and in this we are going to just use a print and give, say, enter your message. Okay, and then we are going to say return the value of input. After that we say another method, say get key str, and in this we would define a key str as 0. Fine, then run a loop till it is true, and here we are going to ask, say, enter the key number. Okay, and here we enter, say you want to enter from 1, and we would be printing here in the string format the value of max key size that we have already defined it above. Okay, so after this we will say key is equal to, or key str, that is what we have taken, so that is equal to, we convert to integer the value of whatever the input user gives. Okay, then we check if the key str is more than equal to 1 and the key str is less than equal to the max underscore key underscore size variable, and if it is, then we return key str. Okay, now after this particular function we go back for another definition of, say, get translated message str, and here we are passing the mode str, the message str, and the key str as the values. So here we check if the mode is equal to, or the mode str is equal to 0 at the index 0 is equal to d colon, we say the key str is equal to minus key str, and we have another variable, say translated str, that's blank. Then we create, say, for sym in a message str, and here we check if sym dot, say, is alpha method, then we do a num1, that's equal to, we use order of sym, then we say num1 plus is equal to the key str, after which we check if the sym dot is upper, if it is we do, and if another with num1 more than the order of capital Z, if this is also true we make num minus is equal to 26, that is num1 in this case. Okay, after which we go for the else if part. Okay, and here we check if the value of num1 is less than the ord of, say, capital A, then we make num1 plus is equal to 26. Now we go for the upper if else condition, and here we check is the symbol dot is lower, then in that case we check again for num1, if it is more than equal to or more than ord capital or small z, then we make num1 minus is equal to 26, then again else if num1 less than the order of small a, then again we would be making num1 plus is equal to 26, and then we go one level back. Okay, and here we say the translated str plus is equal to convert to char the value of num1. Now here we come for the if condition which is declared over here. So let's go one more back, and here we declare the else part for the above if condition, and in this else part we say the translated str plus is equal to the value of sym. Finally we say return the value of translated str, and we end the method there. Now okay, one thing we have made a mistake. This will be over here, so all will be one level back. Even this will be one level back. The alignment would change. Again this. Okay, similarly here also we'll have to change the level there. Same goes for here. This will be for the else if part. This is for num1, and again this will be for the outer if condition. So again for outer if we will have inner if, and we'll have there else also. So let us just change it. We have missed one level there. Again this would come for the else. Now this will be for the upper if condition, and finally we are supposed to return it over here. So now it becomes proper. Okay, after this we go back and let's write down here say mode. Now we have taken the value as mode str. Okay, so let us just check. Yes, so we make mode str is equal to, we call the method get mode. It is the same method that we have created. Okay, then we say the message str, that's equal to get message str method is to be called. Then we check if mode str at the index 0 is not equal to say b. Then we say the key str is equal to get key. Now here also we have get key str. That's a method. Okay, and finally then we say print say your translated text is, and below this we go for checking if mode at the index 0 not equal to b. Then you print get the translated message str, wherein we are passing mode str, we are passing message str, and we are passing the key str values. Else we say for the key str in the range of 1 till say the max key size that we have defined plus 1. Okay, because we want to include 26 in that, hence we are making it plus 1. Then we are saying here print the value of key str and get translated message str, say decrypt. Then you print here message str and key str values. Okay, with this let us save this, say as demo 9 for example .py. Okay, and let us try to execute this. Okay, now first we want to encrypt. Okay, now basically in this let us check the code that we have written. Yeah, here we have not written return mode str. Okay, that is one thing. Let us also check below. Here we are saying mode str is equal to get mode. Okay, oh again here mode str. So now Let us save it and let's try to run this. We wish to encrypt the message first. Okay, we enter, we want to encrypt, say the word Python with the key 14. We are having some issue in translated str. Fine, let's check this. Maybe there is some spelling mistake that we have written for translated str. Okay, so this is, here is where we have defined translated str, and here we are just incrementing the value of translated str. So the message, that is get translated message str, is the one that we have defined, wherein we are going to pass the mode str, the message str and the key str, and we would be similarly passing it over here also with the word decrypt. In this case, D is small, and the message and the key str. Okay, let us run this again. Say we wish to encrypt Python with the key 14. Okay, let's go back here and we are checking this over here in the if. Then we are making this plus is equal to 26. Then we make translated str plus is equal to the char value in the bracket num1. Okay, similarly else we say plus is equal to the value of sym. That looks good. And then we return the value of translated str. We are getting here error on line number 45. Another way is you can directly go to line say 45, that is over here. So now this again, we hope there is no mistake in the typing issues. Okay, we are supposed to define it here because this if condition ends here, and then we define this translated str. So let us run this again, and we wish to encrypt the word Python with the key 14. Now this is what is our translated text coming. Now if we select this, okay, we go back here and we again run this. And this time we say we want to go for not encrypt or decrypt, but we want to go for brute. And this is our message. So it will find in all the keys, and what key we had used? We had used key number 14. So on key number 14 we get the value Python there. Similarly, suppose you go back here, you run this. Now you say you wish to decrypt it. Okay, and you want to decrypt the same message. You want to decrypt using the key 14. You get the same translated text. But when you go for a brute force option there, you get it encrypted or decrypted in all the 26 keys that you are having, and you would get the correct word which you had already encrypted on that particular key, which key you had used. Okay, so another example wherein we had seen the use of brute force to get the values on what key we have encrypted a particular message. We would again get the same message decrypted on the same key itself. Okay, so that's it from this session where we have seen one extra example on how to create a brute force attack example using your Caesar cipher. So here we have merged all the examples together so that you can also encrypt, you can also decrypt it there, or you can also use the brute force technique to see the decrypted text. Fine, so that's it from this session. Thank you. Welcome to the next session in our Python hacking course, that is encrypting with a transposition cipher. Now we have seen Caesar cipher, and we have also seen that it is not more secure or the most secure one. It doesn't take much of a computer to brute force through all the possible keys. The transposition cipher, on the other hand, is more difficult to brute force because the number of possible keys depends on the message length. Now, there are many different types of transposition cipher if you look at it. Now, those different types basically includes the rail fence cipher, your root cipher, the disrupted transposition cipher. Now this particular session will be covering a simple transposition cipher called the columnar transposition cipher. Okay, so in this particular session we would be covering the topics like creating functions with def statements, arguments and parameters, variables in global and the local scopes, what is main function, the list data types, similarities in the list and strings, list of list, coming to argumented assignment operators, using the join string method, return values and the return statement, and finally the name variable. Now we will first of all look at how the transposition cipher work. Now instead of substituting characters with other characters, the transposition cipher rearranges the messages symbols into an order that makes the original message unreadable. Now because each key creates a different ordering or a permutation of the characters, and a cryptanalyst doesn't know how to rearrange the ciphertext back into the original message. Now some steps for encrypting with the transposition cipher are: first is count the number of characters in a message and the key. Second is you will draw a row of a number of boxes equal to the key, for example 8 boxes for a key of 8 or something like that. Next is start filling in the boxes from left to right, entering one character per box. Fourth is when you run out of boxes but still have more characters, add another row of the boxes. Next is when you reach the last character, shade in the unused boxes in the last row. And starting from the top left and going down each column, write out the characters. Now when you get to the bottom of a column, move to the next column in the right, skip any shaded boxes if any, and this will be your ciphertext which is encrypted. Now just to show you how these basically steps work in practice, we will encrypt a message by manually and then we will translate the process into a particular program. Now encrypting a message manually. Now before we start writing the code, we'll first work out on a simple paper, or here we'll use, say for example, a notepad for doing that. Now instead of a notepad we would use here Excel, which would be easy for us because we already have the columnar format there. Now let us take one particular example. For example, say, so now let us take the text something like Python hacking course message. Now over here we will take for example the key as say 8 in this case. Now the range of the possible keys for this type of cipher is from 2 till the half of the message. Now what is the message size? If you just look at it, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, including all the characters. So the range of the possible keys would be over here from 2 till half of the message, that is till 15. So we have used over here the key as 8. But the longer the message you have, the more keys are possible. Now encrypting the entire particular paragraph, you can say, using the columnar transposition would allow you to use thousands of possible keys. Okay, now what we'll do is, first thing, we'll create an 8 boxes in a particular row. Now let's take 4, 5, 6, 7, 8, 8. Okay, we'll just make it in a border type so that it is easy for us to understand. And let us increase the size of the boxes, each boxes. Let's remove this, that's not required. Even this one, not required. We can decrease this. So now we have 3, 4, 5, 6, 7, 8. Okay, fine. All should be visible enough properly. Let's cut it and paste it here so that even this could be removed. So now let's make this wrap, and even all these boxes also we'll make it wrap text. Now after we have done this, we have the 8 boxes which we have created. Now the second step is to start writing the message you want to encrypt into the boxes, placing one character into each box. So for example, Now we will start writing one character. Now even a space that you have, we are indicating over here with a particular symbol. So let's insert here a particular symbol. Let's add some special characters. Okay, so here we have this symbol. Now let's place that symbol over here. And again, we would continue. So one word has been done. Now this particular row has ended. So now we want another row below. So let's take this and again, let's make it the same formatting. And again start writing here. So we had reach till H, A, C, K, I, N, G. And again here, let's copy down the same symbol, C. Now again, we require another row below. Let's take down and do the same thing. Now it is O, U, R, S, E. Again, we require a space and then M, E. And the last one, we would require, say, S, S, A, G, E and a dot. So let's take only till this and let's copy down the formatting. Okay, so after this, let's write down here. So we have written this particular way. Okay, and last thing that we have is a dot. So we have even written that. So only space is we have stimulated that with a particular symbol. Okay, now just to make it more meaningful, we will increase the font size. Okay, so this is how we have basically arranged it. Now these two are not used. So over here, let us give some different background color just to highlight that we are not using this particular two boxes, because 8 rows or 8 columns would automatically be created. So we have shaded the last two boxes in the last row as a reminder to ignore them. Okay. Now the cipher text consists of the letters read from the top left box going down the column from the first column as labeled in the particular sheet that we have created. So how basically the code would be written now is, it will start reading from top till the bottom. So over here, say for example, P, A, O, S. Next will be Y, C, U, S. Say T, K, R, A. H, I, S, G. Then O, N, E, E. N, G. Now that symbol there and a dot. So this is how basically it is going to encrypt it. Now let us see, just we have deleted that. Now creating the particular encryption program here. Now to make the program for encrypting, you will need to translate this paper and pencil that we have done right now in the manual one into a Python code. So now let's look again how to encrypt the string that we have using the key 8 to Python. A character's position inside a particular string is its numbered index. So we'll add an index as each letter in the particular string in its numbered index. So add the index for each letter in the string to the boxes in the original encrypting diagram. Now for example, we would start over here and let's add here the index starting from say 0, then say 1, 2, 3, 4, so on till the last one. Okay, so we would be adding till 7 we have added. Similarly, we would do it for all others. So it will be from 8 till 15, then 16 till 23 and till 29, because it is from starting from 0 onwards. So just let's keep on writing the index values there. That's done till 15. Move to the next one. Say 18, 19, 20, 21, 22, 23, 4, 5, 26, 27, 28, and the last one 29. So we have added the index to the each of these boxes. So these boxes show the first column which has the characters which will be like 0, 8, 16, 24, which the characters are capital P, A, O, S. The next column will have the characters and indexes, that is 1, 9, 17, 25, which are say Y, C, U, S. Now notice the pattern emerging, that is the nth column has all the characters in the particular string at index 0 plus n minus 1, 8 plus n minus 1, 16 plus n minus 1, and 24 plus n minus 1. For example, if we write down something like over here, say 0 plus 0 equals to 0. Similarly, say 1 plus 0 equals to 1, or 2 plus 0 equals to 2. Similarly, say 3 plus 0 equals to 3, 4 plus 0 equals to 4, 5 plus 0 equals to 5, 6 plus 0 equals to 6, 7 plus 0 equals to 7. But when we come over here, say 8, here also we say plus, so here we'll say 8 plus 0, that's equal to 8. Now here we would add 1 to it and we would make it, or rather we would make it something like say 1 plus 8, that's equal to 9. So we're going to take here 1 for substituting it. So here again we will take say 2 plus 8, that's equal to 10. Here we would take say 3 plus 8, that's equal to 11. Here we would take 4 plus 8, that's equal to 12. Similarly, 5 plus 8, that's equal to 13. Say 6 plus 8, that's equal to 14. And finally, say 7 plus 8, that's equal to 15. But when we come over here, we again substitute 0 plus 16, that's equal to 16. But over here, let's make it 1 plus 16, that's equal to 17. Now we'll have to just decrease the size a bit. Here we would say 2 plus 16, that's equal to 18. Then 3 plus 16, substitute 4 plus 16. Here it would be 5 plus 16. Then it would be 6 plus 16. And finally it would be 7 plus 16. When we come down to the last row, we would make again 0 plus 24 equals to 24. But over here, we would substitute say 1 plus 24 equals 25. Similarly, say 2 plus 24. Then say 3 plus 24. And similarly, 4 plus 24. Finally, we'll make it this 5 plus 24. Now in this way, we are going to get the index of each box, which will follow the predicable pattern. Now there will be an exception for the last row in the 7th and the 8th column, because when you say 24, that is 7 minus 1 and 24 plus 8 minus 1 would be greater than 29, which is the largest index in the string. Now in those cases, you will have to only add 0, 8, 16 and n, that is say skip 24 there. So what's so special about the numbers 0, 8, 16, 24 in this case? That these numbers, when you start from 0, you add the key, that is 8 over here. So 0 plus 8 is what you get there. Similarly, then you add 8 plus 8, you get there 16. When you add 16 plus 8, you get there 24. So hence we are getting the first as 0, then added 8 to it, and again added 8 as the key to it. So hence the result is coming like this. Fine. Now the last one, when you say 24 plus 8, it would be 32. But 32 is larger than the length of the message. So you will stop at 24 there. And for the nth column string, starting at the index and continue adding the 8 to get the next index. Now keep adding 8 as long as the index is less than the length of the message. That is less than 30. at which point move to the next column. So if you can imagine each column in a particular string, the result will be the list of the 8 strings that you will be getting. For example, in the first one, you would be getting the string as PAOS. Then you would be getting say YCUS. Then say TKRA. Then say HLSG. Say ONEE. Then say NG, the particular symbol, and dot. Let's copy down the symbol here. Similarly, here again, let's copy down the same symbol 2 times. Then you will have M. And similarly here, you would have say HCE. So something like this is what basically we would be encrypting there. So now let's have a look, and we would create a particular program for the same one, and let's see if we get the similar output that we have created over here manually. So now we would go for the source code for transposition cipher encryption program. So we have come to the Python environment. Now let's create a new file here, and we would start by first saying import the paperclip, after which we would define the main. Here we are going to define say my message str. Now that's equal to the same string that we have taken, say Python hacking course message with a dot also. Then we define here say my key str, and that's equal to 8 as we have taken in the manual one also, so we should get the same output there. Then we would have the cipher text str, and that's equal to, now here we are going to call say encrypt message str, which will, here we would be passing my key str and my message str. So after this we would say a print command, and we would give here print the cipher text str with, in that, concatenate a pipeline symbol. And after that we would copy the encrypted text to the ciphertext clipboard. So we would say here use the paperclip dot copy method and say cipher text str. Now after this we move to the out of the particular definition of main, and here we define another method that we have already called inside, that is encrypt message str, which would be taking say the key str and message str. And in this message or particular function we are calling the cipher text str, that's equal to, we are making it blank, multiplied by the value of key str. After we have done this, we would loop through the each column in the ciphertext. So we would say here say for column str in the range, and range we would be giving here as key str. Here we are saying the current IDX, and here we are making that's equal to the column str. And once we have done through that, after this we would keep looping until the current index goes past the message length. So over here we would run a while loop saying the current IDX if it is less than the length of your message str. If it is, then we will place here the ciphertext str at the index of column str, and there we would say plus is equal to the message str and in bracket the current IDX. After which we would move to the current index over, or the current IDX, saying the current IDX plus is equal to the key str. Now after this, let's convert the ciphertext list into a single string and return it. So let's come back in the for loop, and here we would write down the return statement dot join the value of ciphertext str, and come out of the definition, and over here we say if name is equal to main single quotes, then you're going to call the main method. So let us save this. Let's save it in Python hacking beginner, and let's give it a name as demo10.py, and let us try to run this module. So this is how we are getting this particular value. If we just copy down this in the manual thing that we have done, let's go here and let's paste it here. Let's see, it is coming in the similar manner that we have done. The only thing, we are not replacing there any particular thing. We are getting their spaces instead of the symbols that we have created here. Otherwise, the text that we have created manual thing, and the way we have got here manual through the indexing, the same way we are getting it through the output when we do it into the Python hacking as a transposition cipher. Now let us understand the particular code that we have used there. So here the vertical pipeline symbols here basically marks the end of the cipher text in case there are spaces at the end of it. Okay, so this cipher text without the pipe character at the end is also copied to the clipboard. You can paste it into any of your email if you want it, and if you want to encrypt a different message or use a different key, you will change the value assigned to the myMessageStr or myKeyStr variables, and you can then again run the particular program. Now let's understand the way we have created this. After importing our paperclip module, we have used a define statement or def statement to create a custom function that is main. Now the def statement means you're creating or defining a new function that you can call later in the particular program. In a block of code after the def statement is the code that will basically run when the function is called. So when you call this function, the execution moves inside the block of the code following the function's def statement. So after this, we can, for example, suppose we take a example of a print method. We can take a string value as an argument between its parentheses. So when you define a function that takes argument, you put a variable name between its parentheses in its def statement. So these variables are called the parameters. So here the main function defines that there are no parameters for main function. So it takes no argument when it is called. If you try to call a function with too many or too few arguments for a number of parameters the function has, Python will give you an error message in that case. So coming to defining a function that can take argument with the parameters, now we will do some sort of execution of a particular code. We'll create a function with a parameter and then call it with an argument. So let us open here again a new file, and here we would define, say for example, hello1. We are defining here name str, and we are giving there a print simple saying hello string, comma, and concatenate with that name str. And then we are saying come out of this definition, we call print, and here we say start, after which we go for calling the hello1 function. Here we pass one particular parameter. Again we say print, say call the function again, and again we call hello1. This time we call it with some different parameter, and then we say print, printing, done. Now let us save this as demo11.py and let us execute it. This is how we get it. Start hello Alice, call the function again hello ABC, and then we get it the value as done. So over here, let's go to this particular program. Now when the hello function over here, or the demo11 that we have executed, executes or starts at the top, the def statement defines one function named hello1 with one parameter, which is the variable name str. The execution skips the block after the def because the block is only run when the function is called. Next, it will execute first print start, which is why start will be printed when you run the program. Next line after print is the first function call to hello1. The program execution jumps to the first line in the hello1 function block, and the string that is we have passed alias will be passed as an argument and is assigned to the parameter name str here. And this function call prints the string as hello comma alias to the screen. Now when the program execution reaches the bottom of the def statement, execution jump back to the line with the call function and continue executing the code from there. So now we would get the next print, that is call the function again, will be printed. Now the second call to the function hello1 would be done after that, and the program execution again jumps back to hello1. This time the parameter that we have passed is abc would be replaced here in the name str value, and it will print there hello comma abc. Again, when the function returns the execution, goes to the next line, which is the print done. Now this is the last line of the program, so the program exits. Now you can change the parameter exist only inside the particular function. Now we will see another particular example. We would enter it directly into the interactive shell. Now we'll create a code that will define or defines and then calls a particular function named say func1, and in the interactive shell you will have to require to enter there a blank line to close the definition of the function block. For example, if you go here and here you say define function func1, and here we are defining it with one param. We are giving there say param is equal to the value say 42. End it by pressing one more enter. Then we create here span is equal to say hello. Then we call here func1 and pass there the value span, and then we say print in bracket span. We get the value printed as hello, because now that is being replaced. So span value is hello. We have passed that value over there and printed the value back again. Now this particular function that we have created takes a parameter that is param and sets its value to 42. Now the code outside the function creates a variable span and sets it to a string value, and then the function is called and then span is printed. Now when you run the program, print call on the last line will print hello and not 42, because when function is called with span as an argument, only the value inside the span is being copied and assigned to the parameter. Any changes made to the parameter inside the function will not change the value in the actual variable. So every time a function is called, a local scope is created. Variables created during the function call exist in this local scope and are called local variables. Parameters always exist in a local scope. Now think of a scope as a container the variable exists inside. When the function returns, the local scope is destroyed and the local variables that were contained in the particular scope are also forgotten. Variables created outside every function exist in the global scope and are called as global variables. So when the program exists, the global scope is destroyed and all the variables in the program are forgotten. A variable must be local or global. It cannot be both. Two different variables can have the same name as long as they are in a different scope. So they would be still considered as two different variables even if their name is same. So an important idea to understand is that the argument value that is passed into a function call is copied to a parameter. So even if the parameter is changed, the variable that provided the argument value will never change. Now coming back to our actual program, let us go to our demo 10. Now here we have defined the main function that will set the values of the variables myMessageStr and myKeyStr when they are called. Now the rest of the program will also have a function main that is called at the start of each program. Now reason we are having a main function is explained at the end when we'll conclude our particular session. And now over here we have the variables myMessageStr and myKeyStr, which stores the plain text message to encrypt and the key which is used to do the encryption. Now over here we also have a variable cipherTextStr, which is as an encrypted message by calling the function that takes 2 arguments. So over here this will be stored as an encrypted message that will come from the message or from the function encrypt message str. The code that does the actual encrypting is in the definition encrypt message str function, which is defined later. Now this function takes two arguments, an integer value for the key and a string value for the message to encrypt. So in this case, we have passed my message str and my key str. Now when passing a multiple argument to the function called, separate the argument with a comma in that case, like we have passed over here. So the return value of the encrypt message str is a string value of an encrypted ciphertext, and this is stored in the variable ciphertext str. Now the ciphertext str message is printed on the screen and copied to the clipboard when we say here print and paperclip.copy. Now the program prints a pipe character at the end of the message so that the user can see any empty space characters at the end of the ciphertext. After execution is done, the program execution returns to the line after the line that is called it or called the particular main function. So the key and the message variables between the parentheses or the parameters when we define here the encrypt message str, it takes basically two arguments in this case, like the value in my key str and the message str. Now these values are assigned to the parameter key and the message when the execution moves to the top of the function. Now you might wonder why you need to have the key and the message parameter since you already have a variables as my key str and my message str in the main function. But we need different variables because the my key str and the my message str in the main function are a local scope and cannot be used outside the particular main function. Now when we come to the next, that is the list data type. So over here, if you see, we have created ciphertext str in the particular function by giving square bracket, single open closed multiplied by key str. Now before we can move on, you need to understand how the list works and what do you get out of the particular list. List value can contain other values also. Similar to how string begin and end with a quotes, a list value begins with an open bracket and ends with a close bracket. And the value stored inside the list are between the brackets. So if more than one value is in the list, the values are separated by commas. Now for example, if we want to see a list in action, we will enter something into the interactive shell over here. Like we would give, say, animals str is equal to, we give, say, dog, cat, horse, elephant. We have defined this. Then here we just say in the next line animals str. We get all the values printed. So here the animals str that we have, a variable store a list of values, and in this list values are basically 4 strings that we have created. So over here the 4 string values are stored individually there. So the individual value inside a list is also called as an item or an element. Now lists are ideal to use when you have to store multiple values in one variable. Now, many of the operations you can do with strings also work with list. For example, indexing or slicing works on list values the same way that works on the string values. Instead of individual characters in a particular string, the index refers to an item in a particular list. For example, if we say here, say animals str index 0, we get there the first index. Or if we say animals str index 2, we get there the third item apart in the particular list. Or if we say animals str in bracket 1:3, we get there the value from 1 till 3. So keep in mind that the first index is 0 and not 1. So similar to how you use slicing with a string gives you a new string and that is a part of the original string, using slicing with list gives you a list that is a part of the original list. And also remember that if a slice has a second index, slice only goes up to but doesn't include the item at the second index. Now you can also use a for loop for iterating over values in a list, just like we can iterate over characters in a particular string. For example, if you say for s1 in, okay, and here we use a list, say we give some again the same values, comma, close it, open this, colon, and here we give, say, print for dinner we are cooking plus the value of S1. End it. So we get for dinner we are cooking dog, cat, horse. So everywhere this value of S1 is automatically replaced, and that is what is printed. So each time your loop is iterating, the S1 variable is assigned a new value from the list, starting with the list 0 index until the end of the particular list. You can also reassign the items in the list. Now for example, say here, as we have defined animal str above, let's define that again. Animals str is equal to, give there again the same items. We have defined this. Now we say here animals str at the index 2, we want to make there something like 9999, and now we say animals str to be printed. So now we have replaced that value. To modify an element or third element of the particular list, we have used the index to get the third value with using animal str at the index 2, and then use an assignment statement to change its value from the original one to a new value. So when we check the content of the list again, now the earlier animal, that is horse, is no longer existing in a particular given list. Now similar to this, how can you have list of lists? Now list values can even contain other list values. For example, let's create list 1 here is equal to, here we create say dog, cat 1, end it, give a comma, next we have say a number 1 3 5 for example, and then close it. Now if we say list 1 index 0, we get the first list. If we say list 1 0 0, we get the first row first column value. Similarly, if we say list 1 say 0 1, we get the next value. If we say list 1 second row first column, we get the value 1. Similarly, list 1 1 1, or if you want to do it, say list 1 1 2, because that is having one more value inside it. So here the value of the list 1 evaluates to the list, that is dog, cat first, which has its own indexes. Now the double index brackets over here, that is we have used list 1 0 0, indicate that we are taking the first item from the first list. If we only say list 0, it evaluates to the whole of the first list. And if we say list 1 in the index 0 0, it goes to the first value in the first list, that is dog. Similarly, you can also use the length and the in operator with the list. Now you have also used the length method, which is there to indicate a number of characters in a particular string. The length function also works on list values and returns an integer of the number of list or items in a particular list. For example, if we say length of say animals str, we get the length as 4. Similarly, you have also used the in and not in operators to indicate whether a string exists inside another string values. The in operator also works for checking whether a value exists in a list, and the not in operator checks whether a value does not exist in the particular list. Now for example, if we try to say a value, say dog in animal str, we get the value true. If we say dog, in string dog 1 in animal str, that is coming to false. Similarly, if we say dog 1 say not in animal str, comes to true. Right, this is how we can use the particular values there. So now coming to the list concatenation and the replication with plus and the multiplication operators. Now you know that the plus and the multiplication operators can concatenate and replicate the strings. Same operators can also concatenate and replicate your list. Now for example, if we enter something into the interactive shell, say we write down here say Python and plus, again here we enter say hacking. we get there Python hacking. Okay, similarly if we say Python multiplied by 5, we get 5 times Python printed. Now that's enough about the similarities that we have seen between strings and lists. So, almost whatever we can work on string, we can also work it on list. So just remember, the most operations you can do with string values also work with your list values. Now coming back to our transposition encryption algorithm. So let's go back to our demo 10 over here. Now we are going to use the list in our encryption algorithm to create our ciphertext str. Over here we are going to say the ciphertext str, open the list, multiply by the key str. Now each string in the ciphertext str variable represents a column of the transposition cipher grid. Because number of column is equal to the key, you can use list replication to multiply a list with one blank string value in it by the value in a particular key. So the string values will be assigned all the characters that go into one column of a grid. The result will be the list of string values that represents each column as discussed earlier. Now because the list indexes starts with 0, you will need to also label each column starting at 0. So here we say ciphertext 0 or ciphertext str0 is the leftmost column and ciphertext str1 is the column to the right of that particular column, and so on and so forth. So over here, the next step here will be adding the text to each string in the ciphertext str as just we did it as in a manual example, except this time we will add some code to make the computer do it programmatically. So here we are looping it through the for each loop. So we are saying for column str in the range of key str, current IDX is equal to the column str. So over here we are looping or iterating once for each column, and the column variable has an integer value to use for the indexes to ciphertext str. On the first iteration through the for loop, the column str variable is set to 0, on second set to 1, and so on. We have an index for the string values in the ciphertext str that we want to access later using the expression ciphertext str in the index of column str. Now meanwhile, the current IDX variable holds the index of the message string for the program looks at on each iteration for the loop. On each iteration, the same or the current IDX, so the same value as column str. Now we'll create a ciphertext str by concatenating the scrambled message together one character at a time. So coming to the augmented assignment operators. Now so far that we have concatenated or added values to each other, we have used the plus operator to add a new value to the variable. Often when you are assigning a new value to a variable, you want it to be based on the variable's current value. So you need to use variable as a part of the expression that is evaluated and assigned to a variable. For example, if you try to enter something in the interactive shell here, like say span, that's equal to say 30, and here we say span equal to span plus 4, and then we say print the value of span, we get that 34 printed. Now there are other ways to manipulate values in the variables based on the variable's current value. For example, you can do this by using the augmented assignment operators. The statement like, for example, span plus equal to 2, which is used as plus equal to augmented assignment operator, does the same thing as span is equal to span plus 2, something like that, right? So just a little shorter to type it. So the plus is equal to operator works with integers to do additions, strings to do string concatenations, and lists to do a list concatenation. So if we go back to our program here, demo 10, now over here, the value that is we have used here ciphertext str. So over here, the variable that is your current IDX is basically holding the index of the next character in the message string. Now that will be concatenated to your ciphertext str list. Okay. And the key added to the current IDX on each iterations will be to the point to different characters in the message str. And at each iterations, the current IDX is set to the value in the column str variable. To scramble the string in the message variable, we need to take the first character of the message, that is over here P, and put it into the first string of the ciphertext str. Then we would skip 8 characters in the message because the key is equal to 8 and concatenate the character that is after 8 to the first string of the ciphertext str. We would continue to skip characters according to the key and concatenate each character until we reach the end of the message. Now doing so would create a particular string that we have first as we have getting there the value that is say P. Then if we just look at the Excel that we have here, that is PAOS. This would be the first the string that would be getting, which is the first column of your ciphertext str. Then we would do this again but start at the second character in the message to make the second column. So inside the for loop that we have in our particular program, a while loop that starts on the particular next line over here. It concatenates the right characters in the message to make each column, and it loops while the current IDX is less than the length of the message. Now for each column, the while loop iterates through the original message variable and picks out the characters in the intervals of the key by adding key to the current IDX. Okay. So after the, like you have the message str or message str in the bracket in current IDX is the first character of the message of the particular first iteration, and the character at the message current IDX is concatenated to the ciphertext str column to start the first column in the next line. So in this way, the first time the message 0, second time it is message 8, and third time it is message 16, fourth time it is message 24. That is how we get all the particular values concatenated. So although the value of the current IDX is less than the length of string, but when you continue concatenating and the characters to the end of the string at the column index is ciphertext str, when the current index is greater than the length of the message, execution will stop there. And because there isn't code in the for block after the while loop, the loop or the for loop iterates column and sets it to 1, and the current index starts at the same value as the column. So over here, we will get the values that we have got through the manual way as we have created. Coming to the join string method that we have used over here in the return statement. Now this basically is help to or do a join of individual column strings into the of ciphertext str into one string. So the join method is basically called on a string value and takes a list of strings. It returns one string that has all the members in the list joined by the string that join method is called on. Now for example, if we want to try it in the interactive shell, let's go back to Python here, and here we create, say for example, L1 that's equal to, let's give some different text there, and here we say single dot join L1. So we have added that values there or blank values to it. Similarly, if we say dot join L1, so we get a comma for every value that we have there. Or if we say capital ABC dot join L1, we get ABC added to every value in the particular string. So when you call the join on an empty string and join the list that is L1, you get the list or list strings concatenated with no string in between. So in some cases, you might want to separate each member in the list to make it more readable, which we have done when we say join on calling the string in a comma. That inserts a string comma between each member of the list. You can also insert any string you want between the list members as we have done in the last case. Okay. Now coming to the return values and the return statement. So let's go back to our code here, and the function or the function call always evaluates to a particular value. So this is the value returned by the function or the method. So also called as the return value of the function. Now when you create your own function using the def statement, a return statement tells Python what the return value for the function is. Like over here we have told return in single quotes dot join and the ciphertext str. So here we call join on the blank string and passes ciphertext as the argument. So the string in the ciphertext str list are joined into a single string. Coming to a return statement example now, a return statement is basically a return keyword followed by the value to be returned. So you can use an expression instead of a value. Like when you do so, the return value is whatever that expression evaluates true. For example, let us create a new file, and we would say here a definition for add numbers, say A, comma C, and here we are going to say return A plus C, and we would say here print in bracket, say add numbers. We give here say 3 comma 50 as the parameter. Let's save this as demo12.py and let us execute this. So we get there the value as 53 when the program is being executed. Now that is because the function calls or add numbers pass their 3 and 50 as the value and evaluates to 53. Okay, and the return statement in the function that we have created at the second line evaluates the expression A plus C and returns the evaluated value to the calling program, right? Similarly, we have here the returning of the encrypted text in our demo. So like in this case over here, we are returning the value back where we are actually calling the particular program. So in this, the encrypt message str function returns the statement that returns a string value that is created by joining all of these strings in the ciphertext list. And this final string, the result of the encryption code, is returned by our encrypt message str function. Now a great advantage of using functions is that a programmer has to know what the function does but doesn't need to know how the function's code work. A programmer can understand that when they call a particular function and pass it an integer as well as a string for the key and the message parameters, function call evaluates to an encrypted string. They don't need to know anything about how the code is encrypted actually, which is similar to know that you pass a particular string to the print message, it will print the particular given string back to the function code. Now coming to the double underscore variable like we have used here in the if part. Now you can turn the given transposition encryption program into a module using a special trick involving the main function and a variable named double underscore name double underscore. Now when you run a Python program, that's 2 underscore before name and 2 underscores after name that we have used here, is assigned the string main even before the first line of your program runs. The double underscore is often referred to as d under in Python, and double underscore main double underscore is called d under main d under. At the end of the script, you want to have some code that checks whether the name variable has main string assigned to it. If so, you want to call the main function. The if statement over here that we have used in the second last line actually is one of the first line of the code which is executed when you run the particular program. So when you run this, it will basically first check if name is equal to main and it will call the main function. The reason the main is set up over here this way is that although Python is set name to main, when the program is run, it sets it to the string transposition or the file demo 10 over here. If the program is imported by another program or another Python program, we can say. Similarly to how the program imports your paperclip module to call the function in it. So other programs might want to import same program to call its encrypt message str function without the main function running. So when an import statement is executed, Python looks for a particular module's file by adding a .py to the end of the file name. So this is how our program knows whether it's being run as a main program or imported by a different program as a module. So when you import a Python program and before the program is executed, the name variable is set to the file name part before .py. For example, here it is demo10.py, program is imported and all the dev statements are run, but the main function isn't called. So the encryption code for that we have, that Python hacking course message with the key of 8 will not be executed. So that is why the code that encrypts the my message str string with the my key str is inside a particular function, and this code inside main won't run your actual demo10.py program which is imported by another program, but these other programs can still call the encrypt message str function. That is how the function's code can be reused by other Python program in that case, right? So in this way we have seen a whole demonstration actually doing it manually also and then doing the same code in the Python program also. which has made our concept of how actually the transposition cipher works very much clear, right? So that's it from this session. Thank you very much. Welcome to the next session in Python hacking, that is about decrypting with the transposition cipher. Now, unlike the Caesar cipher, the decryption process of a transposition cipher is also different from an encryption process. So in this session, we will create another program which will be for decrypting the transposition cipher to handle the decryption. Also with that, we would be covering the round, math.ceil, math.floor functions, also and or boolean operators, and the truth table. Now coming to how to decrypt with the transposition cipher manually. As we had done manually the encryption part in the Excel format, we would also do it in the decryption format also. So the text that we have supposed to decrypt is this, that we had already encrypted. Now the first step is for decrypting is to calculate the number of boxes that need to be drawn. Now for determining this number, they must be dividing the length of the ciphertext message by a key and round it up to the nearest whole number if it is not a whole number already. Okay, so the length of the ciphertext that we have is basically 30 and the key that we have used is also 8. So if we divide 30 by 8, we get it at 3.75. So rounding up 3.75 will come to 4. So you'll have to draw the grid, that is 4 columns, and each column will have 8 rows, that is the key. So you also need to calculate the number of boxes which you have to shade in. That is using a total number of 32 boxes. So they will subtract the length of the ciphertext, so that is 32 minus 30, that is 2. So the shade of the bottom 2 boxes in the rightmost column would be shaded. So you will have to then start filling up the boxes, placing one character of the ciphertext in each box. Starting at the top left, they fill in towards the right as you did when you were encrypting it. So for example, now let's say we are drawing here 3, 4, 5, 6, 7, 8. Now let us just make this, and also we would increase the length of it a bit. Okay, and now what we'll do is we will start adding up these characters one by one. So the first one that we have is also we will just increase the font size here a bit. Now let's go on adding it one by one. Just the first character first, then O, S, then we come below, it is Y, C, U, S. Now let's just check this again. It is P, A, O, S, it is Y, C, U, S. Then it is T, K, R, A. So it is T, K, R, A. Then we have done till 4. The next 4 T, K, R, A. It is H, I, S, G. I, S, G. Then you have O, N, E, E. Again N, G. Now wherever you would be having their spaces, so here we would be filling up with this character. So you have here one space, then you have there a dot, then you have M, H, C, E, then again you have there the character. Okay, in all here also we have used 3 characters. Yes. Now this is just a blank or the last pipeline symbol there. So what we'll do is we have made some mistake here. Now this is a single. Here also we have used it. Now here we would also have again a space there. This is also same. Now here we would be having, see, we are supposed to leave the next 2 blocks as blank. So let us have there M, H, or we would have it here H, then C and E. So these 2 we would be inserting it as blank, the last one. So now in this way, this is correct, because after this we have one space. So we have inserted the space character. We have a full stop, after which we are having there again two values for space, then M, H, C, E. So after this, now this is how we have basically used it for decrypting. And now if you notice over here, let us write down the first character that we have, say PY, TH, ON, space, H. Then in the next one, what do you have? It is A, C, K, I, N, G, space, C. Then what do you have? O, U, R, S, E, space, M, E. And in the last one, S, S, A, G, E, full stop. That is what, if you combine that together, suppose, let's write down it over here, Python, H, A, C, K, I, N, G, C, O, U, R, S, E, M, E, S, S, A, G, E, dot. That's how we have again decrypted the message. So while encrypting, it is in horizontal way. While decrypting, it is in the vertical way. So a quick recap to the steps for decrypting. One is calculate the number of columns you need by dividing the length of the message by the key and then rounding it up. Second is draw boxes in column and rows. Use number of columns you calculated in the first step and the number of rows as the same as the key. Number 3 is calculate the number of boxes to shade in by taking the total number of boxes. That is subtracting the length of the ciphertext with the length of the normal key that you have. Next is shade the number of boxes you calculated in the earlier step at the bottom of the rightmost column. Then start filling up the characters of the ciphertext starting at the top row and going from left to right. Skip any of the shaded boxes. You will get a plain text by reading the leftmost column from the top to bottom and continuing to do so in each of the column. So note that if you have used a different key, you would draw a wrong number of rows. Even if you follow the other step in decryption process correctly, the plain text would be random garbage. Similarly, as you would use for a wrong key with a Caesar cipher. Now let us write down source code for this transposition decryption program. So for that, let's go back to our Python shell and create a new file. Now here the first thing is we need to also import math and paperclip. So we will say first import math, comma, paperclip. Then we would define again main here and we would have my message str. Now that's equal to, we would take down the encrypted text which is there here as it is. So let's put it here. Fine. And after this, let's remove the pipeline symbol. Here we would define my key str and that's equal to also 8. Then we would take here say plain text str which is for after encrypting. Now here we would be creating the decrypt message str method. Here we would pass my key str and my message str, and whatever the value is returned, that is what we are storing in plain text str. Then we would be printing that again, plain text str with concatenating a pipeline symbol. After which we also say paperclip dot use the copy method and copy the plain text str. Now after this method end over here and we define the next method, that is decrypt message str, which takes the key str and the message str. And inside this particular function that we have, now the transposition decrypt function will basically simulate the columns and the rows of the grid that the plain text is written on by using a list of strings. So first we need to calculate a few values there. Number of columns in our transposition grid. So for that we would take say number of columns, that's equal to, we convert it to integer using math.ceil, and here we pass the length of our message str divided by converting to float the value of key str. Okay. Then the number of rows in our grid, for that we would take number of rows that's equal to the key str. And the number of shaded box in the last column of the grid, for that we would take number of shaded boxes, and that's equal to, we have the number of columns multiplied by the number of rows that you have minus the length of the message str. Okay, and for each string in the plain text str, we would represent a column in the grid. So here we would take plain text str, that's equal to, we would take their list and multiply it with number of columns. Once we have done that, now the column and the row variables point to where the grid in the next character in the encrypted message will go. So here we take, say, col as equal to 0 and row also as equal to 0. And we start here a for loop saying, say, for sym in message str, and in this for loop we say the plain text str at the index of our column, that's plus is equal to the value of sym, and then you say column plus is equal to 1, that is point to the next column then. And after which, if there are no more columns or we are at the shaded box, then go back to the first column and the next row. So for that we will have to use here an if condition stating, and here we would say if column is equal to, say, number of columns, or we use here another, say, column is equal to number of columns minus 1, and row is more than equal to number of rows minus, say, number of shaded boxes. Then we are saying again here, say, column is equal to 0 and our row is plus is equal to 1 again. This will go in the if part that we have. After this, the next thing is we are supposed to only return dot join the value of plain text str. That would be the last statement here. And now we check if name is equal to main single quotes, then you call the main method. So let us save this, say Python hacking, say demo 13.py, and now the message that we have given is already copied here. So let us run the module and check. That is how you are getting it. The same way output comes. Now let's understand the code that we have written. Now the first part of our program is similar to the encryption part that we have done. That is, if we just go on to our program. So after this, until this, almost everything is similar. So the paperclip module is imported along with another module named math. And if you separate the module names with comma, you can import multiple modules in one single import statement, as we have done. Now the main function which we start defining creates the variable named myMessageStr and myKeyStr, and then calls the decryption function, that is decrypt message str. And the return value of the decrypt message str is the decrypted plain text of the ciphertext str and the key str, which is stored in the variable named plain text str, which is printed on the screen with a pipe character at the end in case there are spaces at the end of the message, and then copied to the clipboard. Now coming to the decrypting the message with the key. Now the decrypt message str function follows the 6 decrypting steps described earlier and then returns the result of decryption or as a string. Now to make your decryption easier, we will use functions from the math module which we imported earlier in the session. So we have used the round, math.ceil, math.floor functions. Now the Python's round functions will round a floating point number, that is a number with a decimal point, to the closest integer. So math.ceil, math.floor functions will round a number up and down respectively, When you divide numbers using the slash operator, the expression returns a floating point number. And this happens even if the number divides evenly. For example, if we go to the interactive shell here and try to say 21 divided by 7, we get 3.0, or in that case we say 22 divided by 5 is 4.4. So even if you want to round a number to the nearest integer, you can use the round function and see how it works. For example, you can use here, say, round in bracket 4.5. You get it 4. Or if you use round, for example, 4.9, still you get 5. Or if you say round, say 5.0, you get it 5. Or if you use here round 22 divided by 5, you get there 4. That is how they are basically rounded up to. Now, if you only want to round up, you need to use the math.ceil function, which represents ceiling. If you only want to round down, you use math.floor. Now, these functions exist in your math module, which you need to import before calling them. So now if you say, for example, math.floor and in bracket say 4.2, you get there 4. Or if you try to do math.floor in bracket 4.9, will still give you 4. Or if you say math.ceil 4.0, will take it 4. But if you say math.ceil 4.2, will take it to 5 and upper one. Or in that case, if you say math.ceil 4.9, will again take it to 5. So the floor function will always remove the decimal points from the floor and convert it to an integer to round down. And math.ceil will instead increment the one place of the floor and convert it to an integer to round it up. Now, we'll go back to our Python demo 13, and here the decrypt message str function that we have, it implements each of the description step as the Python code. It takes an integer key and a message string as arguments, and math.ceil function is used for the transposition decryption in the decrypt message str when the columns are calculated to determine number of boxes that need to be made. So now over here we are saying in this particular row that number of columns by dividing the length of the message by an integer in the key, and this value is passed on to math.ceil function, and that return value is stored in number of columns. To make this program compatible with Python 2, we can also call float, so the key becomes a floating point value. In Python 2, the result of dividing two integers is automatically rounded down. Calling float avoids this behavior without affecting the behavior under Python 3. The next thing, we calculate number of rows here, and that is an integer stored in the key str. This value gets stored in the variable number of rows. Then basically we calculate the number of shaded box here, which is number of columns twice or number of column times rows minus the length of the message str. And if you are decrypting the particular text with a key of 8, the number of columns is set to 4, number of rows is set to 8, and number of shaded box is set to 2, as we have done it in manual one. Now, just like the encryption program that we had a variable named ciphertext str, that was a list of strings to represent the grid of the ciphertext. Here also we have a list of string variables named plaintext str. And here the strings are blank at first with one string for each column of the grid. Now, using the list replication, you can multiply a list of one blank string by number of columns to make a list of several blank strings equal to number of columns needed. Now, keep in mind that this plain text is different from the plain text str in the main function, because the decrypt message str function and the main function has its own local scope, and the function's plain text variables are different and just happen to have the same name. So the plain text str variable will have the list of strings, and each string in the list will be a single column of this particular grid. So to make the list, we will first need to place each symbol in the message in the correct string inside the plain text str list one at a time. We'll create two variables named column and a row here, or col and row, to track the column and the row where the next character in the message should go. And these variables should start at 0 to begin the first column and the first row. That is why we have made this column and row as equal to 0. Then we start a for loop here that iterates over the characters in the message, and inside this loop the code will adjust the column and row variables so it concatenates symbol to the correct string in the plain text str list. Now at the end here we are concatenating. Here in the for loop we say plain text str at the index column plus is equal to sym. Now it basically concatenates the symbol to the string at the index column in the plain text list, because each string in the plain text represents a column. And then at the next line we add 1 to the column there. So we are basically incrementing the value of column, so that the next iteration of the loop symbol will be concatenated to the next string in the plain text list. Now we have handled incrementing column row, but we will also need to reset the variables to 0 in some cases. Now to understand the code that does that, we will need to understand the Boolean operators first. Now coming to the Boolean operators, it basically compares the Boolean values and evaluate to a Boolean value. The Boolean operators, that is AND and OR, can help you from more complicated conditions for if and while statements. And the AND operator connects two expressions and evaluates to true if both the expressions evaluate to true. The OR operator connects two expressions and evaluates to true if one or both are true. Otherwise, these expressions evaluate to false. Now to understand this in a more meaningful format, let's go back here, and here we say 10 more than 5 and 2 less than 4. This will give you the value true. But if you say 10 more than 5 and 4 not equal to 4 will give you false, because here one expression is true, second is false. In this case, both the given expressions are true. Now if you ever forgot how the Boolean operator works, you can just have a look at the truth table. For example, which will give you different combinations of the Boolean values evaluated to based on the operators which are used. For example, if we say true and true will give you true. If we say true and false will give you false. If we say first is false, second is true, still false. If we say both are false, till it is false. So in AND operator, only when both are true, it will evaluate to true. Now similarly, let us see how the OR operator interacts. If we say 10 is more than 5 and we use OR, 4 not equal to 4. Now in this case, one is true, one is false. The expression will give you true. If we say 10 is less than 5 or 4 is not equal to 4. Now in this case, both are false. So the value will come to false. Now again here, if you want to know the truth table for OR, if you say, for example, true or true will give you true. If you use true, first one, second one false, till it is true. If you say false or true, first one is false, second is true, still it will be true. Only when both the expression evaluates to false, this OR comes to false. Other than that, everything would be true. Similarly, if you want to say, for example, say not 10 more than 5 is false, or we say not 10 less than 5, this is true. If we say not false is true. If we say not false, this is also false. If we say not false, this will come to true. You can use multiple not operators, and the not operator truth table, if you want to look at it, if you use not true will be false. If you say not false will be true. So this is how we have seen the truth tables example, how the value will evaluate. So similarly, it will happen to how for loops let you do the same task as the while loops but with less code. And the AND and the OR operator also lets you shorten your code. Now for example, if you try to enter the particular text like if 10 is more than 5, you again check if 2 is less than 4, sorry, made a mistake. It is if 10 more than 5 colon, if 2 less than 4 colon, we say print Python. It prints Python, right? If we say if 10 more than 5 and 2 less than 4, we say print Python. It prints Python, but this is decreasing the lines of code that you are writing down. Now, you can also replace an if and else if statement with an or operator. For example, if we try to say 4 not equal to 4, one condition, we are saying print, say Python. We come out here and the next statement we give here, else if 10 more than 5, let's check out 4 not equal to 4 colon, we say print, say Python, and else if say 10 more than 5, we use print Python. So here again we get the value Python printed. Similarly, if we try to change this, we say 4 say not equal to 4 or 10 more than 5, then we give here a print, say Python. So we are replacing the if else if also with the help of or operators. Now coming to the order of the operations for the Boolean operators. Now let's try and do this. Say not false and false will give you false, or if you say in bracket not false and false will give you true in this case. Now in this case, the first line of code, the not false is evaluated first, so the expression becomes true, and false which evaluates to false, and the second line, the parentheses are evaluated first, so even before the not operator, so false and false, that is evaluated to false, so the expression not false becomes true. So now coming to adjusting the row and the column variables. So coming back to our program here, we know now how the Boolean operators basically work. So now there are two cases in which you will want to reset the column 0, so that the next iteration of the loop, that is symbol, is added to the first string in the list in the plain text str. In the first case, you want to do it if the column is incremented past the last index in the plain text str. And in this situation, the value in column will be equal to number of columns that we have already passed to it. Second case, if it is a column in the last index and the row variable is pointing to a row that has shaded box in the last column, as we have seen in the manual one. So in that case also you want the value of the column to be incremented and row also. So these two cases are why the condition that we have given there, that is over here in this particular column. If column is equal to number of columns, or column is equal to number of columns minus 1 and row is more than equal to the number of rows minus the number of shaded box. Now although this is looking a very big and a complicated expression, remember that you have break it down into smaller parts. The expression 1 is column is equal to number of columns, which checks whether the column variable is passed as an index range, and second part of the expression checks whether we have a column and a row index that is a shaded box. So if either of this expression is true, the block of the code that executes will reset the column to the first column by setting it to 0, and you will also increment the row variable. So after this, you have finished looping over every character in the message string, and the plain text list string have been modified, so they are now decrypted order. So the string in the plain text str list are joined together in the last statement, that is using the return statement here, which returns the string that is decrypt message str function returns. And at the first line, as we have done for the earlier one also, the first line of which our program would execute is this part of the code. After the importing modules and the execution of the def statement is the if statement which will execute. So as per the transposition encryption program, Python checks whether this program has been run by checking whether the name variable is set to the string value main. If so, the code executes the main function. And that is how we get the output of the decrypted message. So that's it from the session of decrypting your transposition cipher. We will continue with the next session. Okay, that's it from this session. Thank you very much.
Welcome to the next session in our Python hacking course, that is programming a program to test your particular program. So now here the transposition program seems to work pretty well at encrypting and decrypting different messages with various keys. But how do you know they always work? Now you cannot be absolutely sure the program always work unless you test the encrypt message and the decrypt message functions with all sorts of message and the key parameter values. But this would take a lot of time because you would have to type a message in an encryption program, set the key, run the encryption program, then paste the cipher text into the decryption program, set the key, and then run the decryption program. You would also need to repeat that process with several different keys and messages, resulting in a lot of boring work. Now, instead of this, we can write down another program that can generate a random message and a random key to test the cipher programs. Now, these programs will encrypt the message using the encrypt message method and then pass that particular ciphertext to your decrypt message method. And if a plain text returned by the decrypt message the same as the original message, then the program will know that the encryption and the decryption program have worked. Now, the process of testing a program automatically using another program is called as the automated testing. Now, several different messages and key combinations need to be tried, but it takes the computer only a minute or so to test thousands of combinations. So if all those tests pass, then you can be more certain that your code has worked. Now to cover this particular session, we would be also covering the random.randint function, the random.seed function. We will also see what are different types of list references. We will cover the copy.deepcopy functions, random.shuffle function, randomly scrambling a particular string, and sys.exit function. Okay. So now we would come for writing down a particular code for testing our transposition program. So here we would go for a new file and we would type first thing we require is import random, then sys, then transposition encrypt and transposition decrypt. Now we would be defining the main method here. Inside this, let us use the random.seed function, and here we are giving say a static value as say 42. Now this is we have set the random seed to a static value that we have set it here. Now below this we would run a for loop which will go in a range between 20. So we're basically going to run 20 tests for this encryption and decryption process. So this will generate some random messages which will be helpful for us to testing it. And then if you go inside this for loop, here we would create say a message str that is equal to, let's give some capital numbers. Okay, so GHIJKLMNOPQRSTUVWXYZ. Now we have given everything into capital. Then here we say multiply it by random.randint function wherein we are passing 4,40. Now this message that we have created will also have a random length. So that length we have defined it over here. After this, in the next line, we would say message str will equal to list in bracket
message str. Now here we are going to convert the message str string to a list, which will be basically used to shuffle. And then after this, we would use the random.shuffle function. And in this also we would pass the message str. Now after we have shuffled this, we will create message str is equal to blank, then dot join, and again let's give here message str. Now this is basically used to convert the list back to a string. And then don't forget to give a print command here. We are giving say test hash. We print here in %s colon double quotes %s, close this single quotes, give here in bracket I plus 1 comma the value of message str colon 50 in square bracket, and let's close the round bracket. Now after this, we will have to check for all the possible keys for each message. So for that, we would go for say key str in a range. We are giving here starting from 1 and converting it to integer the length of your message str divided by 2. And after this, let's create here say encrypted str, that's equal to, now here we are going to use the transposition, say transposition encrypt dot, we will use the encrypt message method, and we will pass here the key str and the message str. Whatever the value will be returned will be stored in this encrypted str. Similarly, here we will use decrypted str, that's equal to say transposition, use the decrypt dot decrypt message, and again here we'll use the key str, but now for decrypting it we'll have to pass the value that is encrypted str here, so that the same encrypted text would be again decrypted. So if the decryption doesn't match the original message, we have to display an error message and we'll have to quit. So now after this, we will have to go for another say if, checking for the message str. If that is not equal to your decrypted str, then what are you supposed to do? We will give here a print saying say mismatch with key str %s and message str %s, close it and print here the values of key str comma message str. After this, we will again print another saying the decrypted as colon, close this and print here the value of decrypted str. And after this, we would say sys.exit. Now once this is done, the next thing we'll have to do is, let's come out of this and move back in the for loop here. And here we would be printing say the transposition cipher test has passed successfully. That will be the end of this particular session, that we have defined the main method. Now if we have to run the main method as in the earlier one we have done, we will have to check name underscore is equal to in single quotes main, then you will have to call the main method. So now let us save this again in hiking course and we'll save it as demo 14.py, and let us try and run this particular example. Transposition encrypt. Fine. Let us just check if we have made any spelling mistake there. So that's over here. So we have used the transposition, E capital it is, and encrypt Now here the files that we have created earlier, that is demo 10 for encryption and demo 13 for decryption, that we will have to use here. So let us just substitute the file names, and also the method is encrypt message str and decrypt message str. So rest everything looks good. Now let us execute this. It is encrypt message, it's str. Let us run this again. Fine. Let's open up the demo 10, and here we have encrypt message str file. So let us copy this in the current demo. Similarly, we also have in demo 13 it is decrypt message str. Now let us save it and run it again. Decrypt message str has no attributes. Look at the file demo 13. There we have decrypt. M is also small. Fine, no issues. Let's open up demo 14, the current one, and let us substitute the file there. Okay, now let's try and execute it. So now it is executing. We have totally given there till the range of 20. So we will have the 20 test, which it will take with the help of different keys and the message that we have given in the encrypt and decrypt file. And after everything is successful, it would give us the message as transposition cipher test has passed successfully. So after we have completed the output, now over here, the tester program creates a random message and chooses a random key also. So it doesn't matter that the message is just some random letters, because the program only needs to check that encrypting and then decrypting the message results in the original message again. So using a loop, the program repeats this particular test 20 times as we have seen. And if any point the string returned from the decrypt method isn't the same as the original message, then you would get there the error, which would print the error that we have given, that it is not matching or mismatch of the text. Now let us explore the source code that we have written in our demo 14.py program. So over here, the first thing we have done is, if you look at the first line, that's our import statement, where we have imported the modules, including the one which we have already seen, that is random, sys, and also the programs which we have earlier created, that is demo 10 and demo 13, by just typing their names without the .py extension, because that is not required. Now after this, we'll move on to creating the pseudo-random numbers. Now to create some random numbers which will help for generating the messages and the keys, we are basically using here the random modules seed function. Now before we delve into what the seed does, now let us just have a look at how the random numbers works in Python by trying out some random.randint functions. Now this function that we will be using later in this session takes two integer arguments and returns a random integer between those two integers, including the integers that you have passed on. Now for example, if we go back to our interactive shell here and we say, for example, say import random, and here we say random.randint, we pass 1, 20. We'll get any value, random value in between those two. Similarly, you again say, for example, random.randint 1, 20. This time you would get some different values. Or for that case, you say another range, say 100, 2000. Would get any value between 100 to 2000. Now, of course, the numbers you get will probably be different from those that we are seeing over here, because this is what we are executing at that time. We are getting some random numbers. So you might not get the output as same. But these numbers generated by random.randint functions are not truly random. They are produced from a pseudo-random number generator algorithm, which takes an initial number and produces other numbers based on some formulas. Now the initial number that the pseudo-random number generator starts width is called as the seed. So if you know the seed, the rest of the numbers the generator produces are quite predictable, because when you see the seed to a particular or a specific number, the same numbers will be generated in the same order. Now these random looking but predictable numbers are also called as pseudo-random numbers. Python programs for which you don't set a seed use the computer's current clock time to set a particular seed. You can reset the Python's random seed by calling the random.seed function. Now we would see certain variations of the pseudo-random numbers which aren't completely random by entering something in the interactive shell, but we would do that in the next session and look at the output. That's it from this current session. Thank you very much. Now let us just have a look here. If we say import the random, then we say random, we use here the seed value as 42. We give here number str as blank, and we run a for loop for i1 in the range. Say we are generating say 25 values for example, and in this values we are giving say number str dot append the values generated from random dot randint 1 comma 25, after which we give here a print command for number str. We get those 25 numbers generated. Again, second time, if we say random dot, again using the same seed value here as above, that is 42, and again we are saying number str equals to blank, then we again run a for loop, say i1 in the range, say 25, open the loop, and say here number str dot append the random dot randint 1 comma 25, and then again we give print for number str. So again, if you just compare the values, all the values are exactly the same as we have in the first one. So here we have generated say 25 numbers twice using the same seed value. First we have imported and then set the seed to 42. Then we have set up a list called as number str where we are storing all our generated numbers. We use a for loop for this to generate 20 numbers, and we are appending each one to the number str, which we print so that we see the every number that was generated. Now when the seed of the Python pseudo-random number generator is set to 42, the first random number between 1 and 25 will always be say 21. The second number will always be say 4. The third number will always be say 1. And the same set of pseudo-random numbers is returned from random.randint, as you can see by comparing the numbers str, both the print command that we have executed. So the random numbers will become important for ciphers in the later sessions because they are used not only for testing ciphers but also for encrypting and decrypting in a more complex ciphers. So random numbers are so important that one common security flaw in encryption software is using a predictable random numbers. If a random numbers in your programs can be predicted, then a cryptanalyst can use this information to break your cipher. So selecting the encryption key is a truly random manner is necessary for the security of a cipher. But for other uses, such as this code that we have used, the pseudo-random numbers are fine. We'll also see the use of pseudo-random numbers to generate test strings for our tester programs. Now, you can generate truly random numbers with Python by using the random.systemRandom.randint functions. We will learn this later in the particular session. So now we'll move on to creating a random string. Now that you have learned how to use your random.randint method or the function and random.seed function to create your random numbers, now let us return to the source code that we have used. So let's go to our demo14.py code and now see what completely automated code we have written for encryption and decryption programs. Now for doing this, we will have to take a string of characters to use in the message string or message str, duplicate it a random number of times and store that as a string. And then we will take the string of the duplicated characters and scramble them to make them more random. We'll also generate a new random string for each test, so we can try many different letter combinations or character combinations. So first of all, let us set up the main function which contains the code that tests the cipher program. And it starts by setting a seed of the pseudo random string there. So inside the main, we first of all set random.seed in bracket 42. So setting the random seed by calling random.seed is useful for a tester program because you want predictable numbers. So the same pseudo random message and the key str are chosen each time the program is run. So as a result, if you notice one message fails to encrypt decrypt properly, you will be able to reproduce this failing the test cases. Next, what we'll have to do is duplicate a string using a for loop. So duplicating a string a random number of times, we are using here a loop which will run for 20 tests and to generate our random messages. So we run a loop saying for I in the range of 20. We generate certain random values over here or random messages. So each time the for loop iterates, the program will create and test a new message. We want this program to run multiple tests because the more tests we try, the more certain will be that program works. So later in the particular line, we have the testing code that creates a message of a random length, and it takes a string of uppercase characters and uses the randint method over here. So after this, we are multiplying it by random.randint and giving there the value or giving the string replication to duplicate the string a random number of times between 4 and 40. That's the range that we have given. And then it will store the new string in the same message str variable. So if we leave the message str string as it is now, it will always be just the alphabet string repeated a random number of times. Because we want to test different combination of characters or letters, we will need to take things a step further and scramble the characters in the message. To do that, let us first learn a bit more about what are lists. Coming to the list variables and the use references. Now variables store lists differently than they store other values. A variable will contain a reference to the list rather than the list itself. A reference is just a value that points to some bit of data, and a list reference is a value that points to the list. So this results in slightly different behavior of your code. Now that you know what are the variables, store strings and integer values, we would enter certain commands in the interactive shell and check the output. For example, we'll go back here and let us try to type, say span equals to 42, for example. Say cheese equal to the value of span. Let's give span equals to 100 and let's try to print the value of span. Oh, sorry, we made a mistake. Span is 42. Cheese equal to span. Span equal to 100. And now let's print. So we get the value 100. Now let's try to print the value of cheese. It is still 42. So we have assigned 42 to the first span variable, and then we copy that value of the span and assign it to the variable cheese. So when we later change the value in span to 100, a new number doesn't affect the value in the cheese variable, because span and cheese are totally different variables that store different values. But list doesn't work this way. When we assign a list to a variable, we are actually assigning a list reference to the variable. So if we try to make certain code that makes the distinction easier to understand, for example, we try to make, say, list 1 that's equal to, we give here certain values in list, okay, 1 to 7 for example, and then we create, say, var1 that's equal to, we give list 1. Then we try to make var1 at the index 1, we try to give there some text, say, let's write down Python for example, and now let's try to print the value of list 1. You see, in list 1 also it has changed, and if we try to print a value through var1, even var1 has changed. So this code might look odd to you. The code changes or changed not only the variable, that is var1, but both var1 and list1 values also. So when we create a list, we assign a reference to it in the variable. But in the next line, we have copied only the list reference in the variable, that is var1 or list1 to var1, not the list value. This means that the value stored in the list1 and var1 now both refer to the same list. So there is only one underlying list because the actual list was never actually copied. So when we modify the first element of the var1 variable, we are actually modifying the same list that list1 refers to. Let us understand another concept, that is passing references. Now references are particularly important for understanding how arguments are passed to the functions or methods. When a function is called, the argument values are copied to the parameter values. And for list, this means a copy of a reference is used for the parameter. Now to see the consequences of this action, we will create a new file and we would enter certain code into it and then try to execute it. So let us go back here and say a new file. We would define here a particular method, say dummy1. In this, we are giving parameter 1. And in this particular method, we are saying parameter 1 dot append, say Python as a text. After this, we come back here, we create list1 that's equal to say 1, 2, 3. Some values are given. Then we call there the method that is dummy1 and we pass this list1 as the parameter to it. And then we try to print the value of the list1. Now let us save this as say demo15.py, that's eDrive hacking course. And let us try to run this. So we are getting 1, 2, 3 and plus one more value is appended to it. So when you run the particular code, we have noticed that the method that is called a return value isn't used to assign a new value to the variable that we have created. Instead, a list is modified directly. So when we run the program, we get the value as 1, 2, 3, Python. Even though we are having two different variables. One is, if we look at our program, one is our list1 and one is the parameter, that is parameter 1. They contain separate references. They both refer to the same list. Now this is why the append Python method call inside the function affects the list even after the function call has returned. So keep this behavior in mind. Forgetting that Python handles list variables this way can lead to some confusing bugs. So coming to using the copy.deepcopy to duplicate a particular list value. Now if you want to copy a list value, you can import the copy module to call the copy.deepcopy function, which returns a separate copy of the list. It is that has been basically passed to it. For example, if we go for the, let's close this dummy now and let's go back here and we try to create say a var that's equal to 0, 1, 2, 3, 4, 5, 6, 7. Now we say import copy. Then we say another variable, say var2 that's equal to, we use copy.deepcopy and we pass there the var as the variable. Then we say the var2 at the index of 1, we want their Python to be printed. And now we print the value of var. We get 0, 1, 2, 3, 4, 5, 6, 7. But now if we var2, we get in var2 we have edited this. That's 0, 1, then we have Python 3, 4, 5, 6, 7. Now because the copy.deepcopy function was used to copy the list in the variable that is var to var2. When an item in the var2 is changed, the original var is unaffected. We would be using this later in some sessions when we come back to some simple substitution ciphers. That's it from this session. Thank you very much. Now let's have a look at random.shuffle function. Now with a foundation in how the references work, we can now understand how the random.shuffle function that we will be using next works. The random.shuffle function is a part of the random module, and it accepts a list of argument whose items is randomly rearranges. We will enter certain code in the interactive shell and see how the random.shuffle works. So over here, the first thing we will have to do is import random. Then we'll create a var that's equal to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we would try to print the value of where we get all the values printed. Then we will use random.shuffle and we'll pass the same variable as the parameter to it. And then we will try to print the value of where it has randomly shuffled it. Again, if we say random.shuffle, again pass the same variable in the parameter and again try to print the values. Again, it has been shuffled with some random values. So an important detail to note is that shuffle does not return a list value. Instead, it changes the list value that is passed to it, because shuffle modifies the list directly from the list reference values that is passed. The shuffle function modifies the list in place, which is why we execute random.shuffle and we pass the variable instead of saying the variable is equal to random.shuffle and again the variable to be passed. So coming on to randomly scrabbling a particular string. So if we return to our code in demo14.py, over here if you see, we are using the message str is equal to list in bracket message str and saying random.shuffle the value of message str. Now the return value from the list is a list which one character strings of each character in the string that is passed to it. So we're reassigning the message to be a list of its characters. Next, we use shuffle that randomizes the order of the items in the message. And the program converts the list of string back to a string value using the join method over here. Now this shuffling of a message string allows us to test many different messages. So now coming to testing each message over here in the print one. Now that the random message has been made, the program tests the encryption and the decryption functions with it. Now we'll have the program print some feedback so that we see what's going while it is testing. Hence we have given this print command. Now here we have called the print that displays which test number the program is on. So we have added 1 to I over here because by default it starts from 0. And the test numbers should start at 1. Because the string in the message str can be long, we are using a string slicing to show only the first 50 characters. Hence, we are not displaying the whole message str but only the first 50 characters of the message. Now next, we also use string interpolation, the value that I plus 1 evaluate, to replace the first %s in the string and the value that message str:50 evaluates to replace the second %s. When using the string interpolation, be sure that the number of %s in the string matches the number of values that are between the parentheses after it. Now next, we will test all the possible keys. Although the key for a Caesar cipher would be an integer between 0 to 65, the length of the symbol or something like that. And the key for the transposition cipher can be between 1.5 or the length of the message. So the for loop here runs the test code with the key 1 up to the length of the message. Hence we have run this for loop here. That is half of the length of the message. So then we are creating two variables, that is encrypted and decrypted. So the encrypt the string in a message using the method that is encrypt message str that we have inside the file demo10.py. So we need to add the demo10 file name dot, that is a period sign at the end, and a function name. So the encrypted string that is returned from this encrypt message str is then passed on to the decrypted str or decrypt message str. Now the return value from the decrypt message str is stored in the variable name decrypted. And if the function works, the string in the message should be the same as the string in the decrypted. Now we will look at the program that checks for this. So over here, after we have encrypted and decrypted the message, we need to check whether both the processes worked correctly. So to do that, we simply need to check whether the original message is the same as the decrypted message. Hence, we have written this particular code where we test whether the message str and the decrypted str are equal. And if they aren't, then Python displays an error message on the next line that prints the key, the message and the decrypted value as the feedback to help us figure out what went wrong. And then the program would exit. So normally the program exits when the execution reaches the end of the code and there are no more lines of execute. However, when we say sys.exit is called, the program ends immediately and stop testing the new messages, because you will have to fix your cipher program even if one test fails. But if the value in the message str and the decrypted str are equal, the program execution skips the if statement blocks and call to the sys.exit. Program continues looping until it finishes running all of the tests. And after the loop ends, the program runs, which you know in the outside of the loop here, and come here on the last print statement, which prints the transposition cipher test has passed successfully. Now after this, we'll come on to calling the main function. So as with our other programs, we want to check whether the program is being imported as a module or being run as the main file. So we are checking whether the special variable _name_ is set to main, and if so, we are calling the main function. Now let's see testing our test program that we have run. Now we have written a program that tests the transposition cipher programs. But how do we know that the test program works? If the test program has a bug and it just indicates that the transposition cipher programs work when they really don't, then we can test this program by purposefully adding a bug to the encryption or the decryption function. Thus, if the test program doesn't detect a problem, we would know that it isn't running as expected. Now to add a bug in the particular program, we would go to our demo10.py file and we would add a certain line of code there. So let us go to our, say, demo10.py and let us add over here, say, current IDX plus is equal to key str plus 1. Let us save this, and now let us again open our demo14.py and now let's try to run the module. Got it? Mismatch with key str1 and the given particular message decrypted as this. So now that is not proper. So we have got the error message. When we test our program, we get an error message that we have printed. So the test program has to fail at the first message after we purposefully inserted a bug there. So we know that isn't working exactly as we have planned. So now if you just go back there, go to your demo 10, you remove this bug, you save it. Now let us close this demo 10, go back to our demo 14 and again, try to run the module. Now again, you would not have any error. It will automatically execute successfully. So that is how we have actually added a bug and even tested if that error part was executing in our given Python program. So with this, we have concluded our testing of the transposition cipher with multiple key values. So that's it from this particular session. Hope you have understood with the help of the example that we have done. Thank you very much. Now, before proceeding to the next session of encrypting and decrypting using files, we would do another example of implementing the columnar transposition in Python. So let us create here a new file and let's try and do it using import math first. We will create here a key and we would give here a text, say hack for example. Now for encryption, we are going to define a method that is encrypt message str, in which we would pass the msg str as a parameter, and here we would define the cipher str equals to blank initially. Then we would track the key indices by giving the key underscore idx that's equal to 0. Then we give here the message length that's equal to, convert to float the value of length message str. Similarly, next we would take msg list or lst that's equal to, we convert to list the value of message str, and then we take the key lst that's equal to sorted in bracket, we would pass list in bracket the key str. And after this, let us calculate the column of the matrix. So let's create here column str that's equal to the length of key str, and calculate the maximum row of the matrix by giving row is equal to, say, int in bracket math dot ceil. We'll use in bracket the msg length len that we have created divided by the column str. That would be our value for row that we are calculating. Then let us add some padding characters, say underscore, in the empty and the empty cell of the matrix. So for that we will say fill null variable that is equal to, we convert to integer the value of, say, row multiplied by the column str minus the msg len. After this, we create the message list that we create dot, we use the extend method, and here we give an underscore sign multiplied by, say, the value fill null, that earlier one which we create. Then we create matrix and we insert the message and the padding characters row wise in this. So we create here, say, matrix str variable which is equal to our message list variable. In bracket, let's take I colon I plus the value of column str, and here we say for I in the range, and we give here, say, 0 comma the length of message lst comma the column str. Close the bracket. Now we would read the matrix column wise using the key. So for that, let's take for underscore in the range of column str, and in this we would write down the current idx is equal to the key str dot find out the index of key list in bracket the value of key underscore index or idx. Then don't forget to close the round bracket. Then we create the cipher str that's plus is equal to blank, then dot join, and here we use row in bracket the current idx, close it, and after this we say for row in the matrix str, close the brackets, create here the key underscore idx as plus is equal to 1. After this return statement, we would say here the return as value of cipher str, and that is with our encrypt message str. In the same program, we would define another method for decrypt message. So let us go for defining a decrypt message str, which again takes here the cipher str parameter, because whatever we have encrypted, that parameter only has to be passed for the decrypt message. So now in this decrypt message str, we create an msg str variable that's equal to blank. Again, we would need to track the key indexes. So we'll take here key underscore idx that's initially equal to 0. To track the message indices, we would take msg idx that's also equal to 0. The message length that's equal to our float in bracket the length of your cipher str, and message lst, that is list, is equal to convert to list the value of cipher str. Now after we have got all the values, we would calculate the column of the matrix. So let's take column str is equal to the length of key str. After which we say the row is equal to convert to integer, say math.ceil, use the message msg length divided by the column str value, that is your value for row, and then we would convert the key into the list and sort alphabetically so we can access each character by its alphabetical position. So we say after this the key lst is equal to use here sorted method and sort the values using the key str. Okay, now we'll create an empty matrix to store the deciphered message. So here we create des cipher str, that's equal to blank initially, and then we run underscore in the range row. Here we run using the dec cipher str, use plus is equal to none multiplied by the column str, close the square bracket, and then we would arrange the matrix the column wise according to the permutation order by adding into a new matrix. So here again we would run for underscore in the range of now column str, and here we say the current variable for current idx is current idx we have used. Okay, that is equal to the key str dot use the index in bracket the key list that you have created, the bracket key underscore idx, and after this we create another for loop, say j1 in the range of your row. Here we use the dec cipher str at the index j1 and the second index as current idx, that's equal to we use the message lst index of message idx, and here we say the message idx plus is equal to 1, and here we say the key underscore idx is plus is equal to 1. Now once we have done this, we will have to convert the decrypted message matrix into a string. So for that we would go one level back and say here try, give here the value, say msg str, that's equal to blank dot we use join, in bracket we give the sum of dec cipher str comma square brackets, and then we say here except the type error colon, we are raising here the type error saying say this program cannot handle repeating words, close it, and then we create here a null count that's equal to our message str dot count the underscore value, and check if your null count is more than 0, then we are saying return the message str using the string as minus null underscore or null count in the square bracket. Now once you have completed this, don't forget to return the value of message, and once that is done we return the value of message str. Here we would create msd str value, and we are giving here the code as say this is Python hacking message, and here we are first calling the encrypt str is a variable that we have created where we are calling the encrypt message str, passing the msd str variable there. Then we are printing the value of encrypt str variable. We again create a decrypt str wherein we are calling the decrypt message str, and now we are passing in this the encrypt str, because whatever is encrypted, the same thing we are supposed to decrypt, and then we are printing here the value of decrypt str. Let us save this in same folder by the name, say, demo16.py, and let us try to run the module. Now that is, let's see on line number 7 first. So let's go back here and let's go to line number 7. Oh, that is list. Made a mistake there. Key str is not defined on line number 8. Fine. So here we have defined key str. Where it is, or encrypt str. Oh, spelling mistake. Line number 64. Let's go to line 64. And this is YPT. Again, let us run the module. Cipher str is not defined. That is line number 30 it was. So we are having here cipher str, not T. Let's save it, run it again. So this is how it has been encrypted, and the same text has been taken for decrypt, and this is the original message that we have written, which is passed on to encrypt it, and this message is passed on to decrypt to get the back your original message. So likewise, we have done another demonstration wherein we have combined both the files together for encrypting it and for decrypting it. So if you now try to import this file that we have, for example demo16, in another file, and you want to use both the encrypt and decrypt methods, is quite possible. So you don't need to import two different files, just import one file, that is demo16, and using demo16 dot encrypt message str for encrypting it, and demo16 for dot decrypt message str for decrypting a particular message and getting the value returned. Hence we are returning this value everywhere so that you can save it in another variable like this and print it wherever you are using it. So that's it from this session. Thank you very much. So now we'll move to the last session in our first beginner level course of Python hacking, that is encrypting and decrypting using files. Now in the previous session, we have worked or created programs that have only worked on small messages that we type directly into the code files as some string values. Now the cipher programs we'll make in this session will allow you to encrypt and decrypt the entire file, which can have millions of characters in size. Also, along with this, the following topics would be covered in this session, that is using the open function, reading and writing files, using the write, close and read file object methods, using the os.path.exit function, using upper, lower and title string methods, using the starts with, ends with string methods, also the time module and the time.time function. Now understanding what are plain text files, the transposition file cipher program encrypts and decrypts the plain text files. Now these are the kind of files that only have some text data and usually have a .txt as the file extension. You can write your own text files with programs such as Notepad on Windows or TextEdit on Mac OS or gedit on Linux. Now you can even use the IDLE's file editor by saving the file with an txt extension instead of the usual .py extension. Now we'll use some simple text files in this particular session, which will have certain characters or data already there, which we are only using for encrypting it and again to decrypt it. So in this particular session where we'll be covering the module part, also if you just look at our Python hacking beginner folder, So in this Python hacking beginner folder, we are having this dummy.txt file, which is having some text data into it, which we are going to use in our session for encrypting it and again for decrypting it also. So we would first of all create the program for transposition file cipher for encrypting it and decrypting it. So let us go back here and we'll go for a new file, and here we will have to again import our demo 10 and demo 13 here also. But before that, we will say import time, say os/sys/ our demo 10 and demo 13. And after this, we define the main method wherein we give the input file name str as equal to our dummy.txt, and we have placed this in the same folder where we are going to save the current file. Otherwise, be careful to give the whole path if it is not existing. Again, if the file is not existing, you will get an error. So be sure that the file is existing into your particular folder. Now this is the input file name that we have given. Similarly, we also require some output file name str, and here we would be giving say dummy.encrypted.txt, just to make it a difference that the earlier one is a normal file and this is our encrypted file. Hence we have given the file name .encrypted.txt. Then we give there say my key str, that's equal to, let's give our key as say 10, and say my mode str is equal to, we are first of all doing it encrypt. So first time when we are doing it encrypt, we are setting to encrypt. If we want to do a decrypt, set this value to decrypt. So we will do that later on when we would be decrypting it. Then coming to the next one. Now if the file input does not exist, the program would terminate. So for that we are checking if not the os dot the path dot exist, and in this you give the file input file name str parameter. So if it is not existing, we are giving an appropriate message to the user saying the file say %s say does not exist and quitting the program. And here you give in % format the value of the input file name str. After which we say here sys.exit, which will exit the particular program totally. And if the output file already exists, give the user a chance to quit. So again, the output file should also be not existing because we are creating the file there. So for that, we would check here in another if, saying if os dot path dot exist, and here we give the output file name str variable. Then we give here a print message as say this will overwrite the file, print here %s, and in this we give c continue or in bracket q for quit. Give this to the user as a message and print their output file name str. Then whatever the response the user gives, here we store it in the response str variable by taking there the input and then after which we say if not the response str dot lower dot starts with, we say c, then you say sys dot exit again. Otherwise, if everything is proper, then we'll go here and create another file obj str, and we will open the file that we are passed to input file name str. So if the file is there, everything is proper, then you pass that to the file object. And again, the value for content str would be your file obj str dot using the read method, and the file obj str dot, don't forget to close it after it has read it successfully. So once that is done, we go on for a print, and in this we say print in percentage, say SING, print the value of, say, my mode. Now here, okay, so that is my mode str dot, say, title. After this, now we will be measuring how long the encryption and decryption takes place. So for that, we create here a start time, which is equal to, we use time.time method, and we check if my mode str is equal to encrypt. Then what are you supposed to do? We are using here a translated str that's equal to, we are using demo10 dot encrypt message str, passing there my key str and the content str as the variables. Then we have another else if, we are checking my mode str if it is equal to decrypt. Then what are you supposed to do? Again here we take translated str, and that is equal to, now we use demo13 dot decrypt message str, in bracket we pass my key str and again the value of content str. Now we will be taking total time str, and that is equal to, we are rounding off here the value of time.time minus the value of start time that we have already taken, and round it off to 2. After which we give here print command. Now this will be over here, even translated will go there, and after this we would give a print command here, say percent timing colon percent s seconds, say percent giving my mode str dot title comma total time str. Now we would write out the translated message to the output file that we have created. So here we would take the output file. Now we have taken here output file name str there. So likewise we have created the file object here. We would also create the output file obj str, and that's equal to, first thing is we would open the output file name str and open this in the write mode, hence we have given w, because now we want to write something in it. Okay, similarly output file obj str dot use the write method and put the value of translated into it. Similarly then say output file obj str, don't forget to close it. So one way we have read it from one file, and in the other one we have inserted that encrypted data into the other file. Now once we have done this, we will move on to the next print command, wherein we are saying done percent %sing percent %s in bracket s characters dot percent, say in bracket we print the value of my mode str comma the input file name str comma the length of your content str. After which the next print command we would give is in single quotes, say percent %sed file is percent %s, and we print here say my mode str dot title and the output file name str. Now once we have given this print command, the last one that we need to do here is in the main. Here we would say if the name is equal to main in single quotes, call the main method. Fine. Now let us save this as demo. We are having 16 done, so we would take it as say demo 17.py and let us try and execute this. Okay, encrypting, and then we got an error, translator is not defined. Okay, now this is not translated over here, we made a mistake, that is translated str, so this one. Okay, let's save this again and try to run this. We'll overwrite, take it C, encrypting. Encryption time it has taken 0.77 seconds. Done encrypting the file dummy.txt and the encrypted file is dummy.encrypted.txt. Now let us check whether this file has been created. So if we go to our Python hacking beginner method, here we come in the folder, we have dummy.encrypted.txt. If you try to open up, see, the whole file that we have is totally encrypted and it is not able to be readable now, right? So if you have to read, you have to again decrypt the whole file and then you will have to read it. So in just some seconds, we have decrypted the whole of the file that we have and created another file, that is another txt file in the same folder. So now what if you are supposed to decrypt it? Let us check out in our program, that is demo 17. Now the first thing is our input file name over here will change. So now it would be demo.encrypted.txt and here we will create a file that is say decrypted.txt, output file name, and here we would give the mode now as not encrypt but decrypt, and others everything we would keep it same. Let us save this and let us try to run it again. So now it is decrypting. Decryption time taken is more or less than the time which was required earlier. Done decrypting the file and now decrypted file is your dummy.decrypted.txt. Let's have a look in our folder whether we have this file created. Yes. If you open up, everything looks like normal. Now it is readable, a normal human readable file. So in this way, the normal file was encrypted. The same file was again decrypted. That's it from this session. Thank you very much. Now let us understand how the program works. Now here we will first of all see working with the files in Python. Now before we dive into the code for our file, that is demo 17.py, we will first of all examine how Python works with files. So the three steps to reading the content of a file are: first is opening the file, then reading the content or the file content into a normal variable, and finally closing the file. So similarly, to write a new content in a file, we must open or create the file, write the new content, and again close the files. So coming to opening a file. Now in Python, we can open a file to read from or write to using the open function. The open function first parameter is the name of the file to open. If it is the file in the same folder as the current Python program that you are typing, then you just give the file name there. The command to open the file, if it existed in the same folder as your Python folder, would basically look like if you give like here the file object and we are giving here the file name, and then we are saying the file object str is equal to open and pass. Now a file object is basically stored in a file object variable which will be used to read from or write to the file. You can also specify the absolute path of a particular file which includes the folder and the parent folders that the file is in. For example, if it is something like say in E drive user folder /python /abc.txt. So you will have to give that C:// users / then python / and the filename.txt is actually your absolute path. So remember that on Windows the backslash must be escaped by typing another backslash before it. Now suppose you want to pass the path of the file as a string for the open function's first parameter. Then you can directly say here, instead of giving the object name here, you can give open in bracket the path of the file. The file object has several methods for reading to or writing to, reading from and closing the file. So coming to the writing to and the closing of files. Now for the encryption program, after reading the text file content, you will need to write the encrypted or decrypted content to a new file, which you would be doing using the write method. So to use the write method on the file object, you need to open the file object in write mode, which you do by passing open the string w as the second parameter like we have done over here. Now this second parameter or the argument is an optional parameter because open function can still be used without passing two arguments. Now like here we have given w, this creates a file named say output file name str, which is having the file name for the output file is in the write mode, so you can edit it. So if a file of the same name exists where the open function creates a new file, the old file would be overridden. So be careful when using the open in the write mode. Now using the particular file, now in the open in write mode, you can write to the file by calling the write method here. And the write method takes one argument, a string of a text which you want to write to the file. So here you can enter something in the interactive shell. For example, say we go back here and the first thing that we do here is we will open the file. So let's take here the file obj str, that's equal to, we open one file say abc.txt. Okay, now we have to first create this file. So what we'll have to do is we'll have to go to this folder and let us create here file say abc.txt. And now here we would say file objstr.open. We will give here abc.txt and we want to open it in write mode. So rather here we would say is equal to, the first thing is we would give there the open command, that is our file object name is equal to open. And now once we have opened the particular file, we say file objstr dot, we use write method, we print here say hello python file object. We pressed enter. Now suppose you go back here and try to open abc. We have not yet closed the particular file. So what we would do is file object str dot close first and then we would open abc. You get there hello python file object printed. So when you pass the string to the write method, it writes that string to the text file and prints a particular number, that is the number of characters in the string returned to the file. And when you are finished working with a file, you need to tell Python that it is done with the by calling the function close method on the file object as we have done. So there is also an append mode, which is like write mode, except append mode doesn't override the file. So instead strings are written to the end of the content already in the file. Although we don't use this in this particular program, you can open a file in the append mode also by passing a string a as the second argument to the open function. So if you get some error like io.unsupported operation or not readable error message, then when you are trying to call the write on a file object, you might not have opened the file in the write mode. So when you don't include the open function's optional parameter, it automatically opens the file in read mode that is R instead, which allows you to only use the read method on the file object, not writing. So let us now see reading the data from the file. Instead of going in the file directly over here from Python, we can use the read method, which returns a string containing all the text in the file. Now, to try out that, we will read the same abc.txt file which we have created earlier with the write method. So now for that, we would take say file object str is equal to, again we would give open abc.txt. Now we are giving here R. So even if you don't give R, by default it is in the read mode. But still we are specifying that we want to give R. Then we give here content str is equal to, we give file object str dot use the read method and store the values in the given variables. Then we say print the value of content str here, which would print whatever string you have in the particular file. And once you have done, don't forget to again close the file object. So here the file is open and the file object that is created is stored in the file object str variable. So once you have the file object with you, you can read the file using the read method and store in it the content str variable, which you then print for printing the values in the file data. Now, if you get some error messages like IO error or error number 2 or no such file or directory is there, then make sure that the file actually is where you think it is, and double click or double check that name that you have typed and the folder name also. Or if it is in a proper directory, so check if the directory is another word or a particular folder. Now we would be using this open, read, write, close on our files that we have opened to encrypt or decrypt in our demo that we have created. So now let's go back to our demo 17.py and let us see setting up our main function. Now the first part of this program should look familiar. We have an import statement which is importing our data, that is the time object. If you look at the first statement here, then we are importing the OS, the sys, the demo 10 and the demo 13 parameters. Now then we start with our main by setting up some variables to use in our program. That is our input file name str variable, which holds a string of a file to read, and the encrypted file or the decrypted text is written to the file name in the output file name str. The transposition cipher uses an integer for a key which is stored in your myKeyStr variable, and the program accepts the myModeStr variable, which will store either encrypt or decrypt to tell it to encrypt or decrypt the file input name str file. But before we can read from the input file name str, we need to check that it exists using the os.path.exist. So coming to checking whether a file is existing, we are reading files is always harmless, but you need to be careful when writing to the files. So calling the open function in the write mode on a file name that already exists overwrites the original content. So using here the os.path.exist function in your program can check whether or not that file already exists. Now, understanding the os.path.exist function, it takes a single string argument for a file name or a path or to a file and returns true if the file already exists and false if it doesn't. The os.path.exist function exists inside the path module, which exists inside the OS module. So when we import the OS module, the path module is imported also. So for example, if we just go to our interactive shell and here if we try to enter saying import OS first, then we say os.path.exist and here we give say abc.txt. In the bracket, we get the value true. If we try to say os.path.exist in bracket, we give here say c:/ then Windows, say system 32, then calc.exe for example, we get it true. Suppose you are not on Windows, you are on Mac OS, then you will have to write down something like, now I won't execute this, but just showing you how the command would look like. It will be slash, say USR, then say local, then say bin, and then say a file name which is there for Mac OS. And if you're on Linux, then you will have to write down, say USR slash bin and slash the file name. That's how you can check the path existing on all the given operating systems. Now, in the particular example that we have checked for the function, it confirms that the calc.exe file is there in Windows. Of course, you will only get these results if you are running Python on Windows. Now, remember to escape the backslash in a Windows file path by typing another backslash before it. If you are using Mac OS, only the Mac OS example will return true. Now, coming back, we will check whether the input file exists with the os.path.exist function. So when we are using this in our demo 17 file, to check whether the file name in the input file name str exists. Otherwise, we have no file to encrypt or to decrypt it. So if we say if not os.path.exist the input file name str, then we are printing here a message that is the file, the name does not exist, giving quitting and passing there the input file name. So if the file doesn't exist, we display a message to the user and then quit the particular program. Next, we are using the string methods to make user input more flexible. Now next, the program checks here whether a file with the same name as the output file name exists, and if so, it asks the user to type C if they want to continue running the program or Q to quit the program. Now, because the user might type various responses like a small c, a capital C, or even the word continue with C capital, we want to make sure that the program will accept all of these versions. To do this, we are basically using more string methods here. That is upper, lower, title string methods. So that is over here that we are checking out. So the upper and the lower string methods will return the string they are called on in an uppercase or lowercase letters respectively, and enter the following into the interactive shell to see how the methods basically work on the same string. So for example, if we go back to the Python shell here and we try to enter say Python dot upper, we get there all in the uppercase, or we try to enter Python dot lower, we get all in the lowercase. Now just as the lower and the upper string methods return a string in lowercase or uppercase, the title string method returns string in a title case. Title case is where the first character of every word is uppercase and the rest of the characters are in the lowercase. For example, if we enter something like Python dot title, we get it first character in upper, rest all in small. Similarly, if you enter everything in capital and still you would say title, it will be converted in the same manner. Or if you have say Python hacking course beginner level, everything you want to convert to title. So every word, the first character will be into capital. So we are using title a little later in the session to format messages we output for the user. Now on, we would be coming with first as the using the starts with and the ends with string methods. So the start with method returns true if its string argument is found at the beginning of the string. For example, if we say Python then dot starts with, and here we give capital P. For example, we get the value as true. Or in that case, we say Python dot starts with and we give here I. We get the value as false. For this case, you can also take a variable. For example, say John is the value in the variable, and we use this variable dot starts with and we give here say JO. Still the value would be true. So the starts with method is case sensitive and can also be used on strings with multiple characters. Similarly, we have the ends with string method, which is used to check whether a string value ends with another specified string value. For example, if we say here Python hacking dot say ends with, in bracket we give hacking, it is true. Or if we try to say again in single quotes Python hacking ends with, give here H capital, rest everything same, it is false. So the string values must match perfectly. Notice that the lack of exclamation mark or your capital letters will also cause an ends with to return a value as false. Now we'll come to using these string methods in our program. So now let us go back to demo 17. As noted, we want the program to accept any response that starts with a capital C regardless of capitalization. So this means that we want the file to be overridden whether the user types small c, continue in small, C capital or another string that begins with C. So well, use the string methods lower starts with to make the program more flexible when taking the user input. So over here when we are checking over here, if the os.path.exist, the output file name str, we print this will be overridden, type C or Q for quit. And then we take here the response, saying response str is equal to input and use there the more than sign. If not response.lower or starts with C, then you exit. So over here we are taking the first letter of the string and check whether it is C using the starts with method. Starts with method that is used in case sensitive and checks for a lower C. So we have used a lower method to modify the response of the string capitalization to always be in the lower case. So if the user didn't enter a response starting with C, then the starts with would return false, not otherwise, which will make the if statement to evaluate to true, because if not in the if statement, this sys.exit is called to end the program. So technically the user doesn't have to enter Q to quit. Any string that doesn't begin with C causes the sys.exit function to be called and quit the program. That's it from this session. Thank you very much. Now we come to reading the input file. Now here, after we have checked this, we are giving there the file object str to open the input file name str, content str to read the file object str and close. Then we are printing here a print method. So in this, we are opening the file stored in the input file name str, read its content into the variable and then close the file. And after reading in the file, the output in a message for the user telling them that the encryption or the decryption has begun. Now because your mymode str variable should either contain the string encrypt or decrypt, calling the title string method capitalizes the first letter of the string in the mymode str and splices the string into %sing string, so it either displays say encrypting or decrypting ... So this is what it would be added to it at the end of it. Now coming to measuring the time it took to encrypt or decrypt. So over here we will check the encrypting or decrypting an entire file can take much longer than a short string. So a user might want to know how long the process takes for a file. We can measure the length of the encryption or decryption by using the time module. So here the time module and the time.time function. Let us first discuss that and then we would come to this. Now the time.time function returns the current time as a float value of the number of seconds since January 1, 1970. Now this moment is called the Unix epoch. Now you can enter something in the interactive shell to see how the function works. So let's go back here and we would try to first say import time here and we would say time.time will give you this particular value, or if you again say time.time, it would automatically increase. Now because time.time returns a float number, it can be precise up to say 1/1000 of a second. Of course, the numbers that time.time display depends on the moment in time that you call this function and may be difficult to interpret. It might not be clear that a particular value is a Monday or a Tuesday or something like that, or some particular date there. So however, time.time function is useful for comparing the number of seconds between calls to time. We can use this function to determine how long a program has been running. For example, if you subtract the floating point values returned when we call the first time.time in the interactive shell, for example over here, if we say this particular value, we copy down here, we say minus this particular value, copy down here, and now we press enter. So this is what is the time lapse. So now we come to our code where we are using the time.time function in our program. So here we use start time is equal to time.time. It returns the current time to store it in a variable named start time. Then we call the if statement here to encrypt or decrypt the particular files that we have passed. And again, after the program encryption decryption has done, we are again calling after that a time.time method, which is over here, which is total time str. We are saying round it to time.time minus start time and round it off to 2 decimals. So the result is a number of seconds between the two calls of time.time. That is, the first start time expression evaluates to a value that is passed on to the round function, which rounds to the nearest 2 decimal points because we don't need a millisecond precision for the program. And this value is now stored in total time str. So now we use again a string splice link to print the program mode and display to the user the amount of time it took for a program to encrypt or decrypt. Then we go ahead for writing the output to the file. So the encrypted or a decrypted file contents are now stored in the variable named translated str. But this string is forgotten when the program terminates. So we want to store the string in a file to have even after the program has finished learning or running. So after that, we open a particular file in the output file obj.str, which is opened in a write mode. And then we call the write file object method there and again close the file. And after this, it prints say more messages to the user indicating that the process is done and the name of the file is written. So after this, we are printing here that done whatever mode, that is encrypting or decrypting into the particular file. We print there the length of the file and also the characters which are or how many characters it has been written to the file. And finally we say it is completed, or the encrypted or the decrypted file is whatever is the file name there. With this, we come to the last part of our program wherein we are calling the main method, which is again call the main function if the program is being run instead of being imported. So this is again similar as to what we have done till now. So now for example, the one file that we have, say we take it as the input file as abc.txt, and here we will take it say abc.encrypted.txt, and we are supposed to encrypt the process. And after this, now let us execute this once again. So we will first of all save this and run the module. Now here we are saying encryption time is this, done encrypting abc.txt, that is 26 characters, and encrypted file is abc.encrypted.txt. Let's have a look in our Python hacking. We have this abc encrypted, so the file that we have written later on that we had created, we have encrypted that file. Now again, if you have to decrypt the same file, you will have to write down here the input file name as this instead of a normal txt, and now you want say a decrypted file here, and the process you want to do is not encrypt but decrypt. So let us save this again and run the module. So now we have abc.decrypted.txt. So let's again check whether the file is there and in the normal position. So this file and abc file should exactly match. That is how the file has properly encrypted and decrypted itself. So another simple example that we have done by just changing the file name that we have. So any file you can take with whatever data you have, same file, pass it for encryption, The encrypted file later on pass it as an input file name and create another decrypted file name to get the output for it. So in this way, we have completed the Python hacking beginner level course, wherein we have covered the reverse cipher, we have covered the Caesar cipher, also seen how to hack with Caesar cipher. We have worked on encrypting with the transposition cipher, again decrypting using transposition cipher. We have seen a program which would run a transposition cipher a number of times with different parameters on it and get the output with different key and the message parameters. And finally, how to encrypt or decrypt a particular file in Python. So with this, we have covered the beginner level, which will give you a start in how to hack using Python. So that's it from this session. Thank you very much.
Welcome to the next course in Python hacking, that is our intermediate level course. Now first of all, let us see what skill set do you require for doing this intermediate level course. So in Python hacking intermediate trainings, for doing this course you must have completed the Python hacking beginner level training. Then you should have knowledge of Python basics, also knowledge of any programming language. Okay, now let us understand what are our course objectives for intermediate level. So here you will get the knowledge of hacking a transposition cipher, what is affine cipher, how to program using an affine cipher, how to hack an affine cipher, and what do you understand by simple substitution cipher. Now we would see what all things we would learn at now. Let us understand who are the target students for the particular intermediate level course. So they are any professionals who want a more deeper knowledge of what is Python hacking. Also any individual who is interested in learning Python hacking. So now let us see by the end of this course what will you have as the following skill sets. So you would have a lot of examples done on transposition cipher. Also you would have an in-depth knowledge of affine cipher and will have knowledge of what is a simple substitution cipher. So with this we get started with our Python hacking intermediate level training. Okay, and let us understand the first topic in the particular session that we would be covering, okay, which will be basically our hacking a transposition cipher. So let's continue with this in the next session. That's it from this introduction part of our Python hacking intermediate level. Thank you so much.
Welcome to the first session in our Python hacking intermediate level course. Now in the last course of our beginner level, in the last session, we have used the transposition file cipher to encrypt and decrypt the entire files. But we haven't tried writing a brute force program to hack the cipher. Now messages encrypted with the transposition file cipher can have thousands of possible keys, which your computer can still easily brute force. But you would then have to look through thousands of decryptions to find the one correct plain text. Now, as you can imagine, this can be a big problem. But there is a workaround for this. When the computer decrypts a message using the wrong key, the resulting string is garbage text instead of a normal English text. We can basically program the computer to recognize when a decrypted message is English. That way, if the computer decrypts using the wrong key, it goes on and tries the next possible keys. Eventually, when the computer tries a key that decrypts to English text, it can then stop and bring that key to your attention, sparing you from having to look through thousands of incorrect decryptions. So basically, let us see how can a computer understand English. Now, basically a computer can't understand English, at least not in the way that human beings understand. Now, computers don't understand even math, chess, or human rebellions either any more than a clock understands lunchtime. So, computer just executes the instructions one after another. But these instructions can mimic complex behaviors to solve the math problems, win a chase, or hunt down the future leader of a human resistance. Ideally, when we need to create a Python function, for example, say isEnglish function, that is, we can pass a string to it and get a return value of true if the string is English, or false if it's some random gibberish for that particular case. So let us look at some English text and some garbage text to see what patterns they might have. Now, for example, if we type something like, say, Pythons are your friends, okay, or if we type something like, instead of this, now this is not what a human can read. Right, now notice that the English text is basically made up of words that you would find in a dictionary, but the garbage text isn't, because words are usually separated by spaces. One way of checking whether a message string is English is to split the message into smaller strings at each space and to check whether each substring is a dictionary word. To split the message string into substrings, we can use the Python string method name, that is split. When checks where each word begins and ends by looking for spaces between the characters, right? Now we can then compare each substring to each word in the dictionary using an if statement. Okay, now we would write down a code like that. We would probably wouldn't, because it would be tedious to type all of it. Fortunately, we can use the English dictionary files, which are basically text files that contain nearly every word in English. Now basically we'll provide you with a dictionary file which you can use. So we just need to write down the function, for example, say isEnglish function, that checks whether a substring is a message or particular substrings available in the messages are in a dictionary file or not. So not every word exists in our dictionary. Dictionary files might be incomplete. For example, it might have the word name, say awkward. Now there are so perfectly good decryptions that might have non-English words in there. Like for example, say YW686 in some example like this. Okay, so a plain text could also be in a different language, but we'll assume it's in English for now. So we would write down an isEnglish function. Okay, that won't be foolproof obviously, but we will give it a try. And now there is a low probability that a cipher text that is decrypted using the wrong key will decrypt to English. Okay, now first thing is we would download a dictionary file for this, which we already have created, and it's basically a text file which is having one word per line in the uppercase. Okay, now we would just add it and I'll show you after opening it what all words do we have. So let's remove this. Now if you go to A drive, we have a folder as Python intermediate level, wherein we have created this dictionary file which is having one word per line, all in capital. Okay, having some English words stored into it. File. Now this is basically our file name dictionary.txt. Now we would create a function named isEnglish, okay, which will basically split a decrypted string into individual substrings and check whether each substring exists as a word in the dictionary file. And if a certain number of substrings are English words, we'll identify that text as English. And if the text is in English, there is a good chance that we'll have a successfully decrypted a ciphertext with the correct. So now we would write down the source code for dictate English module. Okay, we'll create a new file and write down the code into it. Okay, so we will create file, new file, and here we would create, say, upper letters str, and here we would give all the letters in capitals, so A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. After this, we would create another constant, say letter and space str, and that is equal to, we have this upper letter str. With this, we would concatenate the upper letter str dot the lowercase characters, all of this, plus we would give a space, a slash t, a tab, and a new line also, and all we would concatenate in letters and space str. Then we would define a function Now that is our say load dict, okay, and that is load dictionary. And in this function, the first thing we would create is a dictionary file str, and here we would use open and we would give that file, that is dictionary.txt, the one which we have right now created and saved in the same folder where we are going to save the current file. Okay, so after giving this, here we would create say English words str is equal to, initially it is blank. We create for word 1 in our dictionary file str dot read dot split using a /n, because on one line we are having one word, so we are splitting it whenever we find a new line. And in that we are saying English words str in the index of word 1, we are saving the value as none initially. Okay, then we say dictionary file str dot close, and we are returning here the value of English words str, and we end this function here. And then we say English words or word str is equal to, we are calling the load dictionary method that we have created, so that will get stored in a constant name English word str now. So now over here, say the next thing, we are creating another definition for saying get English word count, and here we are passing message str as the parameter. Okay, now in this function we are defining a message str is equal to a message str dot in uppercase, and message str is equal to, we are saying remove the non. Now here we are also creating this remove non letters, so say remove non letters or letter str and passing this message str in that. And then we have say possible word str, that's equal to our message str dot split the method, and then check if the possible word str is equal to open close bracket. Here we are returning say 0.0, that is no words at all, so return 0.0 in this case. Then we check if the matches str is equal to 0, then for say word 1 in the possible word str, okay, here we write down an if say word 1 in, now we have this created constant English word str. If that is it, then we are saying matches str, okay, should be equal to or plus is equal to 1 in this case. And in the for loop we are saying return, converting to float, the value of match str divided by the length of possible word str. Okay, so once we have done this, we have returned this value here. The next thing, we are supposed to define another function that we have called here, that is remove non letter str, and this will also take a message str as the parameter. And here we are saying say letters only str, that's equal to blank, and for symbol 1 in the message str we are saying if our symbol 1 in, now we are having another this constant that we have used here, which is letters and space str. So we are checking here that if symbol 1 is in letters and space str, then we are saying say letters only str dot append the value of symbol 1. Okay, otherwise we are giving here a return statement dot join letters only str. Okay, and after this the next function that we are defining is English check, okay, which is going to take a message str. Then the next thing is word %str. Now this we are defining as 20, and letter %str we are defining as 85, and we are giving here the definition of function. Now here by default we are saying 20% of words must exist in dictionary file, and 85% of all the characters in the message must be letters or spaces, not punctuations or numbers. That is why we have given there the values constant in our definition of the function itself. Then here we are having words match str is equal to, we are using here get. Now we have this English word count method defined, so let us call this here get English word count, and in that we are passing the message str as the parameter. Then we are multiplying it by 100. If that is more than equal to, we are using here the word %str. Okay, then the next thing we check over here is num letter str is equal to, find the length of, now we are using here remove the non-letters, so let us call this function here and get the length of this by passing the parameter message str to it. And then you have the message letter %str, which is equal to, convert to float the value of num letter str divided by the length of message str multiplied by 100, and then you say letters match str is equal to our message letter %str if more than equal to letter %str. Okay, then we are saying return word match str and letters match str. Okay, that is where we are saving this. Okay, now we are going to save this in A drive intermediate, and let's give this as name as check english.py. okay, and we are saving this. Now this file basically will not run over here because we need to import this in some other file to use the method that is English check. Okay, so this we would use in and try and create another file wherein we would create a program to hack a transposition cipher, and there we will use this and then check the output how the file executes. So now let us understand the way we have created this file, and if you want to use this, you can basically use this currently in an interactive shell to check whether a particular string is in English or not. So for example, if we go back here and we say here import our, now the file name that we have created is check English, so we say import check English, and then we use here the method from check English dot, okay, the method name is we are having is English check. Okay, so we will use this is English check, and we give here is this sentence in English, close this. Okay, and check the output. Okay, fine, we are having this match str is not defined, so let us check this. This is match str. Okay, let's save it, and again let us write down the same thing. That's on line number 25. Let's go to line 25. So in this, if we just check the output in the if condition. Okay, now once you have saved this, we will have to run the module again, and again we will have to execute it from import statement. So we will have to say import, say check English, and check English dot say is English check. That is the method, is English check, and here we are passing say is this sentence in English, close it. We will get the value true. Now this is one way in which we can test this. Okay, now if you basically let us understand the particular program that we have created. Now first thing over here that we have is creating the constants in our file. So we have created in this case the variables as constants, which are basically in uppercase. Okay, so we have already understood that constants are nothing but variables whose values should never be changed after they are set. So here the upper letter str is a constant containing 26 uppercase letters that we have set up for convenience and to save time typing. So we have used the upper letter str constant to set up the letters and space str, which contains all the uppercase, lowercase, as well as a space character, a tab character, and a new line character. So instead of typing out all of the uppercase, lowercase letters, we just concatenated the upper letter str with the lowercase letters returned by upper letter str dot lower function, and additional non-letter characters, a tab, a new line, are represented over here in the case of /t and /n. Okay, moving to the dictionary data type. Now before we continue with rest of the code we have written here, we will understand more about the dictionary data type to understand how to convert a text in a file into a string. So the dictionary data type stores values which can contain multiple other values just as the list do. In list, we use an integer index to retrieve item in a list, like for example, say list 1 in the index 42. But for each item in the dictionary value, we instead use a key to retrieve a value. Now, although we can use only integers to retrieve items from a list, the key in a dictionary value can be an integer or a string, like for example, say where in the square brackets say Python, or where in the square brackets an index. Now dictionaries let us organize our program data in more flexibility than list, and don't store items in any particular order. Instead of using square brackets as the lists do, dictionary uses this curly braces that we have created over here, if you see. So here this English word str we have created as a type like dictionary. So a dictionary's items are typed as key value pair in which key and the values are separated by colons. Multiple key value pairs are separated by commas. Now to retrieve values from dictionary, we can use square brackets with the key between them. Similarly to do indexing with list. Now we'll give it a try for retrieving values from a dictionary using keys. We would go back to our interactive shell and give it a try here. We would create say dictionary 1 is equal to, let's give here say key 1 colon, say this is value for key 1. Okay, then we have a comma. Next we have say key 2, and here we have some value for key 2. We close this dictionary. Okay, and now we say dictionary 1, we want to print the value of key 1. So we get there K is capital. So we'll say dictionary 1 in bracket key 1. We get this is the value for key 1. Similarly, if we say dictionary 1 and we try to print the value of key 2, we get the value for key 2. Okay. So here first thing is we have set up a dictionary called as dict1 with 2 key value pairs. We then assign the value associated with key 1 string, which is another string as with list, and we can store all kind of data types in our dictionaries. Note that as with list, variables don't store dictionary values. Instead, they store the references to dictionaries. So we will look at an example which will show us two variables with references to the same dictionary. For example, the one which we have created now. Okay, let's say we create dict2 which is equal to say Python, and the value for this say 50. Okay, then we create a var1 which is equal to dict2. Okay, now we say var1 at the index of Python, we want to change it to 90. Okay, now if we say it is dictionary 2, we get Python is equal to 90. Or if we say var1, again we get Python is equal to 90. Right, so the first line of code here sets up another dictionary which is a dictionary 2, and this time we have only one key value pair in that. Okay, so now you can see that it stores an integer value say 50 associated with the key as Python. The second line assigns that dictionary key value pair to another variable which is var1, and you can then use this variable to change the original dictionary value associated with Python string key to 90. The new both variables, that is dictionary 2 and var1, should return the same dictionary key value pair with the updated value now. Now let us understand some differences between the dictionaries and the list. Now dictionaries are like list in many ways, but there are a few important differences. Point number 1 is dictionary items are not in any order. There is no first or last item in a dictionary as there is in a list. Second is you can't concatenate dictionaries with the plus operator. If you want to add a new item, use indexing with the new key. Third is list only have integer index values that range from 0 to the length of the list minus 1. But dictionaries can use any keys. If you have a dictionary stored in a variable, say var1, you can store a value in var at the index 3 without needing values of the var 0 or 1 or 2. Okay. Now coming to adding or changing the items in the dictionary. You can also add or change value in a dictionary by using the dictionary keys and indexes. Okay, for example, if we try to say dictionary 3 is equal to, we are giving here say 10, and the value for this say Python. Okay, now we are giving a print command and we are saying here dictionary 3 at the index 10. We get the value printed. Similarly, if we just say dictionary 3 at the index 10 is equal to say hacking. Okay, and now we give a print command saying dictionary 3 index 10. We get the value hacking. So this dictionary has an existing dictionary string value associated with the key 10, that is Python, and we can reassign a new value hacking to that using same dictionary 3 at the index 10. Okay. Now moving to using the length function with dictionaries. Now the length function shows the number of items in a list or a number of characters in a string. It can also show you number of items in a dictionary also. For example, we'll enter something in the interactive shell to see how to use the length function to count items in dictionary. For example, now we create dictionary 4 and that is just open close bracket. If we now use length of dictionary 4, we get the length as 0. Now suppose we say dictionary 4, we give here a key value say first and we give here a value say ABC. Okay. Now if we say another dictionary 4 say second as the key and the value for that is say XYZ. Okay, we add another dictionary 4 say third and the value for that is LMN. Okay, and now we give length of dictionary 4. We get there the length as 3. So the first line in this shows an empty dictionary. Okay, the length function correctly shows the length of this empty dictionary as 0. However, after we introduce the following 3 values into the dictionary, the length function now returns 3 for the 3 key and value pairs that we have just assigned to the variables. Let's move on to using the in operator with the dictionaries. Now you can also use the in operator to see whether a certain key exists in the dictionary. And it's important to remember that the in operator checks keys and not values. Okay, to see this operator in action, we will enter the following in the interactive shell. For example, we create say dictionary 5 and here we give say 1 in colon say first item comma say 2 second key colon say second item. Okay, that is the values we have given. Now we give here for example the key say 1 in dictionary 5, it gives us true, or we give 2 in dictionary 5, we get true, or if we give 3 in dictionary 5, it is false because that is not existing, right? Similarly, if we give for example say fourth not in dictionary 5, that's true. So in this case, we have set up a dictionary called dictionary 5 with some key value pairs and then checks whether the key exists in the dictionary using the in operator. Wherever it is existing, it gives us the value true. Wherever it is not, we get the value as false. Okay, similarly, if we use not in operator where the value is not existing in the dictionary, we again get the value of the existing command as true. Now coming to finding the items is faster with dictionary than with list. So now let us create a list and a dictionary. Okay, now for example, let's create here a list 1 that is equal to say Python one word hacking say intermediate. Okay, and we create dictionary 6 that's equal to, we are giving here say, let's give value same, we would change the keys. So let's give say key 1 as 0, then let's give key 2 and that is also 0, and then let's give key 3 and that is also 0. Okay, now Python can basically evaluate the expression, that is if you give a particular value in the dictionary value which is more faster retrieval than your list value. Okay, now this is basically because for a list, Python must start at the beginning of the list and then move through each item in order until to find a particular item. If the list is very large, Python must search through numerous items. A process can take a lot of time. But a dictionary is also called as a hash table, directly translates where the computer's memory and the value for the key value pair is stored, which is why dictionary items don't have an order. No matter how large dictionary is, finding any item always takes some amount of time. Same amount of time we can say. This difference is speed that is hardly noticeable when searching a short list or short dictionaries for that case. Okay, now let us understand using the loops for dictionaries. So you can also iterate over the keys in a dictionary using for loops, just as you can iterate over the items in a list. Okay, now for example, we have this dictionary 6 created. We take say for k1 in dictionary 6. Okay, and here we give print command and we give print the value of k1 and dictionary 6 at the index k1. So we get there key 1 value 0, key 2 0, key 3 is also 0. So all the values are been printed. Okay. So to use a for statement to iterate over the keys in a dictionary starts with the for keyword. You can set the variable k1 using the in keyword to specify that you want a loop over the dictionary 6 and end the statement with a colon. So as you can see, after entering the print command, it returns each key in the dictionary along with its corresponding value also. So now let's see implementing the dictionary file. Let us return to our checkenglish.py and set up the dictionary file here. Now the dictionary file sits on the user's hard drive, but unless we load the text in this file as a string value, our Python code can't use it. Okay. Hence, we have created this load dict helper function to do this. Okay, so here we are saying the dictionary file str is equal to open, in the single quotation marks we have given dictionary.txt. Then we have created English words str as a blank dictionary. So first we get the dictionary file object by calling the open method and passing the string of the file name dictionary.txt. Then we name the dictionary variable English word str and set it to an empty dictionary initially. Now we'll store all the words in the dictionary file. That is the file that stores the English words in a dictionary value, the Python data type. Okay. The similar names are unfortunate, but the two are completely different. So dictionary file str is different and English word str is totally different, right? Now, even though we would have used a list to store the string values of each word in the dictionary file, we are using a dictionary instant because the in operator works faster on dictionaries than normal list. Okay, now next we will learn about the split string method, which we'll use in our to split our dictionary file into substring. So let us understand the split method first. Now this split string method takes one string and returns a list of several strings by splitting the passed string at each space. Now to see an example for this, we will go to the interactive shell and try to split some words and get the output. So let's go back to interactive shell here and we will type, say, this is Python hacking intermediate level course. Okay, and dot, and then we use a split method there. Okay, now it has splitted every word after a space, right? So this is the list of strings that we have got here. Now it is one string for each of the word in the original string. Spaces are dropped from the items in the list. Even if there is more than one space if you have given, you can just pass an optional argument to split method to tell it to split it on a different string other than a space. Okay, now for example, if we try to enter something like, say, this is or this, then we separate it with AA is, say, Python hacking intermediate level course. Okay, and again here we say split, but this time we give AA in the bracket. So now it is splitting wherever it is finding AA, that is a separate word for it. Okay, this is how we have used this for another way in which we can split it. So notice that the string doesn't have any spaces in this. Using a split and passing double A splits the original string wherever AA occurs, resulting in the list of, again, 7 different part of the string. Okay, now using a splitting the dictionary file into individual words. So let us return to our code that we have created here. Okay, and where we have used the split function here for word 1 in dictionary file str.read.split on a new line. Okay, so let's break down the particular code. The dictionary file str variable that stores the file object of the opened file. We are using that read method which calls read the entire file and returns it as a large string value. We then call the split method on this long string and split it on a new line character because dictionary file that we have has one word per line. So splitting on a new line character returns a list of values made up of each word in the dictionary file. Now we use a for loop at the beginning of the line which iterates over each word to store one each in a key. But don't need values associated with the key since we are using dictionary data type. So we'll just store the none value for each key. Hence, we have stored this none value for every key. Now none is a type of value that you can assign to a variable to represent the lack of a value. Whereas the Boolean data type has only 2 values. None type has only one value, that is none. It's always written without quotes and with a capital N like we have written here. Okay, so for example, you say you had a variable named, say, answer, which holds a user answer to a true or a false pop-up quiz question. And if the user skips a question and doesn't answer it, it makes the most sense to assign the answer variable to none as default value rather than true or false. Otherwise, it might look like the user answered the question when they didn't. So likewise, we have the function calls that exit by reaching the end of the function and not from the return statement, which evaluate to none because they don't return anything. Okay, so over here, the word that is being iterated over as a key in the English word str and stores none as a value for that particular key we have done inside the for loop. Now coming to returning the dictionary data. Now after the for loop finishes, the English word str dictionary should have different types of or whatever words you are having as the key in it. Okay, so at this point we close the file object by saying dictionary file str.close, because we are done reading it, and then return the value of English word str from the function. Okay, we then call basically our load dict and store the dictionary value it returns in a variable that is named English word str, which is also a constant. So we want to call the load dict before the rest of the code in the check English module, but Python must execute the def statement for load dict. Okay, so before we call the function, this is the reason we have assignment for the word English word str comes after the load dictionary function has been written. So first we have defined the function, and then we are storing that value of the function in the given constant. Now let's move on to counting the number of English words in the message. So we go ahead with the next definition, that is get English word count method definition. So here we have written the program code that defines the get English count or English word count function, which takes a string argument and returns a float value indicating the ratio of recognized English words to total of the words. Now we'll represent the ratio as a value between 0.0 and 1.0. Now where a value of 0.0 means none of the words in English or in the message string are English words, and 1.0 means all of the words in the past parameter are English words. So most likely the get English word count will return a float value between 0.0 and 1.0, and the is check English function uses this return value to determine whether to evaluate it as true or false. Okay, so when we use this, we create it as a message str is equal to message.upper. Then we have removed the non-letters which we have created below, and then possible word str we get message str.split. Now to code this function, we will first create a list of individual word strings from the string in the message str. Then we'll convert the string to the uppercase as we have done here in the next line. Okay, and then remove the non-letter characters from this string, such as numbers or punctuation, by calling the remove non-letter str method, which we will see later on. Okay, and after this, finally, we will use a split method that will split the string into individual words and store them in a variable named possible word str. Now, for example, if the strings, for example, say, hi, this is Python, is passed after calling the get English word count, okay, the value stored in the variable possible word str would be probably, say, this, hello, space, then this is Python. So there are separate words which we are creating. So if the string in the message is made up of integers like say 1, 2, 3, 4, 5, 6, and the call is made to remove non-letters, would return a blank string, which splits would be called on to return an empty string or an empty list. Okay, so in the program, an empty list is basically equivalent to 0 words being English. This could basically cause a divide by 0 error also. Now let us understand what is this divide by 0. To return a float value between 0.0 and 1.0, we divide the number of words in possible word str recognized as English by total number of words in the possible word str. Now, although this is mostly straightforward, we need to make sure possible words is not an empty string. If possible words is empty, it means total number of words is basically 0. Now, because in mathematics, dividing by 0 has no meaning. So, dividing by 0 in Python results into an error of divide by 0 error. Okay, for example, if we just go to the interactive shell here and we try to do it something like 42 divide by 0, we get here a division 0 error. Okay, now you can see that 42 divided by 0 will give you this particular error. So to avoid this, we'll have to make sure that the possible word list str in our list is never empty. Okay, so for that, what are we doing in our program is, if you just check that if it is empty, we are returning a value 0.0. Okay, so we are checking the particular list here, and if it returns empty, then we are giving a particular value to it to avoid a divide by 0 error in this case. Okay, so now we move on to counting the English word matches. Now to produce a ratio of the English words to the total words, we are going to divide the number of words in the possible word str that are recognized as English by total number of words in possible word str. Now for doing this, we need to count the number of recognized English words in the possible word str. So we have set the variable match to 0 and we use a loop to iterate over each word in the possible word str. Okay, and check whether the word exists in the English word dictionary. So that is why we have run this loop here for word 1 in possible word str. And if word 1 in English word str, then we are putting match str plus is equal to 1. Okay, now after the loop is complete, the number of English words in the string is stored in matches variable. And remember that we are relying on dictionary file to be accurate and complete for the check English module to work correctly. If a word isn't in the dictionary file, it won't be counted as English, even if it is a real word. So conversely, if a word is misspelled in the dictionary, words that aren't English might accidentally be counted as real words. Now, right now, number of words in the possible word str that are recognized as English and total number of words in the possible word str are represented by integers. Now, to return a float value between 0.0 and 1.0, we are dividing this two integers. Will return to change one or the other into a float. Hence, we are saying here return float match str divided by the length of possible word str. So coming to the float, int and str functions and the integer division that we have in Python. Now let's have a look at how to change an integer into a float, because the two values we will need to divide to find the ratio are both integers. And Python 3 always does a regular division regardless of a value type, whereas in Python 2, it performs integer divisions when both values in division operators are integers. Now, because users might use Python 2 to import our checkenglish.py, we'll need to pass at least one integer variable to float to make sure a float is returned when doing division. Okay, so doing so, it ensures that regular division will be performed no matter which version of Python is used. Now, this is an example of making the code backward compatible with previous versions also. So, although we won't use them in the session, let's review some other functions that converts values into other data types. We have the int function which returns an integer version of this argument and the str function that returns a string. Now to see how this function works, let us enter some detail in the interactive shell to get the output. For example, we enter here in float, say 45. We get 45.0. We try to enter 42.0 and convert it to integer. Or we enter 42.5 and get the value of type integer. Or in that case, we say integer 45 and passing a string value to it. Or we say str42. Okay, an integer value converting to a string value. Or if we say 56.7 and converting to integer. Okay, now you can see that the float function changes the integer into a float. Int function can turn the float to an integer by truncating their decimal values, or it can turn a string into an integer. Even the str function changes numerical values to string values. So these functions are helpful if you need a values equivalent to be a different data type. Now coming to finding the ratio of English words in the message str. So let's return to our program back, and to find the ratio of the English words to total words, we then divide the number of matches we found by total number of possible word str. So there we are using the slash or the division operator to divide the two numbers. Okay, and returning the value back to the calling program. So after we pass the integer matches to the float function, it returns the float version of that number, which is divided by the length of the possible word str list. Now the only way we return the float match str divided by the length of possible word str would lead to a divide by 0 if the length of possible word str is evaluated to 0. And the only way that it would be possible is if possible word str were an empty list. However, we have already specified that to check for this case and return 0.0 if it is empty. So if possible word str were set to an empty list, program execution would never get passed after the particular line that we have told here. Okay. So we can then be confident that this particular division will not cause you a divide by 0 error in this case. So now let us move on to the removing non-letter characters. Now certain characters such as numbers or punctuation marks will cause our word detection to fail because words won't look exactly as they are spelled in our dictionary file. For example, say for you have the last word say as you, and that is you dot, okay, and we didn't remove the dot at the end of the string, so it wouldn't be counted as an English word because you, that is you, wouldn't be spelled with the period in a dictionary file. So to avoid such misinterpretations, numbers and punctuation marks needs to be removed. Okay, so the previously explained our get English word count function calls the function remove non-letters str. Okay, now on a string to remove any number and punctuation characters from it. So if we look at the remove non-letter str, which takes a message str as a parameter, okay, it has letters only str as blank dictionary, okay, or a blank list. Then from symbol 1 in the message str, if symbol 1 in the letters and space str, we are saying letters only str dot append symbol 1. Okay, now over here we are creating a blank list called as letters only str, and after which we use a for loop to loop over each character in the message str argument. And next the for loop checks whether the character exists in the string letters and space str. Then we check if the character is a number or a punctuation mark. Okay, if it won't exist in letters and space str, string and won't be added to the list. If the character doesn't exist in the string, it's added to the end of the list using the append method over here. Okay, now let's have a look at next, that is the append list method. Okay, now when we add a value to the end of the list, we are appending a value to the list in that case. So this is done with list so frequently in Python that there is an append list method that takes a single argument to append to the end of the list. Now for example, just to check this append method in the interactive shell, if we go back here and here we create say a list 1 that's equal to blank. Okay, after this we are saying list 1 dot append, and here we give say a word Python. We then say list 1, it prints the value that is Python. Again we say list 1 dot append, here we add hacking, and again we say print the value of list 1. So it prints Python and then hacking that was added. So after we have created an empty list named list 1, we can enter say list 1 dot append a particular string to add a string value to the list. Then we can enter again list 1 to return the value stored in this list, which is right now Python. If you again use append to the list 1 to add to the end of the list, now if we again print list 1, we are getting Python and hacking both printed. So similarly, we also use the append list method to add the items to the letters only str list we created in our code earlier. Okay, so whenever we say letters only str dot append and a symbol 1 in the line, it basically goes on appending the values there. So coming to creating a string of letters. Let's go back to our program here. Okay, and after finishing the loop over here, that is in remove non-letter str and the append one. After this, okay, now letters only str should be a list for each letter and space character from the original message str. Now because a list of one character string isn't useful for finding the English word, we have joined the character string in the letters only str into one string and returns that. So hence we have told here return a blank then dot join letters only str. Now to concatenate the list items in letters only str into one large string, we call the join string method on the blank string, that is open close single apostrophe. And this joins the string in the letters only str with a blank string between them. And this string value is then returned as a remove non-letter str function's return value. Okay, now coming to the dictating English words or detecting English words. Now when a message is encrypted or which is decrypted, okay, with a wrong key, it will often produce far more non-letter and non-space characters that are found in a typical English message. Also, the words it produces will often be random and not found in the dictionary of English words. So, if we go for a definition of is English check function, we can check for both of these issues in the given string. Now, here in this function, we have created this or set up this to accept a string argument, that is message str, and return a boolean value of true when the string is English text and false when it is not. Now this function has three parameters. One is message str, word %str that is 20, and letter %str which is 85. And the first parameter contains a string to be checked. Second and third parameter set default percentages for words and letters, which the string must contain in order to be confirmed as English. Okay, now a percentage is just a number between 0 and 100 that shows how much of something is a proportional to total number of those things. So we'll explore how to use these default arguments and calculate percentage in the following session now. Now using the default arguments. Okay, now sometimes a function will always have the same values passed to it when it is called. Instead of including these for every function call, you can specify a default argument in the function's definition statement itself. Like here we have defined three parameters with default arguments of 20 and 85 provided for word %str and letter %str respectively. Now this is English check function can be called with 1 to 3 arguments. If no arguments are passed for word % or letter %str, then the values assigned to these parameters will be their default arguments. Okay. Now the default arguments defined what % of the message str string needs to be made up of real English words for is check English or is English check. To determine that message str is an English string and what % of message needs to be made up of letters or spaces instead of numbers or punctuation marks. Now for example, if is English check is called with only one argument, default arguments are used for word %, which means 20% of string needs to be made up of English words and 85% of the string needs to be made up of letters. Now these percentages work for detecting your English in most cases, but you might want to try other argument combinations in specific cases when is English check is basically called. Needs some more looser or more restrictive threshold in that case. So in those situations, a program can just pass arguments for even word %str and letter %str instead of using the default ones. Now we'll just see one function call to is English check. Okay. And for example, if we just go to the interactive shell here, now we have already imported this English check. Now we say is check English dot is English check. Oh, this is also in capital. Yeah. Okay. In bracket, we give Python and just the one string in this case. Now let's give another, say check English dot is English check Python and 50. Still it is true. Okay. So now in this case it is evaluated. Say in the first one it is like Python comma 20 comma 85. Here in this case it is Python comma 50 comma 85. Now if you say, for example, say check English dot is English check and here you give Python comma 50 comma 60. Still it is true. Or if you want to give, say check English dot is English check in bracket the string and you want to give for letter %str is equal to 60. So it is evaluated now as say Python, then 20 the default one for word %str and 60 for letter %str in this case. Okay. So now for example the one which we have seen here, we are calling the function when it is called with second and third parameter specified. Program will use those parameters and not the default ones. Now let's move back to our calculating percentages. Now once we know the percentages our program will use, we will need to calculate the percentage for the message str string. Okay, now for example, let us assume that we are having, say, we'll just put this in the comment part. Okay, say we are having the string as say Python, then one more word, say who. Okay, then we take some word, again some word. Okay, now again some word. Now this particular string is having 5 words, but in that case only let's say we'll make one more who is. Okay, out of this only 3 words are English. Now to calculate the percentage of English words in this string, you will have to divide the number of English words by total number of words and multiply it by 100. So the percentage of English words in this case would be something like, say, 3 divided by 5 multiplied by 100. Okay, which would be, for example, 60% in this case. Okay, now similarly, suppose you have, say, number of English words, say as 3 or 6, let's take it now 6, and total number of words, say 10. So again, if we say here 6 divided by, say, 10 multiplied by 100 would also come to 60. Or in that case, say a bigger number, say 32 English words out of 87 multiply by 100, this would give you something like 36.78. Okay, for example. Or 0 English words and 10 total words, okay, multiply by 100 will give you the value 0. Okay, so this way we may have a different percentages calculated in this case. Now the percentage will always be between 0%, meaning no words are English, and 100%, meaning all the words are English. Okay, so our is English or is English check function will consider a string English if it is at least 20% of the word existing in the dictionary file, and the rest 85% of the characters in the string are letters or spaces. Now, this means the message will still be detected as English even if the dictionary file isn't perfect or if some words in the message are something other than what we define as English words. Okay, so now if we come back to our program, let us just remove this line. In our program over here, where we are calculating the percentage to recognize the English words in the message str by passing the message str to get English count, which does the division and returns the float between 0.0 and 1.0 over here. Okay, so we are saying word match str, that is equal to get English count or get English word count, pass the message str multiplied by 100 if that's more than equal to the word %str. Now to get a percentage from this float, multiply it by 100. If the resulting number is greater than or equal to word % parameter, true is stored in the word match. Okay, otherwise false will be stored. Okay, now similarly, if we go on to the next line where we are saying num letter str is equal to the length of remove non-letter str and passing the message str to it. Okay, we have written this function to find all the letters and space characters in a string. So we just need to reuse it. Okay, similarly, if we say call to the remove non-letters in the earlier one to get a string of just the letters and the space characters in the message str. Now passing this string to the length function over here should return total number of letters and space in the message. Okay, the next line over here that we have is, say the message letter %str is equal to convert to float the number letters divided by the length of message str into 100. Now over here we are getting the percentage of the letters by getting a float version of the integer in num letters and dividing it by the length of the message. The return value of this will be a total number of characters in our message str. Okay, so as discussed previously, the call to float is made to make sure that this particular line performs a regular division instead of integer division, just in the case of the programmer who imports your check English module is running on Python 2. Okay, next we check whether the percentage in our message letter percentage is greater than or equal to the letter %str. And this expression evaluates to a boolean value that is stored in the letters match str. Now we want the is English check to return true only if both the word match str that is in the first line and our letter match str in the second last line contains true. Okay, hence we have combined these values into an expression using an AND operator. So we are saying return word match str and letter match str. So if both the word match and the letter match variables are true, that is, the is English check will declare the message is English and return the value true. Otherwise, it will detect it as a non-English and return the value false in that case. Okay, so in this way, we have created this particular file, that is checkenglish.py file. Now in the next session, we will see how to use this in some another file for checking a transposition cipher or hacking a transposition cipher in that case. Now, in this session, we would be using the brute force approach to hack the transposition cipher of the 1000 of keys that could possibly be associated with the transposition cipher. Now the correct key, okay, now should be the only one that results in an eligible English. So here in this particular example, we would be using the earlier example which we have created for check English, okay, where we have written transposition cipher hacker program will find us the correct key using the checkenglish.py code that we have written. So now let us come and write down the source code for the transposition cipher hacker program. So as normal, we would be creating a file, new file, and we would be entering the code here and saving it by any example.py. Okay, now make sure wherever you are saving this particular file, in the same folder you should have the paperclip.py. Also, you should also have the demo 13 file. Also, check English that we have seen. Now, if you just go to your Windows Explorer here and look at our folder that is Python intermediate level, here we have the checkenglish.py which we have already done. Now, demo 13 and paperclip we have taken from our beginner level because in that we had created for decryption and the paperclip we had imported. And this dictionary.txt is from the last session that we have created. So all these 4 files have to be there in the same folder where we are going to save the current file that we are creating. Okay. So now let's go back here and create our file for transposition cipher hacker program. So the first thing we would do is write down here the import paperclip. Then the next we have is check English. And the next we have is demo 13. Okay. Now we define here the main method. Okay. Now in this particular code, we would be writing down a message, say my MSG, that's equal to, okay, we are giving it in triple quotation marks. Okay. Now here, before writing this message for decryption, what we would do is, let us open now in E drive. We have this demo 10 which is basically for encrypting. So here we would put some text, say this is Python hacking intermediate level course. We are trying hacking with transposition cipher. This message is used to encrypt the text. Now we have written this particular message. Let us split it across multiple lines. And let's try to give here. Okay. And now let us try to run this particular course. Now this is what we are getting it as the encrypted message. So now we would copy down this. Okay. Let's close this demo 10 as of for now. And here we would paste that encrypted which we want to decrypt using transposition hacking now. Okay. So now if you just look at our demo 9 for example, demo 10 for example, we have used here key that is 8 and this is the text that we have used. Okay. So now the same key would be used for decryption also. So once we are done doing this particular or executing this particular program, now what do we want to do is, if we want, can move it like this. Okay. And then after writing this my message part here, let's not give the spaces. Let it be as it is. Okay. Now below this we would have say hacked MSD str. Now that is equal to, we are going to define another method in this and that method will be hack transposition. So we are calling that over here hack transposition str. Give there my MSG as the parameter which you want to hack it. Okay. Then we check if the hacked MSG str is equal to none. Then we are going to give here a print saying in single quotes, say failed to hack encryption, else we will give print as copying hacked message to clipboard. Okay, and below that we would give another print command wherein we would be printing the hacked MSG str message, and then we would say paperclip dot copy again hacked MSG str. Okay, and after this now we are supposed to define the hack transposition str method, which is going to take message str as the parameter into it. And in this particular message or the method, we are going to print, say in single quote, hacking. Okay, close this. Then now over here, basically Python programs that we are executing can be stopped at any time while executing by pressing a Ctrl+C on Windows or Ctrl+D on Mac OS and Linux. Okay, so here we are going to give a print command for the user, giving there a text, say press, say Ctrl+C on Windows or Ctrl+D, say on Mac OS and Linux, to quit at any time when the program is executing. Okay, now after that we would be using a brute force by looping through every possible key. So we use here the key str in the range of, we are giving 1 comma the length of message str, and in this for loop we are printing, say trying key hash, we print here %s, then we give their end of single quote and print there the value of key str here. Then we use, say decrypt or decrypted text str, that's equal to, now we are going to use the demo 10 dot, let us just open up the demo 10 file. Let's open demo 30, and here we are having the decrypt message str. So we would be using demo 13 dot decrypt message str. Here we are passing the key str and the message str. Okay, so no need to create the method again, hence we are using it. Fine, let us keep open the file, that is check English, which we have created in the last session. Now after we have done this, we will check if our file name is check English. So check English dot, the method that we are using over here is English check. So use the same method here, and in this we would be passing the decrypted text str as the parameter, and if that is true, if it is in English, then giving a print command here, ask user if this is the correct decryption. Okay, then we give here saying possible encryption hack, and another print, we print here the value of key, say %s colon, say %s, give here key str comma the decrypted text str, and just print the initial 100 characters, not all. Okay, or let's give here 50. Okay, after this we again give a blank print, and now we are saying here, say enter D if done, or anything else to continue hacking. So if you enter a capital D, it would be done. Otherwise, anything else you enter, that means you're supposed to work on it more. And then take the input using the response is equal to input. And then we would check here below that if your response dot strip dot upper dot it starts with a capital D. Okay, then we are again returning the decrypted text str. Otherwise, we are just saying return none and come back here and check if name is equal to your main colon, call the main method. Now we would be saving this again in E drive intermediate. Let us give this name as transposition hack eg.py. Okay, and let us save this. And now let's try and execute. Okay. Let's check out this print command here. Okay, now when we are giving this print command here into this semicolon should come here. And then it should be closed. Okay, fine. That is on line number. Let's check LEM where it is. So let's come back here. Now we are importing all this. That is okay. Then we are having printing this and importing demo 13. Okay. So that is not an issue. Now we are checking over here if name is equal to, and we are giving, let's give here a space like this, colon. Okay, we are calling the main method. Again here, fine, no issues in this. Let's check it again. LEM is not defined. So let us see on line number 41 first. Let's go to line 41. Okay, this is the line where we are checking. Okay, we are giving here if underscore name underscore is equal to single quote main, then call the main method. So here we are returning the null. Now we are having this define main created above. Okay. Let's check on line number 8. Okay, why is this hacked message str is equal to, now we have used this hacked transposition over here. Okay, and passing the value that is my message. So my MSG in this. And here we are having message parameter taken. So that doesn't matter. Fine with this. And let's try to run it again. Come to line number 22 now. That is over here. And here we are checking for the key str. Okay, and that is in the range. This is length. Fine. Let us check it. Oh, failed to hack it is saying. We did it on 8. Let us do one thing. Let's keep this like this. Save it. Run that. Good. Now it is getting, because even a space will change it. Okay. Now we do capital D and we get the whole text. Now here we are basically using the decrypt message. So we should get the decrypted text there. Okay, let us check it here. Now is English check. Okay, now in this case we are using demo16.py file for decryption. Okay, which we have already created in the beginner level course, which is, it also has the encrypt message str method and also the decrypt message str. And okay, and here we have given this particular text for encryption. If you just look at the encrypted text, this is how the encrypted text looks like. So we have copied down this encrypted text in our, we just close this and we go back to our transposition hack example. We have copied the encrypted text over here and just two changes. One is we are calling here decrypt message str and passing only one parameter, that is message str, not the key value. Okay, so now if we try to run this module, it prints one line, we press D. Okay, we get the same text decrypted. This is Python hacking intermediate level course. We are trying hacking with transposition cipher and this message is used to encrypt the text. So here we have used that particular key value for hacking it. Okay, if you want to look at again demo16.py, okay, this is how we have used it for hacking purpose. Okay, so we have given here another key for hacking, that is, now here the key str is not any value but it is just a text that we have used for hacking a transposition cipher. Okay, so in this way we have created this example for hacking using the example, that is demo 16. So now in this particular program, okay, we are trying for a particular key and if that key is there, it is returned. The program returns the snippet of the decrypted message for the user to confirm that it has found the right. Okay, now in this example, the message looks promising and when the user confirms the decryption is correct by entering D, the program then returns the entire hacked message. Okay, now you can also see its the biographical note about, okay, that we have, we basically get before pressing D. And if the decryption is false positive, the user can press anything else and the program will still continue to try for other keys. Okay, now the program again runs and skips the correct decryption by pressing anything other than D. The program assumes that it did not find the correct decryption and continues its brute force approach through the other possible keys available. So eventually the program runs through all the possible keys and then gives up, informing the user that it was unable to hack the ciphertext. Okay, now let us take a closer look at the source code that we have used for creating this program. Okay, so the first thing we have done is importing the modules. Okay, in the first line of the code, we tell the user what about this program will basically do. Okay, we are importing several modules that we have written or seen in the previous sessions, that is our paperclip, check English and demo 16. Now the transposition cipher hacker program containing approximately some lines of code is fairly short because of it, much of it basically exists in other programs that we are using as the module. So using a multi-line string with triple quotes, like if you use instead of the single quotation marks, if you use this triple line or triple double quotes, okay, that is known as our multi-line string using the triple quotes. Okay, now notice that if you are having a very long string, then triple quote strings, we also call them as multi-line strings because they span multiple lines and can contain some line breaks within them. So multi-line strings are basically useful for putting a large string into a program source code, and because single and double quotes don't need to be escaped within them, we can see an example of this multi-line string by entering some following text in the interactive shell. So if we go back here and we try to enter, say, str is equal to, we give here double quotation marks, say dear John, press enter, we say why did you dress up my hamster in doll clothing, then say I look at Mr. ABC and think that I know this was John's doing, and then say give thanking you, say LMN. Okay, and then we end this triple quotation mark. Now we give here again say print in bracket str. So we get the same text in the same format printed. Okay, notice that this particular string value, like our ciphertext string, it spans multiple lines. Everything after the opening triple quotes will be interpreted as part of the string until the program reaches the triple quotes ending it. Okay, so you can make a multi-line string using either like 3 double quotes characters or 3 single quotes. So even doing this way and ending it with 3 single quotes will also be possible, or do it with double quotation marks. Okay, anyways, as you wish to do it. Now let us go back to our program here. Now come to displaying the result of the hacking the particular message. So the ciphertext hacking code exists inside our particular method, that is hack transposition str function. Okay, which we are calling it over here and storing the value which is returned by this function in the variable hacked message str. So this function will take one string argument, the encrypted ciphertext message that we are trying to hack, and if the function can hack the ciphertext, it returns a string of the decrypted str, otherwise it returns the value that is none. So if you look at over here, we are saying hacked message str is equal to calling the method, passing the parameter, checking if it is equal to none, then print failed to hack encryption. Else if it is not equal to null, then you are saying copying the hacked message to clipboard, printing the hacked message, and then using paperclip.copy to copy the message. Okay, so over here, after calling the function to return the hacked message, if the attempt is successful or the none value is an attempt is unsuccessful, then it stores the returned value in the message hack msg str. And the next line tells the program what to do if the function is unable to hack the ciphertext. So if none was stored in the variable hacked msg str, the program lets the user know by printing that it was unable to break the encryption. And the next lines after that shows what the program does if the function is able to hack the ciphertext. That is, after the if part in the else, we print the decrypted message, we copy it to the clipboard, and for this code to work, we also need to define the hack transposition str function, which we are going to do after the next line of copying it to the paperclip. Okay. So now coming to getting the hacked message. Now using over here the hack transposition cipher function, we start with a couple of print statement there. Okay, that is we are saying print hacking, then printing a press Ctrl C on Windows, okay, or a Ctrl D on Mac OS and Linux to quit at any time. After this, now because the program may try many keys, okay, and the program displays a message telling the user that the hacking has started and that it might take a moment to finish the process. So the print command over here tells the user to press a Ctrl C on Windows or D on Linux or OS to exit the program at any point. Okay. Now you can actually press these keys to exit any running Python program on the particular given operating system. And after that, the next couple of lines tells the program which key to loop through by specifying the range of possible keys for the transposition cipher. So over here, we run this for loop after that, saying for the key str in the range of 1 till the length of the message str. We are saying print trying the key and the number of the key that it is trying. So the possible keys for the transposition cipher range between 1 and the length of the message. Okay. And the for loop on this particular line tells the hacking part of the function which with each of this particular given keys. So it uses the string interpolation to print the key currently being tested, using the string interpolation to provide a feedback back to the user. So using the message that is, or using the function that is demo16.decrypt message str, which is there in our demo16.py program that we have already written, it gets the decrypted output from the current key being tested and stores that particular value in the variable that is decrypted text str. Okay, and the decrypted output in the particular variable decrypted text str will be English only if the current key was used. Otherwise, it would appear as a garbage text. So then the program passes that particular string, okay, or that is decrypted text str into isEnglishCheck function, which is there in our checkenglish.py. Okay. And then it prints part of the decrypted text str, the key used and the instructions for the user. That is, it asks, first prints a blank line, prints the possible encryption hack, prints the key, again a blank line, and then asks for the response from the user by asking it to press D if it is done. Now just because the check English dot is English check method returns true and moves the execution to the next line, it doesn't mean that the program has found the correct. It could be a false positive, meaning that the program dictated some text as English that is actually a garbage text. So to make sure that it previews the text so the user can confirm that the text is an indeed English, it uses that slice decrypted text str:50 to print out the first 50 characters of the text. And then the program pauses after the particular line and asks or waits for the user to enter D or anything else, and then stores that input as a string in the given response variable. Okay. Now, understanding the strip string method. Now, when a program gives a user specific instruction, but the user doesn't follow them exactly, an error results. And when our particular program prompts the user to enter D to confirm the hacked message, it means that the program won't accept any input other than D. And if the user enters an extra space or a character along with D, the program won't accept it. So let us look at how to use this strip string method to make the program accept other inputs as long as they are similar enough to D. So the strip string method returns a version of the string with any white space characters at the beginning and end of the string stripped out. Now, the white space characters are the space characters, tab characters, and the new line characters. So for this, we would enter some following text in the interactive shell to see how this basically works. So if we go over here and if we write down here certain space, write down hello, and then we use the strip, still we get only the text that is hello. Or if we write down using say some special characters there, dot strip, still it is coming the same way. Or if we try to give space before, okay, and say here dot strip. Now in between the words, the space will be counted, but before and after that would be removed. In the given examples over here, this strip method removes the space characters at the beginning, at the end of any two given strings. Okay, so if a particular string includes space at the beginning or at the end of the string, the method removes them from both the sides but doesn't remove any space between other characters. Okay, the strip method can also have a string argument passed to it that tells a method to remove characters other than white space from the beginning and the end of the string. Now to see an example for this, say we give over here another example, say write down any characters, or let's write down just one character in this case, say ppp, write down here hello ppp, okay, dot strip, and we give the character p, so it removes p from everywhere. Okay, or suppose we have used say ab everywhere, this is our text, we use here dot strip say ab, so it removes ab and gives us the given string. Okay, like that way we can give here the example. Okay, so if you pass a string argument say a or ab, remove these characters when they occur at the beginning or the end of the string. Similarly, but the given strip function doesn't remove characters embedded in the middle of the string. So let us see applying the strip string method over in our given program here. Now let's return to the source code and see how to apply the strip in our given program. So after this, if we go below, okay, we are having this if condition over here. Now in this we are using say if the response dot strip dot upper dot starts with D. Now if the condition for the statement were simply response is equal to capital D, the user would have to enter capital D exactly and nothing else to end the program. For example, if the user enter a small d or some spaces capital D or say D capital done, the condition would be false and the program would continue checking other keys instead of returning the hacked message. So to avoid this issue, the string in the response removes the white space from the start and the end of the string with the call to strip. Then the string that uses a response.strip evaluates to has the upper method called on. Whether the user enter a small d or a capital D, the string returned from the upper will always be capitalized as capital D. So adding the flexibility in the type of the input, the program can accept and make it easier to use. Now to make the program accept user input that starts with D but it is full word, we can use the starts with to check only the first letter. For example, if the user input says space done as a response, then the white space would be stripped and the string done would be passed to upper. After upper capitalizes the whole string into capital, the string is then passed on to starts with, which returns the true because the string does starts with the substring D. Now, if the user indicates that the decrypted string is correct, the function hack transposition str will return the decrypted text str. Now, failing to hack the message. Now, for example, if the first line of the for loop that began over here, in that is for key str in the range, if that particular loop has begun and the program execution reaches this point, it means the program has never reached the return statement, which would happen if the correctly decrypted text was never found for any of the keys that were tried. So in that case, it returns none value to indicate the hacking has failed. Okay, so after this we come to the last part over here, that is we are checking, okay, call to the main function if this program was run by itself rather than being imported by another program using its hack transposition str function. Okay, so remember that the name variable is set by Python and the main function will not be called if your current file, that is transposition hack example, is imported as a module. Okay, so with this we have understood how the particular program has been created, how does it execute, and what is the output that we are getting from the executed program. Now in this particular session we would be learning about the multiplicative cipher and the affine cipher. Now the multiplicative cipher is similar to your Caesar cipher but encrypts using the multiplication rather than addition. And the affine cipher combines the multiplicative cipher and the Caesar cipher, resulting in a stronger and a more reliable encryption. But first, you should learn about the modular arithmetic and the greatest common divisors, two mathematical concepts that are required to understand and implement the affine cipher. So using these concepts, we will create a module to handle a wraparound and find the valid keys for the affine cipher. And we would be using this module when we create a program for affine cipher in the next session. Okay, so in this particular session, we would be covering modular arithmetic, the modulo operator, the greatest common divisor, multiple assignment, using the elucid algorithm for finding the GCD, that is the greatest common divisor, the multiplicative and the affine ciphers, and we will extend the algorithm for finding the modular inverse. Starting with the modular arithmetic. Now the modular arithmetic or the clock arithmetic refers to math in which numbers wrap around when they reach a particular value. We will use modular arithmetic to handle wraparound in the affine cipher. Now let's see how it basically works. Imagine a clock with just an hour hand and a 12 replaced with a 0. If programmers design clock, the first hour would begin at 0. So if the current time is say 3 o'clock, what time it will be in 5 hours? That is easy enough to figure out, that is 3 plus 5, that is 8. It will be 8 o'clock in 5 hours. Think of an hour hand starting at 3 and then moving 5 hours clockwise. If the current time is 10 o'clock, what time it would be in 5 hours? So adding 5 plus 10, that is 15. But 15 o'clock doesn't make sense for clock that shows only 12 hours. So to find out what time it will be, you have to subtract 15 minus 12, that is 3. So it will be 3 o'clock. So normally you would distinguish between 3 a.m. and 3 p.m. But that doesn't matter in a modular arithmetic. Now double check this math by moving the hour hand clockwise 5 hours starting from 10. It does indeed land on 3. If the current time is 10, what time it will be in 200 hours? So adding 200 plus 10 is 210 and 210 is certainly larger than 12. because one full rotation brings the hour hand back to its original position. Now we can solve this problem by subtracting 12, which is one full rotation, until the result is lesser than 12. So subtracting 210 by 12 is 198. Again say 198 is still larger. So again you say continue to subtract 12 until the difference is less than 12. So in this case the final answer would come to 6. So if the current time is 10 o'clock, the time 200 hours later would be 6 o'clock. So if you want to double check the 10 o'clock plus 200 hours math, you can repeatedly move the round hand around the clock face. When you move the forehand for 200 hours, it should have. However, it is easier to have the computer do this modular arithmetic for us with the modulo operator. So coming to the modulo operator, you can use the modulo operator abbreviated as mod to write down the modular expressions. Now in Python, the mod operator is the percent sign. You can think of a mod operator as a kind of division reminder operator. For example, if we say 21 divided by 5, it comes to 4 with a remainder of 1. And if we say 21 modulo 5, it comes to 1. So similarly, if you say 15 modulo 12, it is equal to 3. Just as 15 o'clock would be 3 o'clock. Enter the following into the interactive shell to see how the mod operator is coming to act. If we go here, we type say 21, say modulo 5, you get the value 1. If we say 10 plus 200 modulo 12, we get 6. If we say 10 modulo 10, that is 0. If we say 20 modulo 10, that's also coming to 0. Now, just as 10 o'clock plus 200 hours will wrap around to 6 o'clock on the clock with 12 hours, that is 10 plus 200 divided by a modulo 12 will evaluate to 6. Notice that numbers that divide evenly with mod to 0, such as 10 modulo 10 or 20 modulo 10. Now later we will use the mod operator to handle wraparound in the affine cipher. It's also used in the algorithm that we will use to find the greatest common divisor of two numbers. Now which is enable us to find the valid keys for the affine cipher. So moving to finding the factors to calculate the greatest common divisor. Now factors are the numbers that are multiplied to produce a particular number. Consider 4 into 6, that's 24. Now in this equation, 4 and 6 are the factors of 24 because a number's factor can also be used to divide that number without leaving a remainder. So factors are also called as divisors. So number 24 also has some other factors, that is say 8 into 3 comes to 24, 12 into 2 also comes to 24, 24 into 1 also is 24. So the factors of 24 would be say 1, 2, 3, 4, 6, 8, 12 and 24 itself. Similarly, if we look at the factors of 30, we may have 1 into 30, 2 into 15, 3 into 10 or say 5 into 6. So the factors of 30 would be say 1, 2, 3, 5, 6, 10, 15 and 30 itself. So note that any number will have 1 and itself as its factor because 1 times a number is equal to that number. Notice too that the list of factors of 24 and 30 have 1, 2, 3, 6 in common. So the greatest of these common factors is 6. So 6 is the greatest common factor, more commonly known as the GCD of 24 and 30. Now it is easiest to find the GCD of two numbers by visualizing their factors. We will visualize factors and the GCDs using some manual approach also. Okay. Now coming to the multiple assignment. Now the GCD function we will write that will find the GCD of two numbers, but before you learn how to code it, let us look at a trick in Python called as multiple assignment. A multiple assignment trick lets you assign values to more than one variable at once in a single assignment statement. Now for example, if we enter something over here, say str common str2 is equal to 42 comma in single quotes hello. If we print str, we get 42. If we print str2, we get hello. Suppose if we say a1 comma b1 comma c1 or d1, that's equal to, here we give say abc in single quotes, then we give pqr, say stc, say lmn. Now if we try to print a1, we get abc, b1 we get c1 pqr, c1 stc and d1 is lmn, right? So in this particular approach, we can separate the variable names on the left side of the equal to operator as well as the values on the right side of the equal to operator using comma. You can also assign each of the values in a list to its own variable as long as the number of items in the list is the same as number of variables on the left side of the equal to operator. If you don't have the same number of variables as you have values, Python will raise an error that indicates the call needs more or has too many values. Now, one of the main uses of this multiple assignment is to swap the values in two variables. For example, if we try to enter something over here saying say str is equal to say hello, say str2 is equal to say Python. Okay, now if we say str comma str2 is equal to, we use here say str comma str2, or rather let's give str2 and here str. Now we try to print str, we get Python. We try to print str2, we get hello. So now after assigning hello to str and Python to str2, we have swapped those values using a multiple assignment. Okay, now let us look at how this swapping trick would implement in your, so the Euclid's algorithm for finding the GCD. Now coming to the Euclid's algorithm for finding the GCD. Now finding the GCD seems simple enough. Identify all the factors of two numbers you will use and then find the largest factor they have in common. But it isn't so easy to find a GCD of larger numbers. So a Euclid, a mathematician, who has basically come up with a short algorithm for finding a GCD of two numbers using a modular arithmetic. So here's a GCD function that implements this algorithm in Python code, returning the GCD of integers that we are passing it. So for example, suppose we write something like, say, we will not save this, it is just for our demonstration. We say define GCD in brackets say a comma b, and here we are defining say while a not equal to 0. Here you are saying a comma b equal to b divided or modulo a comma a, and then we say return the value of b. Okay, now in this GCD function, it takes two numbers a and b and then uses a loop and multiple assignment to find the GCDs. Okay, now exactly how the Euclid's algorithm work is beyond the scope of this particular session, but you can rely on this function to return the GCD of two integers. You pass it. If you call this function from the interactive shell and pass it say any number of parameters to a and b, it would return a particular value. Now let us try and save this. We would save it in our intermediate level and let us give it a name, say gcd1.py. Okay, and now if we go back here, now after saving this, if we go back to interactive shell and if we say gcd say, okay, now we'll have to import it, saying say import gcd1.py. Now by what name have we saved it? It is gcd1.py. okay, but it has not found the module into it. So let us do one thing. Let us define this directly over here. Okay, and now we say gcd and some value, say 24 and 36 or 32. So we get there the number as 8. Okay, so over here, the great benefit of this is you can easily handle large numbers also. For example, if you want to handle some large number over here, pass on the parameters, you will get the highest factorial, that is the highest common factor there. Okay, so this particular GCD function will come in handy when choosing the valid keys for the multiplicative and the affine ciphers, which you will learn in the next session. Now coming to understanding how the multiplicative and the affine cipher works. Now, in the Caesar cipher, encrypting and decrypting symbols involved converting them to numbers, adding or subtracting the keys, and then converting the new number back to a symbol. So when encrypting with a multiplicative cipher, you will multiply the index by the key. For example, if you encrypted a letter E with the key 3, you would use E's index 4 and multiply it by the key 3 to get the index of the encrypted letter. which would be something like 4 into 3 is equal to 12, which would be say M. Now when the product exceeds the total number of letters, the multiplicative cipher has a wraparound issue similar to the Caesar cipher, but now it can use the mod operator to solve this. For example, a Caesar cipher symbol variable that we had was storing all the capital letters, small letters and numbers. Okay, now we can also use that all the few characters of this symbol along with their indexes. And you can calculate what these symbols encrypt to what the key is. Okay, and you can encrypt a particular symbol, say F with a key 17, multiply its index, say 5 by 17 and the mod the whole result by 66 to handle the wraparound of 66 symbol set. And the result would be say 19. So 19 corresponds to the symbol T, for example. In this way, we can handle that. If we coming to the choosing a valid multiplicative keys, you can just use any number of multiplicative cipher keys. For example, if you choose 11, you can have a mapping, you would end up with some different values there. Now notice that this particular key doesn't work because symbol A, G and M all encrypt to the same letter A. So when you encounter an A in the ciphertext, you wouldn't know which symbol it decrypts to. So using this key would basically run into some problem in encrypting letters like AF, AN, FS and others. Now, in a multiplicative cipher, the key and the size of the symbol set must be relatively prime to each other. Now, two numbers are relatively prime or co-prime if their GCD is 1. So, in other words, they have no factors in common except 1. For example, say numbers n1, n2 are relatively prime if GCD n1, n2 is equal to 1, where n1 is the key and n2 is the size of the symbol set. Okay, so as in the earlier example, because 11 and 66 have a GCD that isn't 1, they are not relatively prime, which means that key 11 cannot be used for a multiplicative cipher. Note that the numbers don't actually have to be prime numbers to be a relatively prime to each other. So knowing how to use a modular arithmetic and the GCD function is important when using a multiplicative cipher. You can use the GCD function to figure out whether a pair of numbers is relatively prime, which you need to know to choose a valid key for multiplicative ciphers. Okay, so a multiplicative cipher has only 20 different keys for a set of 66 symbols, even fewer than the Caesar cipher. However, you can combine the multiplicative cipher and Caesar to get a more powerful affine cipher, which we would be discussing later. So now let us understand encrypting with an affine cipher. Now one downside to using the multiplicative cipher is that the letter capital A always maps to letter capital A. The reason is that capital A's the index number is 0 and 0 multiplied by anything will be 0. Now you can fix this particular issue by adding a second key to perform a Caesar cipher encryption after the multiplicative ciphers multiplication and modding is done. Now this extra steps changes the multiplicative cipher into an affine cipher. Now the affine cipher has two keys. Say for example key A and key B. Now say key A is the integer you use to multiply the letters number, and after you multiply the plain text by key A, you add key B to the product. And then you mod the sum by 66 as you did in the original Caesar cipher. So this means that the affine cipher has 66 times as many possible keys as a multiplicative cipher. It also ensures that the letter A does always encrypt to itself. Okay. Now if we come to say decrypting with the affine cipher. Now in the Caesar cipher, you used addition to encrypt and subtraction to decrypt. In the affine cipher, you have used multiplication to encrypt. Naturally, you might think you can divide to decrypt with the affine cipher. But if you try this, you will see that it doesn't work. To decrypt with the affine cipher, you need to multiply the keys modular inverse. Now this reverses the mod operations from the encryption process. A modular inverse of two numbers is represented by an expression, say for example, A multiplied by I modulo M if it's equal to 1. Okay. Now where the I is the modular inverse and A and M are two numbers. For example, the modular inverse of 5 mod 7 would be some number I, where 5 into I modulo 7 is equal to 1. Now you can brute force this calculation. For example, like 1 is in the modular inverse of 5 mod 7 because 5 into 1 modulo 7 is 5, and second is in the modular inverse of 5 mod 7, because 5 into 2 modulo 7 comes to 3. So 3 is the modular inverse of 5 and 7, because if you say 5 into 3 modulo 7, it comes to 1. So although the encryption and the decryption keys for the Caesar cipher part of the affine cipher are the same, the encryption key and the decryption keys for multiplicative cipher are two different numbers. Encryption key can be anything you choose as long as it's relatively prime to the size of the symbol set, which in this case is say 66. And if you choose the key 53 for encrypting with the affine cipher, decryption key in the modular inverse of 53 mod 66. So there in that case, you will have to check for say numerical 1, because say for example if you say 53 multiply by 1 modulo, and this whole we would put it in a bracket, say modulo 66, now this comes to 53, so 1 is not possible. Similarly, if we just copy down this some multiple times and just replace this value 53 into 2, now this comes to say 40. If we say 53 into 3, and that comes to say 27. If we say 53 into 4, and this comes to say 14. And here if we say 53 into 5, this comes to 1. Okay, so now in this case, okay, now because now here 5 is a modular inverse of 53 and 66. You know that the affine cipher decryption key is also 5. Now to decrypt a cipher text letter, multiply that letter's number by 5 and then mod it to 66. And the result is the number of original plain text letters that you have. So since say 66 character symbol set, let's encrypt the word, a particular word, say cat, using the key 53. Okay, so if we say over here, okay, now say we give capital C will be at the index say 2. Okay, so if we say 2 multiplied by 53, that will come to say 106, which is larger than the symbol set size because the size is 66. So we need to mod 106 by 66. So if we say 106 modulo 66, okay, if this comes to the result say 40, okay, the character at the index 40 in the symbol set, that is equal to say 0. Okay, so the symbol C encrypts now, say if we give here CAT, this first has encrypted to 0. Okay, now we'll use the same steps for the next letter, that is A available. Now this we have done it for C. So if we take A, okay, now the string A is at the index number say 26. So A is equal to 26. And if we say 26 multiplied by 53, then modulo 66. Now that comes to say 58. And the index at 58 is equal to 7. Okay, so we have encrypted A to 7. Okay, now the string last, that is T, that is small t. Okay, so over here T comes at an index of say 45. So if we say 45 multiplied by 53 modulo 66, this comes to 9. And the index 9, you have the letter as capital J. So therefore the word CAT has been encrypted to 07J. Right? Now similarly, if you have to decrypt this 07J back to the original text, then we'll have to multiply the modular inverse. That is say 53 modulo 66. Okay, now this comes to 5. So the symbol 0 is at the index 40. Right? So we say 40 multiplied by 5. Then again modulo 66, and this comes to 2, which is the index of capital C. Symbol 7 is at the index 58. So if we just take it over here, the first one, that is we have O. Okay, so O, the index is 40. Okay, now the next index is 7 letter, so the index of that is say 58. So now if we try to do 58 multiplied by 5 modulo 66, that comes to 26. Okay, which is equal to A. And then the symbol capital J, the index is 9. Okay, and here we say 9 multiplied by 5 modulo 66, which is equal to 45, which is equal to T. So the ciphertext 07J has encrypted or decrypted back to C80, where C is capital, which is original plain text, just as expected, right? Now coming to finding the modular inverse. Now to calculate the modular inverse, to determine the decryption key, you could take a brute force approach and start testing the integer 1 and then 2 and 3 and so on. But this is a time consuming for large keys if you have, say, somewhere in lakh. So fortunately, you can use the Euclid's extended algorithm to find the modular inverse of a number, which in Python basically looks like we would use it by defining a particular method. Okay, just for your understanding, if we define here, say the find mod inverse, which take say a comma m as the parameters, and here we check if GCD a comma m, okay, if that is not equal to 1, then we are saying here return none, and then we use here say u1, u2, u3 as equal to 1, 0, a respectively. Similarly, say v1, v2, v3 equal to 0, 1, m for example, and we say while v3 is not equal to 0, we are putting it in q is equal to say u3, and we are saying v1, v2, v3, u1, u2, u3 is equal to say u1 minus q multiplied by v1. Similarly, next u2 minus q multiplied by v2, and next say u3 minus q multiplied by v3, and v1 comma v2 comma v3. Okay, and then finally we say return u1 modulo m. Okay, now in this but basic example that we have done, you don't need to understand how the Euclid's extended algorithm works. Okay, now as long as you have two arguments to pass it to the find mode inverse function, which are relatively prime, it will return the modular inverse of the given of particular parameter. So coming to the integer division operation. Okay, now we won't save this. This is just for your understanding purpose. Okay, now you may notice that the double slash operator is used in the, if you just look at this, you must have noticed, okay, here we have made a mistake, that is q is equal to, we have to do u3. Now that is double slash v3. Okay, now if you have noticed that we have used here the double slash operator. Okay, now it divides two numbers and rounds down to the nearest integer. If you want to see how this operator works, okay, if we go back to our interactive shell and if we say, for example, 31 divided by 7, we get some numbers, integer numbers. But if we say decimal numbers, if we say double backslash 7, we get it rounded off to 4. Or we get it say 10 by 5, that already comes to 2. Okay, so over here, wherever you are getting the equation or particular expression is evaluating to a decimal point, if you use a double backslash, okay, you are getting a whole number there. So a division expression that do not divide evenly, the double slash operator is useful for getting the whole number part of the answer. This is sometimes also called the quotient. Now while the percentage operator gets the remainder, an expression that uses double slash integer division operator always evaluates to an int, not a float. Okay. So, okay, for example, if we say 10 divided by 5, we get 2.0. The same thing if we say 10 divided by 5, we get it only 2, not 2.0. So now let us write down a source code for a crypto math module. Okay, now we would be using a GCD and the find mode inverse method in more cipher programs later. But over here, we would put both of these functions into a module. So as we have created this, okay, where we have already defined the find mode inverse, the first thing we would try out over here is we would define the GCD, pass a comma b into it as the parameter, and here we would say while a is not equal to 0, we are saying a comma b is equal to b modulo a and a. Okay, and then we use return the value of b. There we end this GCD function. Then we have the find mode inverse, which is taking again a and m as the parameter. And here we are checking if GCD a comma m is not equal to 1, then we are saying return none. Okay, otherwise we are calculating the extended Euclidean algorithm. Okay, and we are saying here, say u1, u2, u3 is equal to 10a and v1, v2, v3 is equal to 01m. Then we say while v3 is not equal to 0, we are saying q u3 double slash v3. Okay, and now here we have used this integer division operator, and then we have used this assignment operator. We are returning u1 modulo m. Now this program contains the GCD function described earlier and the find mode inverse function also, which implements your Euclid's extended algorithm. Now after importing this, now suppose we save this, say we are saving it in our intermediate level folder and we give it a name, say cryptomath1.py. Okay, and now if you have to suppose go to the interactive shell here, and the first thing you say is import, say cryptomath1 dot or import cryptomath1. Oh, sorry, that is import cryptomath1. Okay, and now if we say cryptomath1 dot, we use GCD to find out some number, we get the values. Similarly, let's use one more, say cryptomath1 dot GCD, some different number, we still get it. Or if we try to use cryptomath1 dot, say find mode inverse, we give say 7,26. Or if we try cryptomath1 dot find mode inverse, we give a higher number. Okay, let's see, cryptomath1 find mode inverse, we give here say 8953851 comma say 26. Yeah, you get the particular value. Okay, so in this way you can see you can call the GCD function also and the find mode inverse function to find the GCD or a modular inverse for given to number. Now this particular file we would be using in our next session for implementing the affine ciphers. Welcome to the next session in Python Hacking Intermediate Level course. Now in the earlier session we have learned that the affine cipher is actually the multiplicative cipher combined with the Caesar cipher, and the multiplicative cipher is similar to a Caesar cipher except it uses multiplication instead of addition to encrypt the messages. So now in this session we would build and run a program to implement the affine cipher. Now because the affine cipher uses two different ciphers as part of its encryption process, it needs two keys, one for a multiplicative cipher and another for a Caesar cipher. So for the affine cipher program, we will split a single integer into two different keys. And the topics which we will be covering in this session would be the tuple data type, how many different keys can an affine cipher have, and generating some random keys. So we move on to the source code for the affine cipher program. So here we would be creating a file, new file, and we would be entering the code into this particular file editor. We would save it with a file name .py. Now make sure that wherever you save this file, you should have the paperclip module, the crypto module that we created in the last session in the same folder as you are saving the same file. So let us start creating this file now. The first thing is, let us go to our Windows Explorer. So we go to the Explorer. Now in E drive, we are saving in Python intermediate level all the codes. So here we have the cryptomath1 module and we have the paperclip module. Okay. So now let's go back to our code here in the new file. And first thing is we will have to say import. Now we would be importing the sys, then paperclip, then our cryptomath1, that is CRY. Okay, and then random. After this import, we are creating here, say, symbols str, that's equal to saving all the capital letters I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now all in small, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and then the numbers till 0, then a space, exclamation, question mark, period operator, and close the single quotes. Now after this, we are going to define the main method, and in this we would be creating, say, my message str, and that's equal to, now we are giving it in a triple quote, saying a computer would deserve to be called as intelligent if it could behave like a human into believing that it was human. Some phrase we have written. Okay, let us give some name, ABC, PQR. Okay, and then we will close this with triple quotes. So now let's just give one. Okay, and here we would be creating the next, that is, say, my key str, and that is equal to, we are giving 2894 for example. We are creating here my mode str, and that is equal to, we are giving the text as encrypt. Now here you can either set it to encrypt or decrypt. Currently we are setting it to encrypt, and then we are checking below that if the value of my mode str is equal to encrypt. Okay, then what are you supposed to do? Let's go below and we will open the colon, and here we would create, say, translated str is equal to, now we would be calling this encrypt message that we are going to create below. So here we would say encrypt message str, pass there my key str and my message str. Then you check that else if your my mode str, if it is equal to decrypt, not encrypt, then you will say translated str is equal to, we would be creating decrypt message str, and again we would be passing the my key str and my message str in this. And after this, let's go back here and print the value of key colon, say %s, we print here in my key str, and after this the next print we give in single quotation marks, say %sed text colon, close this, and here you give say my mode str dot title, then print the value of translated str here, and use paperclip dot copy for copying the translated str, and print here, say full sed text copied to clipboard, and print here the value of my mode str. Now once you have done all the transactions, let us end this function here and go back here and define, say, get key part str, and here we would pass the parameter key str, and here we will get, say, key a1, that's equal to, say, key str length of symbols str. Similarly, key b1 is equal to key str, and then here we do modulus length of symbols str, and then we return here the value of key A1 comma key B1. Now after we have returned the value of key, we need another definition, that is say check key str, and here we are passing the value of key A1, then key B1 and mode str, and then here we are checking that if say key A1 is equal to 1 and say mode str is equal to say encrypt, then what are you supposed to do? Say sys.exit. Here we print say cipher is weak if key A1 is 1. So we give here say choose a different key. So directly we are saying here sys.exit for that. Now once we have done this, let us check for another option, another if part. So here we would check again another if condition, that if your key B1, if that is equal to 0 and your mode str is equal to encrypt. Okay, then again you are saying sys.exit and you are giving a message say cipher is weak if, that's if say key B1 is 0, say choose a different key. Okay, this is another that we have checked. Another we will be checking here, that if your key A1 is less than 0 or your key B1 is less than 0 or say key B1 is more than the length of our symbols str, and that comes to length minus 1. Then if this is true, again we are saying sys.exit, say key A1 must be greater than 0 and your key B1 must be say between 0 and print %s and print here percent in bracket say length of symbol str minus 1. Now once we have checked with this, the next we will check in the if condition, that is say if your cryptomath1 dot use the gcd function there, pass key A1 there and pass the length of symbols str, and if that is not equal to 1, then again you say sys.exit and print here say key A1 in bracket %s and the symbol set size in bracket again %s are not relatively prime. Say choose a different key and print %, say key A1 here, then the length of symbol str. Now after we have checked for all the conditions in the check key str method that we have defined, we move on to creating the encrypt message str method, which will take the key str and the message str, and inside this we would be creating key A1 comma key B1, that equals to we get the key part str pass there the key str. So we are getting those values which are returned. Since there are two values which are returned, we are creating here two variables to hold the values. Then we call the check key str method, and here we pass A1, key B1 and the text encrypt. Then we create here say cipher text str that's equal to blank initially. We run a for loop for symbol in message str. We check if the symbol in symbol str, then here we create symbol id x that's equal to symbol str dot use the find method and pass symbol into it. And then we say cipher text str plus is equal to symbol str, open the square bracket. Here you pass the symbol idx, multiply that with key A1 plus key B1 and divide that with the length of symbol str. Then close the square bracket. Now this is the if part that we have written. We'll move on to the else part here, and here we would write the cipher text str plus is equal to the symbol. So we are basically appending the symbol without encrypting it. And at the end, in the last, we would say return cipher text str. That is the end of our definition of encrypt message. Similarly, we are having decrypt message str. This also takes key str and message str. And in this, we are again creating key A1, then key B1. That's equal to, we are calling the get key part str, passing there the key str. Then we are calling again the check key str method and passing in that A1, B1 with the text decrypt now, because now we want to decrypt it. So for storing decrypt text, we take plain text str which is equal to blank. Then we create a mod inverse of key A. That's equal to, now we are calling the crypto math1 dot, we call now in that file, let us just check. We'll go to our file and let us open this in Python itself. Rather, let's temporarily open this using say notepad. Now in this we are having this find mod inverse. Same method we are having. So let us go back here, and now the same method name we would write down find mod inverse, and we pass there key A1 and the length of symbol str. So that value will be stored in the mod inverse of key A1. Let's give here A1. That is easy for us to remember. So let us continue here. We would go for a for loop, say creating for symbol in message str, and in this for loop we would check if the symbol in symbol str, then we are decrypting the symbol. So we are saying here symbol idx is equal to, use here symbol str dot the find method and pass symbol in that. Then you take the plain text str plus is equal to, say symbol str in square bracket round bracket the symbol idx minus the key b1 multiplied by the mod of inverse of key A1, that modular length of symbol str. Close that. Then we write down here the else part, that if this is not true, then we take the plain text str as plus is equal to symbol, and finally we use a return statement and return the value of plain text str. Now that is the end of our decrypt message str. Now here we are defining another method, that is say get random key str, and in this method we are running a while loop while it is true t is capital, and while this is true we are saying key A1 is equal to, we are generating random dot rand int method, passing there 2 and the length of symbol str, this is 1. Then for key B1 again we are saying random dot rand int, again passing 2 and the length of symbol str. Then we check if crypto math 1 dot our GCD method, here we are passing A1 in that and the length of symbol str. If that's equal to 1, then we are saying return key A1 multiplied by len of symbol str, and plus we say key B1. So after this we are using this if condition and checking if the cryptomath1.gcd function, in that we are passing the A1 key and the length of the symbol str. If that comes to equal to 1, then you're returning the value of A1 multiplied by the length of the symbol str and the value of B1. Now once we have completed this, we would check here, say if underscore name underscore is equal to, say in single quote underscore main underscore, then you're going to call the main method. Now let us save this program and let's give here a meaningful name for this as say a fine cipher, something like that. So we would save it here, a fine cipher. Let's give say a fine cipher demo dot py. Okay, and let us save this. And now let us try and run the module. So we are getting this encrypted text and full encrypted text is copied to the keyboard. So now for example, if we copy down this particular text, go to our program back here, and if we put that text over here, let's select this and paste it here, and now we would give here decrypt. Then let us save it and again try to run this. So now it has been decrypted, same to same as it is. So we have seen encryption process also and the decryption process also, right? So now let us understand set the program that we have written. So let's come back here and go to the first line, that there is where we are basically setting up the modules, the constants and the main function. So here we are first of all giving the 4 modules which we have imported in this session. That is basically the sys module for is imported. Basically we have used the exit function, sys.exit. Hence we have imported that module. Paperclip module is imported for the copy clipboard function that we are using. Then the cryptomath1 module that we have created in the earlier session is imported because we are using the GCD function. Also the find mode inverse function from that particular module. Similarly, the random module that is imported for the random.randint function to generate some random keys. So the string stored in the symbols str variable is a symbol set, we can say, which is basically list of all the characters that can be encrypted. So here we have given all the characters in capital, in small case, also numbers. So any characters in the message that don't appear in this remains unencrypted in the ciphertext. For example, if you run the particular example, you can see there we have this dash that is remaining unencrypted because that is not what we have given here. So that don't get encrypted in the ciphertext because they don't belong to your symbol set that you have defined. Then we are defining the main function, which is almost exactly the same as the one we have in the transposition cipher program, right? So it stores the message str, then your key str and your mode str variables respectively, right? Then the value stored in your my mode str is either set to encrypt or decrypt. So we are checking that over here, whether the program encrypts or decrypts the message. So if my mode is set to encrypt, we execute and return value of the encrypt message str and it is stored in the translated str variable. But if my mode str is set to decrypt, then we call the decrypt message str method and the return value is stored again in translated str. Now this encrypt message str and decrypt message str functions, we would understand that somewhere later in the session. Now after the execution of this line, we come over here where we are having the translated variable that has the encrypted or the decrypted version of the message in the my message str. So we are using some ciphertext using the %s placeholders that basically tells the user whether the output is encrypted or decrypted. So after this, we are having some print statements which print some string in the translated str, which is encrypted or decrypted version of the string in my message str. And again, after that, we are copying that to a paperclip module using the clipboard and later notifies the user that it is copied on the clipboard. Now after this, we come to calculating and validating the keys. Now unlike the Caesar cipher, which uses addition with only one key, the affine cipher uses multiplication and addition with two integer keys, which we will call it, say for example, a key A1 and key B1. Because it is easier to remember just one number, we'll use a mathematical trick to convert two keys into one. So now let us look at that where we are converting one key or one number into two keys. So here we come to the method that is get key part str, which splits a single integer into two integers for key A1 and key B1. So the key split is passed to the key parameter. The key A1 is calculated by using an integer division to divide the key by len of symbol str and the size of the symbol set. Then the integer division, that is double slash, returns the quotient without a remainder. So the mode operator calculates the remainder which will be used for key B1. So for example, suppose we are having, say here, key as 2894. Then the key parameter and the symbol str string of say 66 characters. Key A1 would be, say we just write down here key A1 will be equal to 289466, which will come to say 43. And your key B1 would be 2894 modulus 66, which will be say 56. Now to combine key A1 and B1 back into a single key, we'll multiply key A1 by the size of symbol set and key B1 to the product. That is, we would say, for example, say in bracket 43 multiplied by 66 plus 56, which will come to again 2894, which is the integer key we started with. So now let us move on to the tuple data type. So let's just put this particular part in the comment. So which will not be executed as such. It is just there in your particular program, which will help you understand what are we trying to do in the above given two parts. So once we have done this, now we move on to the next code where we are basically returning the list values except the parentheses are used instead of the square brackets. Now this is basically called as your tuple value. Okay. A tuple value is similar to a list value in that it can store other values which can be accessed with indexes or slices. However, unlike list values, tuple values cannot be modified. So there is no append method for tuple values. Now, because this particular program doesn't need to modify the value returned by the getKeyPartStr method, using a tuple is more appropriate than a list. Now, the next thing is we check for the weak keys over here. Encrypting with the affine cipher involves a character's index in the symbols str being multiplied by key A1 and then added to key B1. But if key A1 is 1, the encrypted text is very weak because multiplying the index by 1 results in the same index. So in fact, as defined by the multiplicative identity property, the product of any number is 1 is that number. So similarly, if key B1 is 0, the encrypted text is weak because adding 0 to the index doesn't change it. If key A1 is 1 and key B1 is 0, at the same time, the encrypted output would be identical to the original message. So in other words, it won't be encrypted at all. So we check this weak keys using this check key str function, and the statement or the if statement in this particular function checks whether the key A1 is 1 or key B1 is 0, which is over here. So we check if key A1 is 1 or B1 is 1 and the mode str is encrypt. So if these conditions are met, the program exits with a message indicating that what went wrong. So below those lines, we are using or we are passing a string to sys.exit function, and sys.exit function has an optional parameter that lets you print a string to the screen before terminating the program. So you can use this function to display an error message on the screen before the program quits. Now to check, or these checks prevent you from encrypting with weak keys. But if your mode is set to decrypt, then the check comes which we have checked below here. That is on this line. Now here the condition checks whether A1 is a negative number or key B1 is greater than 0 or less than the size of the symbol set -1. So now the reasons the key are in this range is described in the coming session. If any of these conditions is true, the keys are invalid and the program also exits. Additionally, key A1 must be relatively prime to the symbol set size. So this means that the greatest common divisor or the GCD of key A1 and the length of symbol str must be equal to 1. So this we are basically checking over here in this if condition. Okay, which is basically checking that if this statement, the program, if the two values are not relatively prime. So if all the given conditions in your check key str function returns false, nothing is wrong with the keys and the program doesn't exist. Program execution returns to the line that originally called the check key str method in our main. So now let us understand how many keys can an affine cipher have. Now let us try to calculate the number of possible keys the affine cipher has. The affine cipher's key B1 is limited to the size of the symbol set, where the length of your symbol str is 66. So at first glance, it seems like key A1 would be larger or as large as you want it to be, as long as it's relatively prime to the symbol set size. Therefore, you might think that the affine cipher has an infinite number of keys and cannot be brute force. But this is not the case. Recall how large keys in this Caesar cipher end up being the same as smaller keys due to the wraparound effect. So with this symbol set size of 66, the key 67 in the Caesar cipher would produce the same encrypted text as key 1. The affine cipher also wrap around in this way. Now because the key B1 part of the affine cipher is same as your Caesar cipher, its range is limited from 1 to the size of the symbol set. Now to determine whether the affine cipher's key A1 is also limited, we'll write down a short program to encrypt a message using several different integers for key A1 and see what is the cipher text look like. So we'll open a new file editor and enter some code into it, save it with a particular name in the same folder as we had the affine cipher program created and the cryptomath1 file. So let us create here a new file. Now in this, the first thing is we would import our affine cipher demo and the cryptomath1. And now here we will take, say, the message str is equal to, we'll give here some text, say this is as simple as possible but say not simpler, something like that. And we would run here a for loop, say key A1 in the range we give here say 2, 80. We run this, say key str is equal to key A1 multiplied by the length of, now here we will use the affine cipher demo dot our symbol str plus 1. Then we check here that if say cryptomath1 dot, we call the GCD function, pass their key A1 and the length of affine cipher demo dot symbol str, if that's equal to 1, then we give here a print saying key A1 comma the affine cipher demo dot, we call here the encrypt message str and pass key str comma message str. So we will save this program in the same location. Let us give here say affine key demo dot py. And if after saving this, let us execute this. So see here how many keys it is using, any random number of keys. Now in this particular program that we have written, we are importing the affine cipher demo for the encrypt message function and the cryptomath1 module for its GCD function. Now we'll always encrypt a string stored in the message str variable. So the for loop remains in a range between 2 to 80. Because in this case 0 and 1 are not allowed, or not allowed as a valid key we can say. So an integer as explained earlier. So on each iteration of the loop, we calculate the key from the current key A1 and always uses 1 for key B1. Now which is why 1 is added at the end of the particular session over here after the for loop. Now keep in mind that key A1 must be relatively prime with a symbol set size to be valid. So key A1 is relatively prime with a symbol set size if the GCD of the key and the symbol set size is equal to 1. So if the GCD of the key and the symbol set size is not equal to 1, the if condition on this particular line will fail or will skip the call to encrypt message. So in short, this program prints the same message encrypted with several different integers for key A1, which the output we have seen there. So look carefully at the output. You will notice that the cipher text, let's say for key A1 for 5, let's see over here, is same as a cipher text for, let's say, check it over here, see this one, similar to this 71. Okay, in fact cipher text from key 7 and 73 are also same. If you look at this, say 73, and see this one, this also are same, right? And the cipher text for 13, if you look at this one, and your say 79, this one is also same. So notice that subtracting 5 from 71 results in 66. Size of our symbol set. This is why key A1 of 71 does the same thing as key A1 of 5. The encrypted output repeat itself or wrap around every 66 keys. So as you can see, the affine cipher has a same wraparound effect for key A1 as it does for key B1. So in sum, key A1 is also limited to the symbol set size. Now when you multiply 66 possible keys A1 keys by 66 possible keys B1, the result is 4356 possible combinations. Now when you subtract the integers that can't be used for key A because they are not relatively prime with 66, then the total number of possible key combinations for affine cipher drops to 1320. So now we would come to understand what is writing the encryption function which we have written in our affine cipher file. So let us close this key demo now as we have understood this, and let's go back to the cipher demo. Now here will come to the encrypt message str. So now here, this is basically used to encrypt the given message. It takes the parameter. Now we need to get the integer values for key A1 and B1 from the getKeyPart method that we have defined by passing it on the particular key str. So next we check whether these keys are valid by passing them to the checkKeyStr method over here. Now, if your checkKeyStr function doesn't cause the program to exit, the keys are valid and the rest of the code in the encrypt message function will execute. So here we are having the ciphertext str variable that starts as a blank string but will eventually hold the encrypted string. The for loop that begins iterates through each of the characters in your message str and then adds the encrypted character to your ciphertext str. By the time the for loop is done looping, the ciphertext str variable will contain the complete string of the encrypted message. So on each iteration of the loop, symbol variable is assigned a single character from the message str. If this character exists in symbol str, which is our symbol set, the index in symbols str is found and assigned to the symbol index on the next line over here where we are checking that. Then, to encrypt the text, we need to calculate the index of the encrypted letter. So, we here say the symbol index by key A1 and we add it to key B1 to produce the given output. And then it mods the result by the size of your symbol set represented by expression length in bracket symbol str. Now modding by length symbol str handles the wraparound by ensuring the calculated index is always between 0 and up to but not including the length of symbol str. So the resulting number will be indexed in the symbol str of the encrypted character, which is concatenated to the end of the string in your ciphertext str. So everything in the previous that we have seen is done using a single line of code over here that is selected. Okay. So if your symbol isn't in our symbol set, symbol is concatenated to the end of the ciphertext over here in the else part. The quotation marks and the hyphen in the original message are not in the symbol set and therefore they are concatenated directly to the string. So after this code is iterated through each character in the message string, ciphertext str variable should contain the full encrypted string, which returns the encrypted string from the particular function that is encrypt message str. So now let us understand writing the decryption function. So here we have returned this value for the encrypt message str. Okay. Now here the decrypt message str function that decrypts the text is almost the same as our encrypt message str. So here we have this keys, we check the key str, we create a plain text, and here we are using the cryptomat one for finding the mode inverse. Okay. So instead of multiplying by key A1, the decryption process multiplies by the modular inverse of key A1. The mode inverse is calculated by calling the cryptomath1.find mode inverse, which we have already seen in the earlier session. Now after this, if you see the for loop, this is almost identical to the encrypt message str. The only difference comes over here when in the encrypt message, the symbol index was multiplied by key A1 and then key B1 was added to it. In the decrypt message function, the symbol index first subtracts the key B1 over here, and so subtracting after the key B1 from the symbol index and then it multiplies it by the modular inverse. Then it mods this number by the size of your symbol set, that is the length of your symbol str. Now this is how the decryption process undoes the encryption. Now let us look at how we can change it so it can randomly select the valid keys for a fine cipher. So we move on to generating the random keys. Now if you look at over here in your program, we have this get random key str. Now it can be difficult to come up with a valid key for an affine cipher, so you can instead use the get random key str function to generate a random but a valid key. To do this, simply change it to this particular, like here we are saying. Now if we just go above, we are giving here say the value of my key str here. Now instead of giving a key value here, we can say call this get. Now how have we defined this? get random key str, give this. And while printing also, we are giving here say key str %s, and we are printing the value in the my key str. So now the program randomly selects a key and print it to the screen when it executes. Now let us look at how the get random function works. So let us go below and come to this function here. We have entered a while loop in this, where the condition is true. This infinite loop will loop forever until it is told to return to the user terminates the program. Now if your program gets stuck in an infinite loop, you can terminate the program by pressing Ctrl C on Windows. Okay, so get the random key str function will eventually exit the infinite loop with a return statement. Now here we are determining the random numbers between 2 and the size of the symbol set for key A1 and key B1. Now this code ensures that there is no chance that key A1 or B1 will be equal to the invalid values 0 or 1. The if statement checks over here that we have given. It checks to make sure that the key A1 is relatively prime with the size of the symbol set by calling the GCD function in the cryptomath1 module. If key A1 is relatively prime with the size of symbol set, then these two randomly selected keys are combined into a single key by multiplying key A1 by the symbol set size and adding key B1 to the product over here. Now this particular line, that is the return statement, it basically returns the value from the get random key str function. Now if the condition returns false, the code loops back to the start of the while loop and picks a random number for key A1 and B1 again. Infinite loop ensures that program continues looping until it finds random numbers that are also valid keys. Now after that, the next thing that we have is just the similar one, which is calling the main function if this program was run by itself rather than being imported by another program. So this ensures that the main function runs when the program is running, but not when the program is imported as a module. So now if we try to execute this, now we have done this for decrypting. Let us go back for encryption. So now we have used here, see, the key as 2723 in this case, and the decrypted text is over here. So let's go back here and let's write down a proper text. Let's select this and we'll write down here. So this is an simple program for a fine cipher, encryption of the text will see the output shortly after executing. Let us save this and we will change this to encrypt again. Let us run this. So now what key it has used? 4333 is the valid key which it has used for encrypting this particular message. So with this, we have completed this part. Now we will move on to the next session where we will see hacking this affine cipher. Now the affine cipher is limited to only a few thousand keys, which means we can easily perform a brute force attack against it. So in this session, we will learn how to write a program that can break affine cipher and encrypted messages. Also, in this session, we would be covering the exponent operator, that is the double asterisk or double multiplication, and the continue statement. Now coming to writing a source code for the affine cipher hacker program. Now first thing is, we would go to File, New, and write down the code in this editor window. We would save it by a particular name. Now, say for example, now in this, we would be using it to decrypt it. So instead of writing the encrypted text, we would run our affine cipher program. The encrypted text would be copied from the command to there after executing the program, and that would be pasted over here. So first thing we would do is, let us open a file which is Python cipher demo, affine cipher demo, okay? And we would first run this module. This is the encrypted text. So now let us simply copy down this and We can close this affine cipher now. And over here we would need it. So first thing is we'll have to import the paperclip. Then we will have to import our affine cipher demo, and we also have the check English. So if we just go to our intermediate level, this is our affine cipher demo. This is check English.py. So we'll use that also, and also our crypto math 1. So all these imports are necessary, which also means that you are supposed to save this file where you are having all these files there into your particular folder saved. Also with this, you should also have the dictionary.txt file which we are using it in the check English. So all these files should be in same folder where you are saving the current file. So after the importing of the statement is done, the next thing we would do is create, say, silent_mode, and we would give the value as false. We would define main. In this, now as we have suggested, we would create my message str is equal to, and we are simply copying down the text that we have already pasted it as we have already copied it. Okay, now the next thing we would do is say hacked message str, and that is equal to, we would be creating this function below hack affine str and passing this my message str to it. Okay, now here we check if your hacked message str is not equal to none, then what are you supposed to do? We are giving here a print command. First, say copying the hacked message to clipboard. Then we say print, again give here hacked message str, that is to be printed. After which then we give here say paperclip dot use the copy and put this hacked message str to it. Now if this is not true, we go to the else part and just print here a statement saying failed to hack the encryption. Okay, which means it is not been hacked. That is what we are defining in the main. The next thing we have to define here is the hack affine str that we are already calling it, in which we are passing the message str variable, and here we are first printing say hacking. After this, like we had given for a normal brute force in the earlier sessions, we are giving here a printf saying say press ctrl and C or ctrl and D to quit at any time. Close it. Then for the brute force looping through every possible key, so now here we are supposed to run a for saying say key str in the range of, here we use the length function and call the affine cipher demo dot symbol str. Okay, that we multiplied. Now here we are using this double multiplication operator. We would understand more about this later. Then we have say key a1 which is equal to, we take affine cipher demo dot get the, now let us just open our affine cipher demo in notepad, and we are having here get key part str. Okay, so let us take down the same thing, get key part str, and here we pass the key str index 0. Then we check if our cryptomath1 dot the gcd, where we pass a1 and the length of affine cipher demo dot symbol str. If that's not equal to 1, then we say continue Otherwise, we are going for, say, decrypted text str, that's equal to a fine cipher demo dot, we call this decrypt message str, and here again we pass key str and message str. Okay, then we check that if not silent underscore mode, then we are giving a print command saying tried key %s, print here %s and the value of key comma the decrypted text str, only the first 40. Now after this we say if, now all this is coming in the same for loop till now. Okay, so here we are checking if our check English dot, the function that we have in check English, if we open up with notepad, now that method that we have is English. So we will check here your check English dot is English check. So we give here is English check, and in bracket we give the decrypted text str as the parameter. And if it is in English, we check with the user that if the decrypted text has been found. So we first print a blank line, then we print, say, possible encryption hack, and we give the next print, that is, say, key colon print %s and the value of key str. Then here also it is key str. After giving this, we give another print command and we say here decrypted message plus we print the value of decrypted text str, and here also we print 200 characters. We give a print command, give another print, we give enter, D for done, or just press enter to continue hacking. After this, we check in the same thing that if your say, okay, now after putting this, we are supposed to take a response variable which will be equal to, we are taking the input from the user, okay, wherein we are taking this prompt. Then we check here if your response dot, we use the strip dot upper dot, say, starts with, if it is starting with D, then we are returning the value of decrypted text str. Otherwise, we are saying return none. After this return statement, then we check if name underscore is equal to main, then only you are calling the main function. Now we will have to save this program. So let us save it by giving it a proper name. Let us give here, say, a fine cipher hack demo dot py, and let's save it in the same folder. And once we have completed saving this, let us run this module and check the output. Decrypted message, you're getting it? Okay, so when we run this, now currently you're not getting any values. Suppose you just press enter there, it will continue, and now the key that was used was 1557. So at that particular key, you are getting the values decrypted. So now if we press D, it would stop. So over here, it will ask you, because a particular words are found, it would stop there. But if you want to continue, then you can just press enter and again continue hacking it. Now let us take a closer look at the Find Cipher hacker program that we have created. So let us go to the program. And the first line that is importing 4 different modules. One is your paperclip, affine cipher demo, check English, and cryptoman. So when you run the affine cipher hacker program, you will see that it produces a lot of output as it works this way through all the possible decryptions. However, printing all this output slows down the program. So if you want to speed up the program, set the silent mode variable to true to stop it from printing all these messages. So if we have done this false here, suppose we make this true and now we run this. So now you get there some particular values, not all. So now it will not be slowing your CPU time. This is if you want to do it. If you don't do it, even it doesn't matter. So we'll complete this execution first. We would make it again false. No need of doing it. The ciphertext to be hacked is stored in a particular string variable, that is my message str. Now this string is passed on to your hackaffine str function, which we will look in the coming session. The return value from this caller is either a string of the original message if ciphertext has hacked, or the none value if the hacking has failed. So over here we are checking using the if condition. So we check here that the hacked message str variable was set to none. And if hack message str is not equal to none, the message is printed on the screen and copied to the clipboard. Otherwise, program simply prints the feedback to the user that it was unable to hack the ciphertext. Now let's take a closer look at how the hackaffine str method that we have created works. So coming to the definition of hackaffine str. Okay, now it begins that contains the code for the decryption. First of all, it starts by printing some instructions to the users. Decryption process can take a while. So if the user wants to exit program early, they can press Ctrl+C on Windows or Ctrl+D on Mac or Linux. So before we continue with the rest of the code, we'll have to first learn about the exponent operator, which we are using it over here. So the exponent operator is basically a useful math operator you need to know to understand the affine cipher hacker program. Now, besides the basic plus, minus, multiplication, division or the double division operator, we have the exponent operator, which is double multiplication. Now the exponent operator raises a number to the power of another number. For example, 2 to the power of 5 would be looking something like, we just put this in the comment part, say 2 exponent operator 5. Now this is equivalent to 2 multiplied by itself 5 times. That is, we can say 2 into 2 into 2 into 2 into 2. Now both expressions evaluate to an integer value, which is 32. For example, if you want to just check this, we go back to the interactive shell and type here, say 5 exponent to 2, it's 25, 2, 5 comes to 32, say 123, 10 comes to a particular number. So the expression 5 into 2 evaluates 25 because 5 multiplied by itself is equivalent to 25. Likewise, 2 double multiplied by 5 returns 32 because 2 multiplied by itself 5 times evaluates to 32. So let's return to the source code now and see what the double exponential operator does in the program. So if we go back to our program now, here you can see we are using for say key str in the range len of the affine cipher demo.symbol str double multiplied by 2. Okay, so in this, if you know that there are almost length of the affine cipher demo.symbol str is possible integers for a key A1, and the length of affine cipher demo.symbol str returns as a possible integer for key B1. Now to get the entire range of the possible keys, we multiply these values together. Because we are multiplying the same value by itself, we can use the double exponential operator in expression len in bracket affine cipher demo.symbol double multiplied 2. Now after that, we call the get key part function over here, if you look at, and that we have used in our affine cipher demo. Now to split a single integer key into 2 integers. So in this example, we are using a function to get key A1 part of key via testing. Now recall that the return value of this function call is a tuple of 2 integers, one for key A1 and one for key B1. So here then we are storing the value of the tuple's first integer in key A1 by placing it, that is 0, which is the first value, not both the values. Okay. So for example, if we say affine cipher demo dot get key part str in bracket key str 0, it evaluates to the tuple of the index say 42, 22, 0, which is evaluating to 42, the value of the index 0. So this just gets the key A1 part of the return value and stores that in the variable key A1. And key B1 part is ignored because we don't need key B1 to calculate whether A1 is valid. Now, for the affine cipher, and if it is not, the program continues to the next key to try off. Now, to understand how the execution moves back to the start of the loop, you need to learn about the continue statement. So coming to the continue statement, which is basically using the continue keyword by itself, and it takes no parameter. We use a continue statement inside a while or a for loop, and when a continue statement executes, the program execution immediately jumps to the start of the loop for the next iteration. Now, this also happens when the program execution reaches the end of the loop's block. But a continue statement makes the program execution jump back to the start of the loop before it reaches the end of the loop. Now, look at more about this continue statement. Let's go back here in the interactive shell, and here we would create, say, for I1 in the range, say 3. Okay, here we are saying print command for I1. We are giving here a print, say, Python. So here we get 0 Python, 1 Python, 2 Python. Now in this case, the for loop loops through the range object, and the value in I1 becomes each integer from 0 but not including 3. So on each iteration, it will print Python function calls displays Python on the screen. Now contrast that for a loop with the next example which we will see, except it has a continue statement before the print. So over here, we would write down again, say for I1 in range 3 remains same, print I1. Here we say continue, then we give print, say, Python. Okay, and now we end it. So now we get just 0, 1 and 2 printed. Notice that Python never gets printed because the continue statement causes the program execution to jump back to the start of the for loop for the next iteration, and the execution never reaches the print Python line. The continue statement is often placed inside an if statements block so that the execution continues at the beginning of the loop under a certain condition. Now let us return to our code and see how it uses the continue statement to skip execution depending on the key used. So if we go back to our hack demo, in the source code, you have seen that we are using the GCD function in the CryptoMath1 module to determine whether key A1 is relatively prime to the symbol set. Now recall that two numbers are relatively prime if their GCD is 1. So if key A1 and the symbol set size are not relatively prime, the condition on this particular line is true and the continue statement executes. Now this causes the program execution to jump back to the start of the loop for the next iteration. So as a result of this, the program skips the call to the decrypt message str function if the key is invalid and continues to try another key until it finds the right one. Now when the program finds the right key, the message is decrypted by calling the decrypt message str with the key on the given line over here, where we are passing the key and the message. Okay. Now if silent mode was set to false, the tried key message is printed on the screen, but if it was set to true, print call is skipped. Next we use the isEnglish function over here and we check from our file, that is check English module, to check whether the decrypted message is recognized as English. So if a wrong decryption key was used, the decrypted message would look like random characters and the isEnglish check would return false. But if the decrypted message is recognized as readable English, the program displays it to the user. So we are displaying a snippet of the decrypted message that is recognized as English, because isEnglish check function might mistakenly identify text as English, even though it hasn't found the correct key. So if the user decides that there is indeed the correct decryption, they can type D or they can press enter. So we are giving those options over here for the user. Otherwise, the user just press enter to return to the blank screen or string from the input call. And the hacker find again continues trying more keys. Now from the indentation of the beginning, we can see that we have executed the for loop which has completed over here. When we use this return statement, till this the for loop is still continuing. So the for loop finishes and reaches this return line, then it has gone through every possible decryption key without finding the correct one. So at this point, the hacker find function returns the none value to this signal that it was unsuccessful at hacking the ciphertext. Now, if the program had found the correct key, execution would have previously returned from the function and never reached till this return statement over here. Now, after this return statement, what are we doing is, as normal, we are running the program with a special __ name _ variable that will be set to the string main instead of the program name. So in this case, we call the main function. So that is how we conclude the affine cipher hacking program. Thank you very much. Now in this session, we would be looking at the simple substitution cipher. Now in the last session, we have learned that the affine cipher has about 1,000 possible keys, but that computers can still brute force through all of them easily. So we need a cipher that has so many possible keys that no computer can brute force through them all. So the simple substitution cipher is one such cipher that is effectively invulnerable to a brute force attack because it has enormous number of possible keys. Even if your computer could try 1 trillion key every second, it would still take 12 million years for it to try every one. So in this particular session, we would write a program to implement a simple substitution cipher and learn some useful Python functions and string methods as well. So topics covered in this particular session will be the sort list method, getting rid of the duplicate characters from a string, wrapper functions, and using isUpper and isLower string functions or methods. So moving on to how a simple substitution cipher works. Now to understand this, let us go to a blank Excel. Now to implement the simple substitution cipher, we basically choose a random letter to encrypt each letter of the alphabet and using each letter only once. Now the key for a simple substitution cipher is always a string of 26 letters of the alphabet in any random order. And if you look at it, there are basically 403, 291, 461, 126, 605, 635, 584. So many number of different keys available. Now there are so many different possible key ordering for a simple substitution, and this is a lot more keys. So more importantly, this number is so large that it is impossible to brute force it. Now let us try using a simple substitution cipher with paper and a pencil, like here we would be doing it on Excel. For example, say we'll encrypt a message, say Python hacking, for example. Now here we would be using certain keys. Now we would write down our alphabets and the corresponding keys under each alphabet. So say for example, we would write down here all the alphabets, say capital alphabets. So A, B, let's take it from this. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And let's make it small, for example, so that it is just viewed totally all together. We don't need to scroll it. And below this, we would be writing down their keys. Now say we would be using here keys as V, J, Z, B, G, N, F, E, P, L, I, T, M, X, say W, D, W, then say K, Q U C R Y A H S O. So every character again used just once. So if you see here, this every single character is having another substituted character for it, and these characters are also not repeating in it. So in that case, only if you see this M is substituted by M. So some characters might be same, but others are totally different. Now this combination of random character generations could be a very large number. So in this particular case, now to encrypt a message, we will find the plain text in the top row and we'll substitute the letter in the bottom row. So if we just write down it over here that we have, that is first is P. So P will take it. The encrypted will be say Y. Then it is W. Then we have Y. So Y having S. Then T is having C. H is having a substitution of E. O is having substitution of D. And N is having a substitution of X. Then we are having hacking. So H is having a substitution of E. A is having of V. Then C is having of Z. K is having a substitution of I. Similarly, N is X and G is F. So this is what would be your encrypted text would look like. So now, to decrypt the encrypted message, you will find the letter in the cipher text in the bottom row and you would replace it with the corresponding letter in the top row. So like for example here W, which will be replaced by P, so on and so forth. So unlike a Caesar cipher in which the bottom row shifts but remains in the alphabetical order, in a simple substitution cipher, bottom row is completely scrambled. So this results in far more possible keys, which is a huge advantage of using a simple substitution cipher. And now the disadvantage is that the key is a 26 characters long and more difficult to memorize. You may need to write down the key somewhere, but if you do so, make sure that no one else ever reads it. Okay, now let's come to a simple substitution cipher code. Okay, we'll go back to, let's close this. Okay, now in our Python shell, we would create a new file and we would enter the code in this file editor and then save it and execute it. Again, we will place this in the same folder where we have the paperclip.py module. So the first thing we will have to import over here is, let's say, paperclip, then we want sys and we want random. Okay, now we want letters str. Now here we are storing all letters in capital: C T E F G H I J K L M N P Q R S T U V W X Y Z. And now we are going to start with a definition for main, in which we are creating my message str is equal to, we are giving here some text, say this is Python hacking intermediate level course. We are doing, let's take it in triple quotes. Okay, we are doing a simple substitution cipher example wherein we are writing a dummy text to encrypt using some random characters. So let us write down this text which we want to encrypt it. Okay, now after writing this, the next thing is we would create my key str and give here the key value. Now we are using keys, it should be all 26 characters but in a different order. So let us take that order here. Say YUIS VKMN X P B D C R J T Q. We have not used Q, we have used O. Okay. Then let's take E G H and finally say Z. And then we are taking say my mode str variable, which is over here. We are putting the text as encrypt. If you want to decrypt it, you will have to set this over here to decrypt. Currently we are doing an encryption method. Okay. So here we check if your say now this we would be creating below the method that is say key is valid str. Okay, and we are going to pass here my key str as the parameter, and if this is valid then we say sys exit saying there is an error in the key or symbol set. Then the next thing we will have to check is your my mode str if it is equal to encrypt. Then we are creating a translated str variable which is equal to, we are calling the encrypt message str and passing my key str and my message str variables as parameters. Then we check else if my mode str is equal to not encrypt but decrypt. Then we say translated str is equal to decrypt message str in bracket say my key str and again let's pass my message str. Okay, so if it is not encrypt, you will check it for decrypt. If it is that, you will call the appropriate methods. Now these methods we would be creating later in the same program. So after this, let us give a print command. Say using the key, we print here using %s and the value of my key str. Then the next print command we give, here we say the %scd that is encrypted say message is, and we print here my mode str. So is it encrypt or is it decrypt? And we print here the value of translated str. Use the paperclip.copy method and copy the same text translated str, print a blank line and print a message say this message has been copied to the clipboard. That's just a way you're informing to the user. Now that is the end of our main function. Now we define the first function that we are using here, that is key is valid str, which is taking the key str as the parameter. And here we are having say key list str that's equal to list pass key str to it. And then we take say letters list str that's equal to of letters str. And then we use key list str dot sort and letters list str dot sort. Then we finally say return the key list str is equal to your letters list str. Okay, and after this return statement, we define the encrypt message here. Okay, and in this again we are going to pass the parameter. So now the parameter is say key str and message str. Then we just return the translated message. So again, this we would be creating below, in which we are passing the key str, the message str, and the text as encrypt. Similarly, we define decrypt message str, again passing here key str and message str, and here also we are using a return statement for translated message str, where we are passing the value of key str, message str, and decrypt as the text. Now let us see the definition of our translate message str, which is the main function, and get random keys also we would create it. So now after this both definition, we will have to define the translated message str method, which is taking key, message, and one more parameter mode str. And now here we are creating first the translated str variable, which is equal to blank. We are taking characters A1, which is equal to your letters str. We are taking characters B1, which is equal to your key str. And then we are checking if your mode str is equal to say decrypt. Then for decrypting, we are just using the same code as encrypting. We just need to swap where the keys and letter strings are used. Okay. So over here, we are just saying the chars A1, comma, chars B1 is equal to chars B1 and chars A1. So we are just swapping the values there. And then the next thing is we are looping through each symbol in the given message. So for that, we are using a for loop here, say sym in our message str. And for this, we are using if the symbol is in uppercase in your chars A1, then encrypt decrypt the symbol. So we take here the symbol index, that is equal to your chars A1 dot find the sym dot upper sym. Use the upper function there, and then check if your sym dot is upper. You say translated str plus is equal to, say take chars B1 index sym idx dot upper. And if this is not true, go for the else part and say here translated str plus is equal to chars B1 in bracket sym idx dot, use the lower method. Now come to the upper if else part here, and if symbols are not in letters, just add it. So you are just saying translated str plus is equal to sym. And finally, we are using a return statement, translated str to be returned back. That is the end of our translated message str method. Then we are defining another, that is get random key str. And this method, we are saying the key str is equal to the list in bracket the letters str, after which we are using a random dot shuffle. We are passing their key strs to be shuffle, and then we are saying return blank dot join the value of key str. Then we check if name is equal to main underscore, then you're calling the main method over here.
So now we would save this particular file, say in E drive. Okay, and let us save it by the name substitution cipher demo .py.
in the same folder. We are saving it, and now let us try and execute the module. Fine, it is double is equal to here. So again, let us save it and try to run this. Okay, there is an error in the key or the symbol set. Fine, let us check this. What is the error? Let's see if the key that we have taken is proper, and it should not be repeated. So let us just validate that key first. So here the key that we have taken is, say, LFWOAY. Then you have UISVKMN. Then you have XPBDCR. Then you have JTQEGHZ. So as far as we see, there is no characters repeating over here. So let us check what we have passed. Key is valid str. We have passed the my key over there, and when in this particular function, that is key is valid str, we are passing the key list str. That's equal to the list key str here, and letters list str is equal to the letters str that we have created, and the key list str we are sorting it, and this is also we are sorting. Then we are returning the key list str, which is equal to letters list str. Okay, so if this is coming as value over here, then we are giving a system.exit in that case. Now what are we supposed to do is, we have missed here, if not it is a valid key, then you are going to give an error. If it is valid, because this would, if it is returning this, it is a valid key. So if it is a valid key, then we are moving for encryption. So now if we try to execute this, we get the encrypted message here. Now we would copy down this message here and paste it or substitute that over here. So let's add it below, my message str, paste it here, and we would just comment this for the time being. Let's save this and let us execute. One more mistake we made. This is not encrypt, this is decrypt. Save it and run it. So this is how we are decrypting it. Got the same message that we had written there, right? So now let us understand the code that we have written here. First thing is, we are importing the paperclip, sys and random modules, and the letters str variable is set to a string of all the uppercase letters, which is the symbol set for a simple substitution cipher program. Then we have the main function, which is similar to the main function of cipher program also, in which we basically called when the program is run first, and it contains variable that stores the message str, key str and the mode str used for the program. Now the keys for a simple substitution cipher are easy to get wrong because they is fairly long and need to have every letter in the alphabet. So for example, it is easy to enter a key that is missing letter or a key that has the same letter twice, for example, and then check that if your key is valid function, make sure the key is usable by the encryption and decryption functions. So the function exits the program with an error message if the key is not valid. Now in this case, if this particular statement returns false, then the my key str contains an invalid key and the program is terminated. Although over here then we are checking whether the my mode str variable is set to encrypt or decrypt, and we are calling the given particular methods over here. The return value of this particular method would be a string which is encrypted or a decrypted message that is stored in your translated str variable. Now after that, we are copying the value over here using paperclip.copy method on the clipboard. So the encrypted or the decrypted message is printed to the screen and also copied to the clipboard. Okay. Now after that, next we will look at how the key is valid str function uses the sort method to test whether the key is valid. So first of all, we will understand what is the sort list method here. Now the list have a sort method that rearranges the list items into numerical or alphabetical order. And this ability to sort items in a list comes in handy when you have to check whether two lists contains the same items but don't list them in the same order. So in this particular program, a simple substitution key string value is valid only if it has each characters in the symbol set with no duplicate or missing letters. We can check whether a string value is a valid key by sorting it and checking whether it's equal to the sorted list or letters. But we can sort only list and not strings. Okay, we'll obtain list version of the string values by passing them to the list method. Then after sorting this list, we can compare the two to see whether or not they are equal. Now, although letters str is already in the alphabetical order, we will sort it because we'll expand it to contain other characters later on. So hence we are saying string key is passed on to the list method here, and the list value returned is stored in the variable named keyliststr. Then the letters constant that we have created is passed on again to the list method in the next line, which returns the list in again a sorted order, that is again in ABCD till Z. Now after this, we are doing here the list in the keyliststr and the letters list str are then sorted in the alphabetical order by calling the sort list method on them. Now note that similar to the append list method, sort list also modifies the list in the place and doesn't have a return value. So when sorted, the key list and the letter list str values should be the same, because key list str was simply the characters in letters str with an order scrambled. So when we check whether the values of key list str and letters list str are equal, the values are then, after checking it, they are basically return value is then passed on to the method there. So over here, in case if this returns true if they are equal and have no duplicates, but if your key list str and letters str doesn't match, the key is invalid and it is returned false. Now coming to the wrapper function. The encryption code and the decryption code in the program are almost identical, if you can see here. When you have two similar pieces of code, it's best to put them into a function and call it twice rather than enter the code twice. So not only does this save your time, but also more importantly, it avoids introducing bugs while copying and pasting the code. So it's also advantageous because that there is very small bug in every code and you have to only fix one bug at a time instead of looking it for multiple places. So this wrapper function helps you avoid having to enter duplicate code by wrapping the code of another function and returning the value the wrapped function returns. Often the wrapper function makes a slight change to the arguments, the return values of the wrapped function. Otherwise, there would be no need for wrapping because you could just call the function directly. Now, let's look at an example of using the wrapper function in our code and understand how they basically work. Now, in our case, we are having the functions encrypt message str and decrypt message str, which are written basically as a wrapper functions. Now, each of these wrapper functions call the method that is translated message str, which is wrapped function, and returns the value that particular translated message str returns. Now, we will look at this translated message str quite later in this session, but because both wrapper functions use the same function, we need to modify only one function instead of two functions, which is encrypt message str and decrypt. Now, with this wrapper functions, someone who imports a program that we have created and call a particular function named encrypt message str or decrypt message str, just as they can with all the other cipher programs, the wrapper functions have clear names and tell others who basically use the function that what do the function do without having to look at the code. So as a result, if we want to share our code, others can also use it more easily. And other programs can encrypt a message in various ciphers by importing the cipher programs and calling the encrypt message str functions, as we can do it like importing the program and saying that program name dot the encrypt message str. So naming consistency is helpful because it makes it easier for someone familiar with one of the cipher programs to use other cipher programs. For example, you can see that we can see the first parameter is always a key, so second parameter is always a message, which is the convention used for most of the cipher programs. So using a translated message str function instead of a separate encrypt or decrypt functions would be inconsistent with other programs. Now let us look at the code that we have given for translate message str function. Now the translated message str function is used for both the encryption and decryption part. Notice that the translated message str has a parameter for a key, message str, and also a third parameter named mode str. Now when we try calling translated message str, the call in the encrypt function passes an encrypt string to mode str. Similarly, from the decrypt function, it is passing the string decrypt for mode str. Now, this is how the translate message str knows whether it should encrypt it or decrypt the given message. So, the actual encryption process is simple. For each letters in the message parameter, function lookups that letter's index in your letters str and replaces that character with the letter at the same index in the key parameter. So decryption does the opposite. It looks up the index in keys and replaces the characters with the character at the same index in letters str. Now, instead of using letters and keys, the program uses a variables char A1 and char B1, which allows it to replace the letters in char A1 with letters at the same index in char B1. Being able to change which values are assigned to char A1 and B1 makes it easy for the program to switch between encrypting and decrypting. So here we are setting the characters in char A1 to characters in letters and then characters in B1 to the characters in the keys, if you can look over here. Now, keeping in mind that the code in this particular method always replaces the characters A1 with characters in the same index and B1. So when we swap the values, the code does the decryption process instead of the encryption process. And then the next line in the program finds the indexes to use the encryption and the decryption. Now we have a for loop here which sets the symbol or SYM variable to a character in the message str string on each iterations through the loop. And if the uppercase form of this symbol exists in char A1, then it finds the index of the uppercase form of the symbol in char A1 and symindex variable stores this index. Now we already know that the find method would never return minus because from the find method, it means that the argument could be found in the string. So because if the if statement guarantees that your symbol.upper exists in char A1, otherwise we won't have been executed. So in each encrypted or decrypted symbol to build the string that is returned by the translated message str function, but because the key and the letters are both only in uppercase, we'll need to check whether the original symbol in message was lower and then adjust the decrypted or the encrypted symbol to lowercase. Now for doing this, we have to learn two string methods, which is upper and is lower. So moving on to is upper and is lower string methods. These two methods check whether the string is in the uppercase or lowercase. Now more specifically, is upper string method returns true if both the conditions are met, that is string has at least one uppercase letter or string does not have any lowercase letters. And is lower string method returns true if both of the conditions are met, that is string has at least one lowercase or the string doesn't have any uppercase letters. So these non-letter characters in the string doesn't affect whether these methods return true or false. Although both the methods evaluate to false if only non-letter characters exist in the string. Now to check this, suppose we just go to the interactive shell here and we try to enter in this, say Python, then dot is upper. Press enter, we get it true. Or we enter, say Python hacking 123 dot is upper. Still we get it true. Or if we enter it in lowercase and check is lower, we get it true. Or if we say 123 dot is upper, this will be false. Or if we say just a blank and saying is lower, this is also false. So in this, the first example returns true, okay, because all the characters has at least, the text that we have written has at least one uppercase in it and no lowercase. The numbers in the string doesn't affect the evaluation. In the second one, we have checked for is lower, okay. Now this also returns true because the string Python has at least one lowercase letters in it and no uppercase. And now let's return to our code which we have written to see how to use the is upper or is lower string methods. So if we come over here, we have checking this is upper or is lower over in the for loop in the same way, right? Now in the program that we have written, we have used here is upper and is lower string methods to help ensure that the cases of the plain text are reflected in the cipher text. So here we are checking that we are checking if it is converting to upper over here first. Okay, and then we are checking if it is in upper, what are you supposed to do else? If it is not in upper, so it is in lowercase. So then what you are supposed to do? So over here we first check whether the symbol has an uppercase letter. If it does, concatenate the uppercase version of the characters at the char B1 to the translated str. So this results in the uppercase version of the key character corresponding to the uppercase input. Now if the symbol instead has a lowercase characters, then it concatenates the lowercase version of the characters from chars B1 to the translated text. Okay, so if it is upper, concatenate to upper. If it is in lower, concatenate to the lower one. So if the symbol is not a character in the symbol set, such as any number or a question mark or a comma, it would return false and would execute instead of executing this else part. So here it would just execute the next part of the statement. So if your symbols are not letters, then this means that we cannot encrypt or decrypt the character in the symbol. So we simply concatenate to the end of the translated str. Like over here we have done in this else part. Okay. So at the end, your translated message str function will return the value in the translated str variable which contains the encrypted or the decrypted message. Now let's look at the get random key function to generate a valid key for a simple substitution cipher. Now typing this particular method for a key that contains each letter of the alphabet can be difficult. To help this, we have this get random key str function which returns a valid key to users. Now it randomly scrambles the characters in the letters str constant. By doing, we are saying here random.shuffle the key str. Okay. Now to use this, you can just substitute, say this particular method name, that is get random key str, and you can substitute this over here in my key. So let us just comment this, and here we would again write down my key str is equal to, say, get random key str. Now let's check the output. Okay, so now if we execute this, see, it is generating some random key and that is a decrypted message used for it. So in this way, we can also execute this particular part. And after this execution, the last part that we have is checking that at the end of the program call main, if it is being run as a program instead of being imported as a module by another program. Hence, we conclude that our simple substitution cipher program is very much easy as compared to other cipher programs that we have done, because it is basically substituting just character by character with some different characters. Okay, so that is how we have created the program and understood how the program has been created.
Welcome to the next course, that is Python hacking training, the advanced level course. Now in this particular course, let us first look at what skill sets you must require to do the course. So you should have the beginner level and the intermediate level knowledge of Python hacking. Also, you should have the basic knowledge about Python, and you should have well-versed knowledge about programming. Okay, now after understanding this, let us see what are we going to learn at this advanced level course of Python hacking. So the first thing we would be learning is hacking a substitution cipher, then programming the beginner cipher, frequency analysis, coming to hacking beginner cipher, and programming a public key cipher. Now let's see who are our target students for this course. Any hacking professionals, also those who want to make their career in Python hacking. Now let us understand by the end of course what will be having our skill sets. So after the completing this course, you will have knowledge of different types of ciphers. You will have, or you will know how to program them also, and you would have hands-on experience in writing hacking programs. So all this looks very much interesting. So let's quickly start with our first session in Python hacking advanced level course. That's it from this introduction session. Thank you very much. Welcome to the first session in our Python hacking advanced level course. In this session, first we would write such a program to narrow down the list of potential decryption outputs to the right one. So topics covered in this session would be your word patterns, candidates, potential decryption letters, letter cipher mappings, regular expressions, sub-regex method.
So now let's come to first using the word patterns to decrypt. Now in brute force attack, we try each possible key to check whether it can decrypt the ciphertext. If the key is correct, decryption result in a readable English. But by analyzing the ciphertext first, we can reduce the number of possible keys to try and maybe even find a full or a partial key. So let's assume the original plain text consists mostly of words in an English dictionary file, like one we use in the earlier sessions. Although a ciphertext won't be made up of real English words, it will still contain group of letters broken up by spaces, just like words in a regular sentence. So we'll call this as a cipher words, for example, and in a substitution cipher, every letter of the alphabet has exactly one unique corresponding encryption letter. Now we will call that letter in the ciphertext as a cipher letters. Now because each plain text letters can encrypt to only one cipher letter, we are not encrypting spaces in this version. The plain text and ciphertext will share the same word patterns. Now for example, say we have a plain text like, say, Mississippi and spill. Now the corresponding ciphertext would look something like, say, RJ, BBJ, BBJ, XXJ, BX space BXJHH, for example. Now the number of letters in the first word of the plain text and the first cipher word are same. If you look at this, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have made here, I think, a mistake. This one. It's like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the same is true for the second plain text also. So if you look at this, it has 1, 2, 3, 4, 5, and this one also has 5. So the plain text and the ciphertext share the same pattern of letters and spaces. Also notice that letters that repeat in the plain text repeat the same number of times in the same place in ciphertext also. Like here, if we are repeating SS, here BB is repeating. Here if we are repeating PP, here XX is repeating. Here we are repeating LL, so here HH is repeating. So we would therefore assume that a cipher word corresponds to a word in the English dictionary file and that word patterns would match. Then we can find which word in the dictionary the cipher word decrypts to. We can figure out the decryption of each cipher letter in that word. And if we figure out enough cipher letter decryption using this technique, we may be able to decrypt the entire message. So now let's come to understand the finding word patterns. Now let's examine the word pattern of the cipher word, for example, say HGHHU, for example. Now you can see that the cipher word has certain characteristics which the original plain text word must share. Both words must have the following things in common. One is they should be 5 letters long. First, third and fourth letters should be same because here we have H, 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 right? They should have exactly 3 different letters. That is, H should be replaced by 1 letter, G should be replaced by 1 letter, U should be replaced by 1 letter. So now in this particular pattern, you may have words, for example, like say puppy, or you may have, again here you can see first are repeating, third and fourth, then there are only 3 characters there, P, U and Y, and they are arranged also in the same pattern. So P for the first, say third and fourth, and U for the second and Y for the fifth one. Similarly, you may have another word like say mommy, or for that case Bobby, or say nanny. With these all fits in the same pattern. So these words along with others in the English dictionary that matches the criteria are all the possible decryptions for this particular word. Now to represent a word pattern in a way that program can understand, we'll make each pattern into a set of numbers separated by periods, that is dot, that indicates the pattern of the letters. Now creating word pattern is easy. First letter gets a number 0 and the first occurrence of each different letter thereafter gets the next number. So for example, the word pattern, say over here, if we write down a word, say cat, would be say 0.1.2. So over here, and same way, say if we have higher version, say for example classification, which is a longer word, here we may have something like 0, 1, 2, 3, 4, 5. Then again let's have here say 4, 0, 2, 6, 4, 7, 8. Now in this case, in a simple substitution cipher, no matter which key is used to encrypt, a plain text word and its cipher word always have the same word pattern. So the word pattern for ciphertext over here that we have used will come to something like 0, then 1, then again 0, 0, and next is 2. Which means the word pattern for a plain text corresponding to this will be equal to also 0.1.0.0.2. Now moving to finding the potential decryption letters. Now to decrypt this word, we need to find all the words in an English dictionary whose word pattern is this that we have described. So we'll call the plain text word that have the same word pattern as the cipher words the candidates in this particular session, just to understand. So here's a list of all the candidates available for this, in which we have calculated this puppy, mommy, Bobby and Nanny. Now using the word patterns, we can guess which plain text letter ciphered letters might decrypt to, which we'll call as a potential decryption letters. Now to crack a message encrypted with a simple substitution cipher, we need to find all the potential decryption letters first of each word in the message and determine the actual decryption letter through the process of elimination. Now for example, say if we create here something like so let's go to here, and here we write down say our cipher letters here, and below we would write down the potential decryption letters, and here we would take first say H, G, H, H, U, and here we would take it the other words that we have created, that is P, P, Y, say M, O, M, M, Y, then let's take B, O, B, B, Y, and N, A, N, N, Y. So over here, if you look at it, H has a potential decryption letter of P, M, B or N. Similarly, G has a potential decryption letters U, O, A, or U has a potential decryption letters Y. So all the other cipher letters besides this have no potential decryption letters in this particular example, right? So a cipher letter mapping shows all the letters of the alphabet and their potential decryption letters. So as we start to gather encrypted messages, we'll find potential decryption letters for every letter in the alphabet. But because only cipher letters, that is H, G and U, are part of our example, we don't have potential decryption letters for other cipher letters. So notice that U has only two potential decryption, only one over here. That is why, because there are no overlaps between the candidates, many of which ends with the letter Y itself. So over here, we can use a dictionary value to represent a cipher letter mapping as follow. For example, we may use here, say for say G in single quotes, we can use it something like it should be U, then O, A, for example. Or for that case, if we take H, H can be equal to say P, then M, B, N. Similarly, we can write down say U, which should be equal to either Y. Now this dictionary has 26 key value pair, that is apart from G, H and U, you will also have from A, B, C, D till Z, and all the others will be basically blank. You may have say for example A, which is equal to blank, or say let's give comma B, B also has blank, then say comma C also has blank, let's give a comma D also has blank, like this for all the others apart from G, H and U. So it shows the potential decryption letters for the key G, H and U, and all the others will have like this blank as we have represented here. So because we can reduce the number of potential decryption letters for a cipher letter to just one letter by cross-referencing the cipher letter mappings to other encrypted words, we can find what that cipher letter decrypts to. Even if we can't solve all 26 cipher letters, we might be able to hack most of the cipher letter mappings to decrypt most of the cipher text. So now that we have covered some part of the basic concepts and some terminologies which we would be using in this session, let's look at the steps involved in hacking this process. So let's have an overview of the hacking process now. So the hacking a simple substitution cipher is pretty easy using the word patterns. We can summarize the major steps of hacking process as: number 1, find the word pattern for each cipher word in a ciphertext. Number 2, find the English word candidates that each cipher word would decrypt to. Number 3, create a dictionary showing potential decryption letters for each cipher letter to act as a cipher letter mapping for each cipher word. Number 4, combine the cipher letter mappings into a single mapping, which we will call, say for example, as intersected mappings. Number 5, remove any solved cipher letters from the combined patterns or mappings. And finally, number 6, decrypt the ciphertext with the solved cipher letters. Now, the more cipher words in a ciphertext, the more likely it is for mappings to overlap with one another, and the fewer the potential decryption letters for each ciphertext. This means that in a simple substitution cipher, say one line of text, say the Python hacking advanced level course, this is hacking a simple substitution cipher. This whole particular line, before dividing into the source code, we'll have to look at how we can make the first two steps of hacking process easier. So again, in this, we would be using the dictionary file used in the earlier session to get the word pattern for every word in the dictionary file and then sort them in the list. So coming to our word pattern module. Now, to calculate the word pattern for every word in the dictionary.txt file which we have, we would create another file which will check the or make the word patterns.python file, and then we would place that particular file which will have a program, say get word pattern for example, and it would return the number of word patterns which we are passing it as the parameter. Now, after creating this file, then only we can go ahead for creating hacking example for a simple substitution cipher. So in the next session, we would see creating of the make word pattern file, and then we would use that file along with the dictionary files which we have from the earlier sessions, and then we would create our hacking example for simple substitution cipher. So that's it from this session. Now welcome to the next session. In this, now first we would be creating the word patterns.py file. Now for that, we are creating a file. After executing that file, we would get the word patterns.py file created, and that would be based on the words in our dictionary file, that is dictionary.txt. Okay, so we'll have to place this file that we would be creating in the folder where you have dictionary.txt file. Okay, so first thing is we would go for a file and say new file, and here we would import, say pprint. Now we are going to define here, say get word pattern str, pass their word as the parameter. Now here this would basically return a string of pattern form of the given word. For example, like if you have say 0.1.2.3.4.1.2.3.5.6, so it could be something like a dustbuster, something like that. Okay, so if we say word is equal to, say word dot convert to upper, then we create here, say next num1, that is equal to 0. Okay, then we create letters num1, that is also equal to blank, and say word pattern 1, that is also equal to blank. Okay, then we run a for loop saying, say now we are creating here, say letter 1 in word that we have created the object of. Okay, and we check if our letter 1 is not in the letter num1, then what are you supposed to do? So here we are saying letter num1 at the index of letter 1 is equal to convert to str. Now we take here the value of next num, okay, or next num1, for example. So now what are we doing here? Next num n is capital. Okay, so after this, what are we trying to do? Then we say the value of next num1 plus is equal to 1. And after that, below the if, we say the word pattern1 dot, we are appending in that the letter num1 in the bracket of, or in the index of letter 1. Okay, after we have completed with this, then the last thing, we give here a return statement saying dot, then we join in that the value of word pattern 1. Okay, now once we have completed this, we would define the main method below, and in this we are creating, say, all patterns1 is equal to blank, and we create here, say, fo1 or file object 1. Now we are opening here the file that we have, or in which folder we are supposed to save this, that is dictionary.txt file, because this file we would open it and then we would split this file and get the pattern of each string in the word list. So over here, after giving that file reference in the file object, we say the word list1 object is equal to the file object dot, we say read it and split the file wherever you find a new line. So that new line would split one line into your particular file. After you have done that, don't forget to close the file object. And then we run a for loop for, say, word 1 in your word list 1. Okay, and in this for loop, we say we get the pattern for each string in this. So we create here pattern str, that's equal to, say, get word pattern str. We are calling this method, and here we are passing the object, that is, say, word 1. Now after we have passed the reference, we check here if our pattern, now the one which we are creating over here, that's pattern str, and we say not in, say, all. Now here all patterns we have created here above. Okay, all patterns 1. So if it is not in the given range over here, then we need to add it into the all pattern. So then we say all patterns 1 at the index of pattern str, and that is equal to your word 1. Okay, then we go on for the else part here, and here we say all patterns in the index of pattern str dot, now we are appending there the value of word 1. Okay, so if it is not in that, if it is doesn't equal to that, then you are adding or appending the values in this. So in this particular code, that writes this code that we have written into another file that we would be creating now below, that is word patterns.py file, which will contain one every or very large assignment statements. So now for creating that particular file, let's go back here below the for loop of word 1, and here we are creating another file object, say fo1. Again we are giving here to open, but now we are giving a file name, that is, say, word patterns1.py. Now this file we are giving, and this should be open for write mode, which means we now want to write some data into this given particular file. And what are we supposed to write? We are saying fo1.write, and here we are giving, say, all patterns is equal to, this text would be printed, and then we say fo1.write, we give pprint object in p format. Okay, and here we print the value of all patterns 1 that we already have created. So this data would be then written to the file. And finally we say fo1.close. You don't have to forget to close the file object anyways. Once you close that, then we use name is equal to underscore main underscore. Okay, and then we call the main method. Okay, so now this particular file we would be saving it as, say, make word pattern 1.py. So in E drive, we have the folder Python hacking advanced level. In that, we are saving this file. Okay. And now once we have saved this, we have to also copy the dictionary.txt file. Okay. So for that, okay, we have simply copy pasted it from our intermediate level wherein we have already created this file, and we have just pasted it in our advanced level course that we have, the folder that we have created. Now what we are supposed to do is we are supposed to execute this module, and once we execute this module, then we would get a file created. If you look in your folder, you see this word patterns.py file getting created. Now for example, if you want to open up this and check, so, okay, let's go here, say word patterns. You can see this. A lot number of data has been created for this, and this is how the pattern we are getting and the data that we are getting from the dictionary.txt file. Okay, so now we would be using this file, that is word pattern file that we have already created using make word pattern file. So this file, dictionary file would be required, and our paperclip file would be required. Also, the simple substitution file that we had created earlier in the intermediate level course, even that would be required. So using that, we would now create another program for hacking a simple substitution cipher. Okay, so here if you can see, we have also pasted the substitution cipher demo that we had created in the intermediate level last session. Okay, now after doing all these things, now we would proceed ahead for creating a hacker program for a simple substitution cipher. So let's go back to our Python shell, and we will create a new file here. And the first thing we would create is import os, re, copy, then our paperclip, then the folder or the file name that we have is substitution cipher demo. Okay, so we would create that. Okay, so substitution cipher demo. Then we want to create word patterns 1, and we also want to import, that is our make word pattern 1. Okay, welcome to the first session in our Python hacking advanced level course. In this session, first we would write such a program to narrow down the list of potential decryption outputs to the right one. So topics covered in this session would be your word patterns, candidates, potential decryption letters, letter cipher mappings, regular expressions, sub-regex method. So now let's come to first using the word patterns to decrypt. Now in brute force attack, we try each possible key to check whether it can decrypt the ciphertext. If the key is correct, decryption result in a readable English. But by analyzing the ciphertext first, we can reduce the number of possible keys to try and maybe even find a full or a partial key. So let's assume the original plain text consists mostly of words in an English dictionary file, like one we use in the earlier sessions. Although a ciphertext won't be made up of real English words, it will still contain group of letters broken up by spaces, just like words in a regular sentence. So we'll call this as a cipher words, for example, and in a substitution cipher, every letter of the alphabet has exactly one unique corresponding encryption letter. Now we will call that letter in the ciphertext as a cipher letters. Now because each plain text letters can encrypt to only one cipher letter, we are not encrypting spaces in this version. The plain text and ciphertext will share the same word patterns. Now for example, say we have a plain text like, say, Mississippi and spill. Now the corresponding ciphertext would look something like, say, RJ, BBJ, BBJ, XXJ, BX space BXJHH, for example. Now the number of letters in the first word of the plain text and the first cipher word are same. If you look at this, It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have made here, I think, a mistake. This one. It's like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, the same is true for the second plain text also. So if you look at this, it has 1, 2, 3, 4, 5. And this one also has 5. So the plain text and the ciphertext share the same pattern of letters and spaces. Also notice that letters that repeat in the plain text repeat the same number of times in the same place in ciphertext also. Like here, if we are repeating SS, here BB is repeating. Here if we are repeating PP, here XX is repeating. Here we are repeating LL, so here HH is repeating. So we would therefore assume that a cipher word corresponds to a word in the English dictionary file and that word patterns would match. Then we can find which word in the dictionary the cipher word decrypts to. We can figure out the decryption of each cipher letter in that word. And if we figure out enough cipher letter decryption using this technique, we may be able to decrypt the entire message. So now let's come to understand the finding word patterns. Now let's examine the word pattern of the cipher word, for example, say H, G, H, H, U, for example. Now you can see that the cipher word has certain characteristics, which the original plain text word must share. Both words must have the following things in common. One is they should be 5 letters long. First, third and fourth letters should be same because here we have H, 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 right? They should have exactly 3 different letters. That is, H should be replaced by 1 letter, G should be replaced by 1 letter, U should be replaced by 1 letter. So now in this particular pattern, you may have words, for example, like say puppy, or you may have, again here you can see first are repeating, third and fourth, then there are only 3 characters there, P, U and Y, and they are arranged also in the same pattern. So P for the first, say third and fourth, and U for the second and Y for the fifth one. Similarly, you may have another word like say mommy, or for that case Bobby, or say nanny. With these all fits in the same pattern. So these words along with others in the English dictionary that matches the criteria are all the possible decryptions for this particular word. Now to represent a word pattern in a way that program can understand, we'll make each pattern into a set of numbers separated by periods, that is dot, that indicates the pattern of the letters. Now creating word pattern is easy. First letter gets a number 0 and the first occurrence of each different letter thereafter gets the next number. So for example, the word pattern, say over here, if we write down a word, say cat, would be say 0.1.2. So over here, and same way, say if we have higher version, say for example, classification, which is a longer word, here we may have something like 0, 1, 2, 3, 4, 5. Then again, let's have here say 4, 0, 2, 6, 4, 7, 8. Now in this case, in a simple substitution cipher, no matter which key is used to encrypt a plain text word and its cipher word, always have the same word pattern. So the word pattern for ciphertext over here that we have used will come to something like 0, then 1, then again 0, 0, and next is 2. Which means the word pattern for a plain text corresponding to this will be equal to also 0.1.0.0.2. Now moving to finding the potential decryption letters. Now to decrypt this word, we need to find all the words in an English dictionary whose word pattern is this that we have described. So we'll call the plain text word that have the same word pattern as the cipher words the candidates in this particular session, just to understand. So here's a list of all the candidates available for this, in which we have calculated this puppy, mommy, Bobby and nanny. Now using the word patterns, we can guess which plain text letter ciphered letters might decrypt to, which we'll call as a potential decryption letters. Now to crack a message encrypted with a simple substitution cipher, we need to find all the potential decryption letters first of each word in the message and determine the actual decryption letter through the process of elimination. So now after this, we are supposed to define another function, that is say add letters to mapping. Now E is small. Okay, mapping 1, and in this we are passing say letter mapping 1, say cipher word 1 and candidate 1. All these parameters we are passing here, and in this the letter mapping 1 parameter takes a dictionary value that basically stores the cipher letter 1 mapping and which is copied by the function. So the cipher word 1 parameter is a string value of the cipher text word, and the candidate 1 parameter is a possible English word that cipher word 1 would decrypt to. So this particular function adds the letters in the candidate 1 as potential decryption letters for our cipher letters 1 in the cipher letter mapping. So over here we are saying for say I1 in the range, and we are giving here the range of the length of cipher word 1. Okay, and in this we are checking if the candidate 1 at the index of I1, if it is not in the letter mapping 1 in the bracket or the object of say cipher 1 or word 1 at the index of I1. Okay, so if that is not in the mapping of this, then let's close this and colon. Now in this we are giving that letter mapping 1 in the index of cipher word 1 I1. Now in this we are using append, and we are appending the value of candidate 1 index I1. Okay, fine. Now after definition for this particular function, let us go back here and we define another method, that is say intersect mapping or mappings 1, and here we are passing say map A1 and map B1 as 2 parameters. Now here to intersect the two maps, we are creating a blank map and then add only a potential decryption letters if they exist in both the maps. So in this we are creating say intersected mapping 1, that's equal to, we have another object that we would be creating, say get blank cipher letter. Now that we have already created above mapping 1, so we are calling that here getting all the blank cipher letter mappings from this particular function, storing it in the intersect or intersected mapping 1 object, and then we run a loop saying for letter 1 in letters str, the constant that we have created on the first line. So an empty list means any letters is possible. So in this case just copy other map entirely. So in this case we are saying if our map A1 in the index of letter 1 is equal to blank, then open the object and we are saying the intersected mapping 1 index of letter 1. We are using the copy method, copy dot deep copy, and we are giving here object map B1 index of letter 1. Now here we also will have the else if part, wherein we are checking if map B1 at the index of letter 1, if that is equal to blank. If it is, then we say here say intersected mapping 1 index of letter 1, and now we are using copy dot deep copy method and copying the object of A1 at the index of letter 1 in this. Okay, now if both of it is false, then we are going to the else part, and if a letter in map A1 at the index of letter is existing in B1 at the index of letter 1, then add that letter to the intersected mappings of letter 1. So here we are checking for say mapped letter 1 in map A1 index letter 1. Then in this you check if our mapped letter 1 is in also map B1 at the index of letter 1. If both the conditions are true, then you are saying in the intersected mapping 1 at the index of letter 1, we are saying dot append the value of mapped letter 1. Okay, and after you have done this, do not forget to use a return statement and say return the intersected mapping 1. And once you have returned the particular value, then the method ends and we come to another method definition, that is removing the solved letters from mapping. So now let us define here the function, that is say remove solved letters from mapping 1, and it will take the object as letter mapping 1. Once you have passed the object, now in this, the cipher letters in the mapping that map to only one letter are solved and can be removed from other letters. So for example, say if A maps to potential letters M and N and B maps to N, then we know that B must be mapped to N only, right? So we can then remove N from the list of what A could map to. So then A maps to M only. So note that now that A maps to only one letter, we can remove M from the list of letters for every other letter. So this is why there is a loop which will keep on reducing the maps in this particular method that we would be creating. Okay. Now we would be creating here variable, say loop again 1, which is initially equal to true. Then we say while the loop again 1, which means while it is true, we are assuming that we will not loop again. So we are giving here say loop again is equal to false. Then the solved letters we will be basically the list of your uppercase letters that have one and only one possible mapping to the letter mappings. So here we are creating say solved letters that's equal to blank initially. We say while the cipher letters is equal to or in the letters str. Then we are saying if the length of your letter mapping 1 at the index of your cipher letter 1 and 0. So we are giving there two indexes, that is the row and the column. And in this, one thing, we made a mistake here. We are first checking there for say cipher letter in letters. Then we check if the letter mapping 1, at the index of your cipher letter, if that is equal to 1, then we are saying say the solved letters 1 dot, we are using here append and giving say letter mapping 1. Now we are giving two indexes, one is cipher letter 1, another is 0. Now after this, if a letter is solved, then it cannot possibly be a potential decryption letter for a different cipher text. So we should remove it from those other from the list. So now again we create a for loop here saying say for the cipher letter 1 in letters str. We take a variable say s1 in your solved letters 1, and we would run this for loop and check if the length of letter mapping 1 at the index of cipher letter 1, and if this is not equal to 1 and your s1 in the letter mapping 1 at the index of cipher letter 1, then we open up this bracket, and now in this we create say the letter mapping 1 at the index of cipher letter 1 dot, now we use to remove the value of s1. And then again we check here if the length of your letter mapping 1 at the index of cipher letter 1 Okay, if it is equal to 1, again here a new letter is now solved, so the loop again. So now here we are again giving, say, loop again equal to true. Okay, and finally at the end we are saying to return the value of letter mapping 1. Now we move on to our main definition, that is hack simple sub. Now we have given here hack simple sub 1. Okay, so S is small. Okay, and here we are going to pass the message str variable, and now here we create, say, intersected map 1, that's equal to, we are saying the get blank, let's remove this, get blank cipher letter mapping. So we are calling that particular method here. Okay, after we have called and we have stored the value there, then we create the cipher word list str, and that is equal to, say, non. Now let us copy down this non letters or space pattern. Okay, so we are putting that reference there, and in this we are giving blank, then a comma, say message str dot convert to upper dot, we use split method. Okay, after this we create a for loop for the cipher word 1 in our cipher word list that we have created, and that is our, if we just look at it now, cipher letter list str. Okay, so cipher word list str, and in this we open up the for loop and we get a new cipher letter mapping for each cipher text word. For that we say a candidate map str, that's equal to, we call here again the get blank cipher letter mapping 1. Okay, and the word pattern we create, say word pattern str, that's equal to, we say make the word pattern. So let's use that over here. Okay, so now here we can just check out in this make word pattern. If we just open it in Notepad, the method that we are creating is get word pattern str. Okay, and the file name is make word pattern 1. So now here we'll have to write down, say make word pattern 1 dot, we have the method that is get word pattern str. So that is get word pattern str, and in this we are passing the cipher word 1. Okay, hence we need the files to be imported. Then we check if the word pattern str is not in your, now we want another file, so let us close this and go for word pattern file. Let's open this in Notepad. Okay, so if it is not there in word patterns 1, so let's write down not in word patterns 1 dot all patterns. So here we have this all patterns created, so we are using that, and for this the file name is word patterns 1. Okay, so if it is not there in this, we give a colon and we just give there the continue statement. This word was not in our dictionary, so we continue with the next part of it. Okay, and after this, okay, after this continue, we move on to the next and we say for, say, candidate 1, okay, in your word pattern 1 dot all patterns in the index of, take here word pattern str. Okay, in this we are saying add letters to mapping. Now here we have creating add letters to mapping 1. So let us copy down the same concept here. Okay, in this we are passing the candidate 1 or candidate map 1, then the cipher word 1, and we are having now it's candidate map str in this case. Then we have the cipher word 1 and we have the candidate 1 parameter. So we pass all this and we execute the add letters to mapping method. Okay, so after this we continue for the next part, wherein we say intersect the new mapping with the existing intersected mapping. So here we create intersected map 1, that's equal to, we say intersect mappings 1, and here we pass the object of intersected map 1, okay, and the candidate map str, okay, and then finally we give here a return statement and we say return the, now we are calling here remove the solved letters from mapping. So we are returning that, passing there the intersected map 1. Okay, now we'll continue in the next session more on this program, wherein we have to also write down the method for decrypt with the cipher letter mappings and then give our main method execution. Okay, so we will continue this in the next session. Thank you very much. So now here we would create the last function required for this file, and that is we would define the decrypt with cipher letter mapping, in which we would pass the ciphertext 1 and the letter mapping 1 object. Now in this method we will return a string of the ciphertext decrypted with the letter mappings with any ambiguous decrypted letters replaced with an underscore sign. So first we'll create a simple sub key from the letter mappings mapping. So we say here key str at the index of is equal to index, we are giving here x as the value, multiplied by the length of our letters str. Okay, and then we run a loop saying for the cipher letter 1 in your letters str. Okay, here we are checking if the length of your letter mapping 1 at the index of your cipher letter 1, and if that is equal to 1, then if there is only one letter, then you have to add it to the key directly. So then we create here say the key idx, and that's equal to say letters str dot use the find method, and we use here the letter mapping 1 index of cipher letter 1 and 0. Okay, now after we have given the value in the key idx, we say the key str that we have created at the index of key idx, okay, and that is equal to your cipher letter 1. Then we move on with the else part for this if, and we say the cipher text 1 parameter is equal to your cipher text 1 dot, we are replacing the cipher letter 1 dot lower comma, give there an underscore sign. Similarly, we are saying the cipher text 1 is equal to the cipher text 1 dot replace, again say cipher letter 1 dot upper comma, again underscore sign. Okay, and then here we say key str is equal to blank dot join the value of key str. Okay, and with the key we have created, we would decrypt the ciphertext. So we are saying here return. Now here we would be creating or calling the decrypt method. So here we are calling the substitution cipher demo dot the decrypt message str and passing there the key str and the cipher text 1. Okay, and so this value we would be returning back whenever we are calling this decrypt with cipher letter mapping, and this is the method that we are calling it here. So let's keep the same name here also. Okay, and this is not just completed. Here the last part, that if underscore name underscore is equal to, give here main underscore single quotes and then you call the main method. Okay, so now we will save this particular file. Okay, now let's give here a name, say hack simple sub cipher.py, and let us save it in our advanced level course. Okay, so we would save this, and when after completing the save of this particular value, now we have already given there the text which we want to decrypt it. Let us try and execute this and see the output. Okay, paperclip is not there. Fine. Is it there in our folder? Let us check it. No. So we'll have to copy down that. Let us do that. Okay, we have copied the paperclip from our intermediate level course. So now again, let us try to run this. Okay, line number 97. Let us check that. Edit. Go to line 97. Okay. What are we checking here at the end of it? We are checking if underscore underscore name and then is equal to, double is equal to, we give there main and we are calling there the main method. Okay, it is looking fine. Let's see another that is on line number 12. Okay, so let's go to line 12. Okay, over here now that is we are saying hack simple sub 1. So have we created hack simple sub 1 here? Yes, and it is having the same method or the same parameter that we are passing, that is message str. Okay, so let us just try to substitute the name. Okay, and then we say in main. Okay, where in main are we trying to call this? Over here. Okay, that's not an issue. Let's try and execute this again. Okay, let's see line number 69. Okay, fine. Let us just try it out. Oh, here we have made a mistake. If we have the hack simple sub there where we are calling it, and in this we are creating this. Okay, our mistake was over here. It was supposed to be /s1. Okay, so now if we try to execute this, we get some part of the message decrypted. Not all, but at least to some extent we are able to decrypt the given message of a substitution cipher. So wherever it is not able to, we are getting there the values of underscore or so on. Okay, now let us explore the source code in detail that we have written here. Okay, now the first few lines of the simple substitution hacking program is basically importing certain different modules. Now here we have imported more modules as compared to any other program so far. So we have here the letters str, which is a constant global variable, okay, which stores the symbol set given, which consists of all the uppercase characters or alphabets. Okay, now the RE module is basically your regular expression module, which allows for a sophisticated string manipulation using any regular expression. Now let us have a look at how the regular expression work. Okay, so a regular expression are basically strings that define a specific pattern that matches certain string. Now for example, if we say apostrophe A to Z /S1, okay, is a regular expression that tell Python to find any characters that is not in the uppercase from A to Z, or a white space character like a space, a tab, or a new line character. Now after that, the re.compile function basically creates a regular expression pattern object, which is abbreviated also as regex object or a pattern object, that the remodule can use. Okay, now we would use this object to remove any non-letter characters from the function when we are using hack simple sub. Okay, now let's look at setting up our main function. So if we move below, we are defining here the main function. Okay, where as in the previous hacking programs that we have done, the main function stores your ciphertext in the message str variable, and that is basically passes the variable to your hack simple sub1 method or the function which we would be creating. So instead of returning the decrypted message or none if unavailable to decrypt, we have hack simple sub1 which returns an intersected cipher letter mapping with the decrypted letters removed. Okay, now this intersected cipher letter mappings then gets passed to your decrypt with cipher letter mappings. Now that is helpful for decrypting the ciphertext stored in the message into a readable format. So as you can see, we are having a more detail of decrypting this in the coming session. Okay, now the cipher letter mapping that stores your letter mapping is a dictionary value which has 26 uppercase characters, if you can see here, and that is a single letter string as keys are represented the cipher letters. So it also lists the uppercase letters of your potential decryption letters for each cipher letter as a dictionary value. Now when every cipher letter has just one potential decryption letter associated with it, we have a fully solved mapping and can decrypt any ciphertext using the same cipher and the key. Okay, so each your cipher letter mapping generated depends on your ciphertext which is used. So in some cases, we'll have only a partially solved mapping in which some cipher letters have no potential decryptions and other cipher letters have multiple potential decryptions. So shorter ciphertext that don't contain every letter of the alphabet are more likely to result in an incomplete map. So coming ahead, we are moving for displaying the hacking results to the user. Now when the program calls the print function to display your letter mapping 1, the original message and the decrypted message on the screen are printed. So basically we are storing the decrypted message in a variable named as hacked message 1, which is copied to the clipboard and printed on the screen so that the user can compare it to the original message. Okay, we then use the decrypt with cipher letter mapping 1 to find the decrypted message which is defined later in the program. So next we'll look at all the functions that create the cipher letter mappings. Coming to creating your cipher letter mapping, the program needs a cipher letter mapping for each cipher word in the ciphertext. So to create a complete mapping, we will need several helper functions created. One of those helper functions will set up a new cipher letter mapping so we can call it for every cipher word. Another function will take a cipher word, its current letter mapping, and a candidate decryption to find all the candidate decryption words. We'll call this function for each cipher word and each candidate. Then the function will then add all the potential decryption letters from the candidate word to the cipher word's letter mapping and then return the letter mapping to it. Now when we have the letter mappings for several words from our ciphertext, we will use a function to merge them together, and then we will use a final helper function to solve as many cipher letters decryption as we can by matching one decryption letter to each cipher letter. So as noted, we won't always be able to solve all the cipher letters, but you will find out how to deal with this issue in the decrypting the messages. So if we come to creating a blank mapping like we have created over here by defining the function. So we'll need to create a blank cipher letter mapping. When we call this blank or get blank cipher letter mapping 1 function, it returns a dictionary with the key set to 1 character string of all the 26 letters of alphabet. Okay. Now moving to adding the letters to the mapping. Okay, now to add letters to a mapping, we have defined add letters to mapping 1 function. Now this function that we have created takes 3 parameters: a cipher letter, that is a letter mapping 1, okay, a cipher word to map, that is your cipher word 1, and a candidate decryption word, the cipher word would decrypt, that is the candidate 1. Now the function maps every letter in the candidate 1 to the cipher letter 1, okay, at the corresponding indexes position in the cipher word. okay, and adds that letter to the letter mapping 1 if it isn't already there. Okay, now for example, like initially we had done on a paper and pen that, for example, if you have say PUPPY, that is puppy is a candidate for the cipher word say HGHHU. Then the add letters to mapping function would add the values P to the key H in letter mappings. Then the function moves to the next letter and appends U to the list value paired with the key G and so on. And if the letter is already in the list of potential decryption letters, then your add letters to mapping doesn't add that letter to the list again. So for example, in puppy it would skip P to the H key for the next two instances because P is already there. So finally the function changes the value for the key U, so it has Y in its list of the potential decryption letters. Now the code in this add letters to mapping 1 assumes that the length of your cipher word 1 is same as the length of candidate 1, because we should only pass a cipher word and a candidate 1 pair with matching word patterns. Then the program iterates over each index in the string in the cipher word 1 to check if the letter has already been added to the list of the potential decryption letters. So here when we say for I in the range of len of cipher word 1, we say if the candidate 1 at the index of I not in the letter mapping 1 index of cipher word 1 I. Then we are saying letter mapping 1 at the index of cipher word 1 I dot append the candidate 1 at the index I. So we'll use the variable I here to iterate through each letter of the cipher word 1 and its corresponding potential decryption letter in the candidate 1 through indexing. We can do this because the potential decryption letter to be added is candidate 1 at the index of I for cipher letter cipher word 1 index I. So for example, if the cipher word with HGHHU and the candidate was puppy, I would start at the index 0 and we would use cipher word 0 and candidate 1 0 to access the first letters in each string. Then the execution would move on to the if statement, okay, and the if statement checks that the potential decryption letter candidate 1I is not already in the list of potential decryption letters for cipher letter 1 and doesn't add it if it's already in the list. So it does this by accessing the cipher letter 1 in the mapping with your letter mapping 1 at the index of cipher word index I, because cipher word 1 index I is the key of your letter mappings that needs to be accessed. Now this check prevents duplicate letters in the list of potential decryption letters. Okay, now for example, the first P in puppy might be added to the letter mappings 1 at the first iteration of the loop. But when I is equal to 2, that is the third intersection, P from candidate at the index 2 wouldn't be added to the mapping because it was already added at the first iteration. So if the potential decryption letter isn't already in the mapping, it adds a new letter in candidate I at the index I to the list of potential decryption letters in cipher letters mapping at letter mapping 1 index cipher word 1 index I. Now recall that because Python passes a copy of the reference to a dictionary passed for a parameter instead of a copy of the dictionary itself, any changes made to your letter mappings 1 in this function will be done outside the add letters to mapping function as well. This is because both copies of the reference still refer to the same dictionary passed for letter mapping 1 parameter in the call to add letters to mapping. So after looping through all the indexes in the cipher word 1, the function is done adding letters to mapping in the letter mapping 1 variable. Okay. So now let's look at how the program compares this mapping to that of other cipher words to check for the overlaps. Okay. So we come to the intersecting of two mappings. Now we have here the hack simple sub function, okay, which uses the intersect mappings 1 to take two cipher letter mappings passed as its map A1 and map B1 parameters, okay, and this basically returns a merge mapping of map A1 and B1 over here. Okay, so the intersect mapping function instructs the program to combine this A1 and B1, create a blank map and then add the potential decryption letters to your blank map only if they exist in both. Okay, so to prevent the duplications. So when we are defining the method here for intersect mappings, we say intersected mapping 1 is equal to get the blank cipher letter mappings, okay, which creates a cipher letter mapping to store the merge mapping by calling this method here, and stores the return value in intersected mappings one variable. Okay, now the for loop or below this, which we are using, where we are saying for letters 1 in letters str. Okay, now in this, through this uppercase letters in the letter str constant variable, and uses the letter 1, that is the variable we have used, as the key of map A1 and B1 dictionary. Okay, now after giving this, we are checking whether the list of the potential decryption letters of A1 is blank. So we do that over here in the if part. A blank list means that this cipher letter would potentially decrypt to any letter. So in this case, the intersected cipher letter mapping just copies other mapping list of the potential decryption letters. For example, if the list of potential decryption letter in map A1 is blank, then the intersected mapping list to be copied to a list in map B1. Hence, we are saying here intersected mapping 1 at the index of letter 1 is equal to copy.deep copy map B1 at the index of letter. And similarly, vice versa is done over here when we check for B1. Okay, so it is copied from A1. Okay, now here the else block given here handles the case in which neither map A1 nor map B1 is blank. So when the map is not, they are not blank, it loops through the uppercase letters, okay, in the list of map A1 at the index of letter, okay, and then checks whether the uppercase letter in map A1 also exists in the list of uppercase letter in map B1. If it does, then your intersected mapping 1 at the index letter 1, we are adding this common letter to the list of potential decryption letters by saying append method. So after the for loop that's started over here, okay, in the else part, the cipher letter mapping in intersected mappings should only have the potential decryption letters that exist in the list of potential decryption letters of both A1 or map A1 and map B1. Okay, so this completely intersected cipher letter mappings. Now in the next session, we will look at an example output of an intersected mappings. So that's it from this session. We will see more in the next sessions. Thank you very much. So now let's continue and see how the letter mapping helper function work. Now that we have defined the letter mapping helper function, let us try using them in an interactive shell of Python to better understand how they work together. For this, let's create an intersected cipher letter map for the ciphertext. We will create here, or let's say open up a notepad, and we would use the cipher or letter mapping for ciphertext, say put it in capital, so OL Q I H X I R C K G N Z space, say PLQ R Z KB and ZP space, say M P B K SSI P LC. Put close the single quotation mark. Now, which this particular ciphertext contains just 3 cipher words. So we'll do this by basically creating a mapping for each word and then combining the mappings. So for that, the first thing we'll have to import here is the hacker function that we have created. So if we go to our Python hacking advanced level course, the name of the hacker function we have created is simple sub hacker. So if we go back here, we say import, say simple sub hacker. Okay, let's open up the file that is in E drive, simple sub hacker, and let us run the module once. And once this is done, now let's give import simple sub hacker. Now it's done, so let's close this particular file. Now once the import is done, next we will call the function. Now let us just keep the file open so that we are able to understand the functions that we have. So we'll go back to our E drive, Python hacking advanced level and this particular function. So now here we need to call up the function, say get blank cipher letter mappings. So if we look at it, we are having this function here. So let us say here one object, say letter mapping str1 is equal to, we are saying simple sub hacker dot say get blank cipher letter mapping 1. And then if we try to print say letter mapping str1 here, we'll get everything initially blank. So let's start hacking the first cipher word that we have. Now what is the first cipher word that we have? If we check in our notepad, this is our first cipher word that we want to hack. Now to hack this, we'll have to first need to get the word pattern for the cipher word. So we'll have to call the make word pattern module. In that, the make get word pattern function. So if we go back to our hacking program, we have this make word pattern 1. If we try to open up this in notepad just for our reference, we are having it as get word pattern str. So this function we are supposed to call. Okay, so let's copy down this, and the file name is make word pattern 1. So if we go back here in the Python shell, we say import say make word pattern 1. It is make word pattern, P is capital, sorry, import make word pattern 1. Okay, and after this we will say our make word pattern 1 dot get the word pattern str, and let us copy down this word here. Okay, and let's press enter. So this is how we are getting the word pattern, right? Okay, now to figure out which English word in the dictionary have this word pattern. Okay, now we need to import for this the word pattern module, and we have to look up for this particular pattern. So now if we go back to our program where we have the word patterns 1, so we'll have to first say import say word patterns 1, and after this import we create say candidates str is equal to word patterns 1 dot we call here all patterns, and in this we pass this pattern. Just copy this, paste it here in single quotation marks, and after that if you try to get candidate str, you try to print this, you are getting there two pattern in this. One is uncomfortable, one is uncomfortably. So two English words match the given word pattern. Therefore, the only two words in the first cipher word could decrypt to as either uncomfortable or uncomfortably. So these words are our candidate str. So we'll store them in the variable as we have done here. Now next we need to map their letters to our cipher word letter using the add letters to mapping function. So first of all, we will map the uncomfortable by accessing the first member of the candidate str list. So over here, we would say, for example, letter mapping 1 is equal to, now we are having again simple sub hacker that dot. Now let us open the simple sub hacker in notepad just to see the method that we have is add letters to mappings. So let's copy down this and go back to Python shell, and here we are going to pass the letter mapping 1 comma. Now the letter mapping 1 here we are passing this word in single quotation marks, and with that we are passing the candidate str but at the index 0, and the mapping 1 is not defined. We are saying here letter mapping 1 is equal to the function dot add letters to mapping 1, pass there the letter mapping 1, the value for it, and the value of candidates. Okay, here we are having this variable as letter mapping str1. So if here we are saying, say, letter mapping 1 is equal to, say, simple sub hacker dot, say, add letters to mapping 1. Here we are supposed to pass, say, letter mapping str1, which we have created here. So this one will be passed here, after which we need to pass the first word from our text, and then we would pass candidate str at the index 0. Okay, so now let's try to execute, and now we would try to print letter mapping 1 here. So once we have done this particular part, let us try doing this by saying, say, letter mapping is equal to, say, simple sub hacker dot add letters to mapping 1, and here we would pass letter mapping 1 in this case, then the text and candidate str index 0. So let's also copy down this text here, and now if we say letter mapping 1, so we get those letters mapped over here like this. Okay, now similarly, if you try and say letter mapping is equal to, again, say, simple sub hacker dot add letters to mapping 1, here again we take letter mapping 1 and again the same text here, but this time we take candidate str at the index 1, and again we try to say letter mapping 1 being printed. So now here you see we get multiple letters wherever exist. Now earlier what we were doing, we were taking this variable and this parameter same, because of which we were not getting any values displayed. Hence we have changed this variable where the value is stored, and this is the variable where we have already stored the blank ciphertext mappings initial. So notice that if you have seen that nothing much has changed in this letter mapping, except that the cipher letter mappings now for Z maps to also Y in addition to E. Now that is because your add letter mappings 1 adds a letter to the list only if the letter is already not there. So now that we have the cipher letter mapping for the first and the third cipher words, we need to get a new mapping for cipher word, that is second cipher word, and then repeat the same process. So now what we would do is, let us take letter mapping 2, that's equal to, we again take simple sub hacker dot get the blank cipher letter mapping. So let's just copy down this function here. Now this is, we are taking in for this is letter mapping 1 and this is letter mapping 2 that we are doing. Then we take, let's say for example, the word pat 1, which is equal to, we make here saying make the word pattern 1 dot get word pattern str, and this time we pass the middle word or the second word in this case. Just copy paste it over here, and then now that is make word pattern str. of make in this case P is small. Made a mistake by putting it capital. So we got this. Now we take again say candidate str, that's equal to our word patterns. Word patterns 1 dot, we take the all patterns, and now here we are putting the word pat 1 that we already have it, so we don't need to put it by individually copy pasting the values. Okay, word patterns, sorry, our mistake. Okay, word patterns 1. Fine. Now after this, if you try to take this candidate str, you get now 4 values which it is matching. So now if we run a loop saying say candidate str, or let's say for that case for C in candidate str, and here we take another say, now in this case we had taken normal letter mapping, so let's take here letter mapping itself, and that is equal to, we take simple sub hacker dot add letters to mapping 1. Now here T is also capital to mapping 1, and here we pass the letter mapping 2 now, and again the same text available here in this, and then we pass the value of C in this case. And once that is done, if we try to take letter mapping 2 in this case, we get this particular values. Now instead of entering a 4 number of times call to your add letters to mapping 1 for each of the 4 candidate words, we have written a loop in this case which goes through the list in the candidates and call the particular function on each of them. This finishes the cipher letter mapping for second cipher word also. So now let us move on with the intersection part of these 2 cipher letters in the next session. That's it from this session. Thank you very much. Okay, so now we need to get the intersection of the cipher letter mappings in letter mappings 1 and letter mapping 2. Now we'll pass them into the intersect mapping function. So for that, in the interactive shell here, let us insert say intersected mapping is equal to say simple sub hacker dot. Now let us first of all open the simple sub hacker function in Notepad, and let us find out the actual method for intersect mappings, that is mapping 1. So now if we go here, let us just copy paste the intersect mappings 1, and now here we are going to pass letter mapping 1 and letter mapping 2 in this case. And then if we try to say intersected mapping, we get both the things combined together. So now the list of potential decryption letters for any cipher letter in the intersected mappings should be only the potential decryption letters that are in both letter mappings 1 and 2 also. So for example, in the list of the intersected mappings, you can see for Z key it is just E, because in your letter mappings had E and Y, but letter mappings 2 had only E. So wherever both the things are common, only those would be into your intersected mappings. So now we would repeat the steps or the preceding steps for the third cipher word also which we have. So over here we would create the letter mappings 3, and that is equal to, we are using again say simple sub hacker dot get the blank cipher letter mapping 1. There is a huge difference in capital and lowercase. So simple, we would just say copy paste it. so that no errors are there. Okay, then again let's take wordpad2, which is equal to, now let's take the make word pattern, or rather let us copy down the whole thing, and the only thing we will have to change is the word. So now we would take the third word in this case. Okay, so let's copy paste that word here, and then we create the candidate str, which is equal to, so let us take the word patterns 1 and let's put here, but now we would change this to wordpad 2. Okay, now after that let's run here say I1 in the range, and we would go on for length of your candidate str, and here we would take say letter mapping is equal to symbol sub hacker dot, now you have the method that is add to letters mapping, and then here we would be passing the letter mapping 3 in this case, the word and candidate str at the index I1. So let us paste the same word here and let's execute the for loop. So now if we check our letter mapping 3, we get the values printed here. Okay, so now again we'll have to go on for an intersected mappings, because earlier intersected mappings is already there with us. So now what we would do is, let's say intersected mapping 1 is equal to, let's take simple sub hacker dot, now here we have already used the intersected mappings, and here we would pass the initial intersected mappings that we have is this one. So let's pass that, and the second one we have is letter mapping 3, the current one. Okay, so now if we try to say intersected mapping 1, so we get this mappings done. So in this example we are able to find solution for the keys that have only one value in their list. For example, say K decrypts to Y, but notice that M would decrypt to A in this case, or D, because we know that the K decrypts to A, we can reduce that K, or the key K must decrypt to D and not A. So after all, if it is solved letters, it is used by one cipher letter, it can't be used by another, because the simple substitution cipher encrypts a plain text letter to exactly one cipher letter. So now let us have a look at the remove solved letters from mapping function and find the solved letters and remove them from the list of potential decryption letters. We will need the intersected mappings that we have just created. So we will not close this in interactive shed. So coming to the identifying solved letters in mapping, you have the remove solved letters from mapping function, which searches for any cipher letters in the letter mappings that have only one potential decryption letters. So these cipher letters are considered solved, which means that they are, or any other cipher letter which with this solved letter in their list of potential decryption letters can't possibly decrypt to this letter. So this could cause a chain reaction, because one potential decryption letter is removed from other list of potential decryption letters holding just two letters. The result could be a new solved cipher letter. Okay, so the program handles this situation by looping and removing the newly solved letter from the entire cipher letter mapping. Now, let us do one thing. Let us open our simple sub hacker function. So let's go to our code and this one. Okay, so now here if we go for the remove solved letters from mapping, you can see this. Okay, so over here we are having the loop. Then while it is loop again is true, we are assuming that this will not loop again, so hence we are making this false here. Now because a reference to a dictionary is passed to the letter mappings parameter, okay, that the dictionary will contain the changes made in the functions, even after the function returns, it creates a loop again variable that holds a Boolean value which determines whether the code needs to loop again when it finds another solved letters. So if the loop again variable is set to true, the program execution enters the while loop. At the beginning of the loop, it sets the loop again to false, and the code assumes that this is the last iteration through the while loop. And the loop again variable is only set to true if the program finds a new solved cipher letter during the iteration. Now the next part of the code over here, okay, it creates a list of cipher letters that have exactly one potential decryption letters, and these are the solved letters that will be removed from the mappings. So we say solved letters 1. We create a loop for cipher letter once in your letter str. If the length of this is equal to 1, then you're appending it to solved letters dot append method, the letter mappings with the index of cipher letter and 0. Now the for loop here goes through all the 26 possible cipher letters and looks at the cipher letter mapping list of your potential decryption letters for this or for that cipher letter, that is the list at the letter mappings at the index of cipher letter 1. Then it checks whether the length is equal to, or the length of this list is equal to 1. If it is, then we know that there is only one letter that the cipher letter would decrypt to, and the cipher letter is solved. So then over here we are adding it to the solved decryption letters to the solved letters list, and the solved letter is always at letter mappings, that is cipher letter and the index 0, because it is the list of potential decryption letters that has only one string in at the index 0 of the list. So after the previous for loop that has started, the solved letter variable should contain a list of all the decryptions of cipher letters. And at this point, the program is done identifying all the solved letters. Then it checks whether they are listed as potential decryption letters for other cipher letters, and then it removes them. So for doing this, then we are having another for loop which is going through all the possible 26 cipher letters and looks at the cipher letter mapping list of the potential decryption letters. So here we are saying for cipher letter 1 in letter str, for S1 in the solved letters, if the length of this is not equal to 1 and S is in your letter mappings 1 at the index of cipher letters, then we are saying the letter mapping 1 at the index of cipher letter 1 is dot remove, and then we check if it is equal to 1, and that is the new letter is now solved, then so no loop again, hence we are making it loop again to true, which will again continue the loop. So here the for each cipher letter examines through the letters in the solved letters to check whether any of them exist in the list of potential decryption letters for your letter mapping 1 at the index of cipher letter 1. Then we check whether the list of potential decryption letter isn't solved by checking whether the length of letter mappings 1 at the index of cipher letter 1 is not equal to 1, which is over here in this line. And by checking whether the solved letter exists in the list of potential decryption letters. So if both the criteria are met in this condition is returning true, then we remove that solved letters from S1 from the list of potential decryption letters. And if this removal leaves only one letter in the list of decryption letters, then we again set the loop again variable to true in this case, so that the code can remove this newly solved letter from the cipher letter mappings on the next iteration. Now after the while loop has gone through a full iteration without loop again being set to true, then the program moves beyond the loop and returns the cipher letter mapping, that is the letter mapping 1 over here. And the variable letter mapping 1 should now contain a partial or potential fully solved cipher letter mapping. So now let's come to testing this particular method, that is remove solved letter from mapping function. So to let's see this particular function in action by testing it in the interactive shell. Now we'll go back to interactive shell and where we have created the intersected mappings. So let us just copy down this function name, which is easy for us to writing down over here. Now we would say over here, say letter mapping is equal to say simple sub hacker dot this remove solved letters from mapping 1 function, and in this we would be passing say the intersected mapping 1 in this case. And then let us try to say, or let us try to call the intersected mapping 1. So once we have done this, now when you remove the solved letters from your intersected mapping, notice that now over here, initially we had in M, A and D, but now here we just have D in this case, which is what we predicted from the case it would be. So now each cipher letter has just one potential decryption letter. So we can use this cipher letter mappings to start decrypting. Now again we would return to the interactive shell example one more time. So we will not close this, we would keep this open. Now coming to our hack simple sub function. So if we go back to our interactive shell and let us open our file again. So let's go back to E drive here and simple substitution. Now if we go back to our hack simple sub1 function. So now that you have seen how the function, that is your get blank cipher letter mapping 1, your add letters to mapping 1, your intersected mappings 1 and remove solved letters from mapping 1 have manipulated the cipher letter mappings that you have passed them. So now let us use them in our particular program to decrypt the function. Okay. So now here we are going to define the decrypt or hack simple sub1 function, which is going to take a parameter of message str. In that we are going to say intersected maps 1 is equal to calling the blank cipher letter mappings, cipher word list str in which we are storing the non-letters or space pattern. Now here we are creating a new cipher letter mapping that we store in the intersected map 1 variable, and this variable will eventually hold the intersected mappings for each of the cipher words. Now after this we basically remove any non-letter characters from the message str and we use the regex object in the non-letters or space pattern matches in a string that isn't a letter or a white space character. Then we have this sub function. You can see it over here if you just move a bit. Now in this sub method or the sub function, now this is basically called on a regular expression and it has taken 2 arguments. The function searches the string in the second argument for matches and it replaces those matches with the string in the first argument. Then it returns a string with all these replacements, and in the example the sub method tells the program to go through the uppercased message string and replace all the non-letter characters with a blank string. Now this makes the sub returns a string with all punctuation number characters removed, and this string is stored in your cipher word list variable which we have created. Then we execute the cipher word list variable should contain a list of uppercase letters, and the for loop assigns each letter in the message list to your cipher word variable, and inside this loop the code creates a blank map, gets the cipher word candidates, add the candidate letters to the cipher letter mappings, and then intersects this mapping with the intersected map. Now we will see more in detail about this in the next session. That's it from this session. Thank you very much. So now here we are having a for loop for cipher word 1 in the cipher word list str. In this we are getting a new cipher letter mapping for each ciphertext word. We are saying candidate map str is equal to get the blank cipher letter mappings 1. Then we have the word pattern str, which is calling the make word pattern 1 dot get the word pattern str and passing the cipher word in this as the parameter. Then it checks if your word pattern str not in the word patterns dot all patterns. Then you are saying continue. Now this word was not in our dictionary, so we are saying it to continue. Then later we are saying add the letters of each candidate to the mapping. For that we are saying for a candidate 1 in your word patterns 1 dot all patterns, passing that word pattern str in that. We are saying add letters to mapping, passing the candidate map str cipher word 1 and the candidate 1. Then we intersect the new mappings with the existing intersected mapping by saying intersected map 1 is equal to the intersect mappings function, pass in that the existing intersected mappings and the candidate map string. So here we are getting a new blank cipher letter mapping from the function that is get blank cipher letter mapping here, and it stores this in the candidate map str variable. To find the candidate for the current cipher letter, we call the get word pattern str in the make word pattern 1 module. And in some cases, the cipher word may be name or a very uncommon word that doesn't exist in the dictionary, in which case this word pattern likely won't exist in the word pattern either. So if the word pattern of the cipher word doesn't exist in the keys of your all pattern dictionary, the original plain text word doesn't exist in the dictionary file. So in that case, the cipher word doesn't get a mapping, and then it goes on for continue statement, which basically returns to the next cipher word in the list. So if the execution, we know the word pattern exists in your all patterns, then the value in the all pattern dictionary are list of string of the English words with the pattern in the word pattern. Because the values are in the form of a list, we use a for loop to iterate over them. Variable candidate is set to each of these English word string on each iteration of the loop. Then we call the add letters to mapping 1 function, which is basically update the cipher letter mappings in the candidate map str using the letters in each of the candidate 1. And then the add letters to mapping 1 will modify the list directly. So the candidate map str is modified by the time the function call returns. And after all the letters in your candidates are added to the cipher letter mapping in the candidate map str, intersects the candidate map with the intersected map here and returns a new value of the intersected map 1. So at this point, the program execution returns to the beginning of the loop, and to create a new mapping for the next cipher word in the cipher word list, and the mapping for the next cipher word is also intersected with the intersected map. The loop continues mapping cipher words until it reaches the last word in your cipher word list str. Now, when we have the final intersected cipher letter mappings that contain the mapping for all the cipher words in your ciphertext, we pass it then to the remove solved letters from mapping 1 function to remove any solved letters at this particular line. Now, the cipher letter mapping returned from this removed solved letters from mapping 1 is then returned for the hack simple sub function. And now we have the part of cipher solution, we can start decrypting the message. So coming to using the replace string method. Now over here, if you say just have a look at initially what do you understand by the replace string method over here. Now, so the replace string method returns a new string with a replaced character. First argument is a substring to look for, and second argument is a string to replace those substrings. Now if we come to our decrypting the message part, now to decrypt our message, we will use the function that is your decrypt message with cipher letter mappings. Now here also we are going to use in this particular function, the function that is our decrypt message str, which is there in our simple substitution cipher demo. So now for this, this particular function also decrypts using only keys, not the letter mapping. So we can't use the function directly. So to address this, we will create a decrypt with cipher letter mapping, which is a function created here that takes a letter mappings, convert the mapping into a key, and then passes the key and the message to your decrypt message function. And then the function that is decrypt with cipher letter mappings basically return a decrypted string. Now recall the simple substitution keys are the string of 26 characters, and a character at the index 0 in the key string is an encrypted character for A. The character at the index 1 is an encrypted character for B, and so on. So to convert a mapping into a decryption output, we can easily read, we will need to create first placeholder key, which will basically look like XXX everywhere, which can be used in the placeholder key because the actual key uses only uppercase letters. Because not all the letters will have a decryption, we'll need to able to distinguish between parts of the key list that have been filled with decryption letters and those where the decryption hasn't been solved. Okay, so now let us see how this all comes together in the given source code. So if we go for this define decrypt with cipher letter mapping 1, where it takes parameters of cipher text 1 and letter mappings 1. In this particular function, it's going to return a string of cipher text decrypted with the letter mappings with any ambiguous your decrypted letters replaced with an underscore sign. So first of all, we will create a simple subkey for the letter mappings by saying over here the key str is equal to x multiplied by the length of letters str. Then we say for the cipher letter 1 in the letters str, check if the length of your letter mappings 1 at the index of cipher letter 1 is equal to 1. If it is, That is, if there is only one letter added to the key. So then next we are saying the key IDX is equal to letters str.find it, and say key str at the index of key IDX is equal to the cipher letter 1. Now here we are going to create a placeholder list by or replicating a single item list, that is X in this case 26 times, because we have got multiplied it by length of the letters str. So when we use this on a basically list and integers, the multiplication operator performs the list replication. So next we come to the for loop, which checks each of the letters in your letters str for the cipher letter variable, and if the cipher letter 1 is solved, it replaces X with the placeholder with that letter. Now the letter mappings 1 at the index of cipher letter 1 is the decryption letter, and the key index is the index of the decryption letters in letters str, which is returned from the find method here. It sets this index in the key list to the decryption letter. However, if the cipher letter doesn't have a solution, the function inserts an underscore sign for that particular letter to indicate which characters basically remain unsolved. Then we replace the lowercase letters over here in the cipher letters with an underscore and replaces the uppercase letters with an underscore. So we come here in the else part and do that. So after replacing all the parts in the list in key with the solved letters, the function combines the list of strings into a single string using a join method. Okay, to create a simple substitution key. Now this string is passed to the decrypt message function of your simple or substitution cipher demo, which is passed here. Finally, we get the return of the decrypted message string from the decrypt message str function, and we now have all the functions we need to find an intersected letter mappings. Hacker key, decrypt a message. So let's look a quick example of how these functions work in the interactive shell. So let's come to decrypting in the interactive shell. We have done till the last part everything in the interactive one. Now let's return there and we use the particular text where we will be using the intersected mapping variable to create our earlier shell examples to decrypt the cipher message that we had inserted. So now at this particular point, we will have to insert, say, let's go here and we would say our program is, say, let's go back here. It is simple sub hacker. So simple sub hacker dot. Now we will be using the decrypt with cipher letter mappings. And here we are going to pass the text, also the intersected mapping 1, and the text that we're going to pass is there already in Notepad. So let us just copy down the text over here in the single quotation marks. After this, we are getting it as uncomfortable, increase, disappoint. So the cipher text decrypts to the message. As you can see, the decrypt with cipher letter mapping function worked perfectly and returned a fully decrypted string. But this example doesn't show how or what happened when we don't have all the letters that appear in the ciphertext solve. Now, to see that what happens, we are missing a cipher letter decryption. Let's remove the solution of the cipher letters M and S from the intersected mappings by using some instructions, like we are saying, say, intersected mapping 1 at the index, say, M, we are making is equal to blank. Also intersected mapping 1 index S, also we are making it blank. And then again we try to do it something like, say, simple sub hacker dot, we call this again, sorry, decrypt with this, pass the text and intersected mapping 1. So let us copy down the text here again. So now you can see here, when you try to decrypt the cipher letter with this, you're getting there where somewhere underscore sign. So this part, the part of ciphertext wasn't decrypted. Say cipher letters without a decryption letter were replaced with an underscore. So this is rather short ciphertext to hack. Normally encrypted messages would be much more longer. So to hack longer encryptions, you will need to create a cipher letter mapping for each cipher word in the longer message and then intersect them all together. So the hack simple sub function calls the other functions in our program to do this exactly the way as we have done it over here. So with this, let us go to our program. And the last part in our program after this decrypt with cipher letter mappings is we are calling the main function to run the program if it's being run directly instead of being imported as a module by another Python program. So with this, we have completed our discussion of all the functions that the simple sub HackerOne program uses. So now from this, we must have understood that this is fairly complicated, the way we have trying to hack a substitution cipher. Okay, you have also learned how to use a cipher letter mapping to model the possible decryption letters for each ciphertext letters. You also learned how to narrow down the number of possible keys by adding some potential letters to the mappings, intersecting them, and removing the solved letters from other list of potential decryption letters. So the main advantage of a simple substitution cipher is its large number of possible keys. The disadvantage is that it's relatively easy to compare cipher words to words in a dictionary file to determine which cipher letter decrypts to which letter. Now in the next session, we would explore a more powerful polyalphabetic substitution cipher which is called as Vigenère cipher, which was considered impossible to break for several hundred years. So that's it from this particular session. Hope you have understood the program that we have done, because there are many programs intersected with each other for execution of one program. So all of them you would find it over here, just some hands-on experience on them so that it makes your concepts very much clear if you practically do those things. So we would see in the next session programming the Vigenère cipher. That's it from this session. Thank you very much. Welcome to the next session in Python advanced level course or Python hacking advanced level course. In this session, we are going to look at programming the Vigenère cipher. Now just an introduction part about Vigenère cipher. The Italian cryptographer named Giovanni Battista Bellaso was the first person to describe the Vigenère cipher in the year 1553. But it was eventually named after a French diplomat, Blaise de Vigenère, one of many people who reinvented the cipher in subsequent years. Now this Vigenère cipher remained unbroken until British polymath Charles Babbage broke it in the 19th century. Now because the Vigenère cipher has too many possible keys to the brute force, even with our English detection module, it's one of the strongest cipher discussed so far. So it's even invisible to the word pattern attack that we have learned in the earlier sessions. Now topics which we are going to cover in this session are subkeys and building strings using the list append join process. Now understanding first using multiple key letter in the Vigenère cipher. Now unlike a Caesar cipher, the Vigenère cipher has multiple keys. Because it uses more than one set of substitutions, the Vigenère cipher is also known as a polyalphabetic substitution cipher. Unlike with the simple substitution cipher, frequency analysis alone will not defeat the Vigenère cipher. Instead of using a numeric key between 0 to 25 as we did in the Caesar cipher, we use a letter key for the Vigenère. The Vigenère key is a series of letters such as an English word or single English word that is split into multiple single letter subkeys that encrypt letters in the plain text. Now let's just try to do this manually first. So let's go to the notepad and say for example we use a Vigenère key of say pizza. The first subkey is P over here. Second is I. Third and fourth letters of the plain text is the same. Okay, that is Z. And the fifth is A. Okay, the first subkey encrypts the first letter of the plain text. Second subkey encrypts second letter and so on. When we get the sixth letter of the plain text, we return to the first subkey. Now using a beginner cipher is the same as using a multiple Caesar cipher. Instead of encrypting the whole plain text with one Caesar cipher, we apply a different Caesar cipher to each letter of the plain text. For example, the first subkey would be say AP15, second would be say AI8, third would be say AZ25, then it may be say AZ25, again say fifth would be AA0. Now each subkey is converted into an integer also and serves as a Caesar cipher key also. For example, letter A corresponds to Caesar cipher key here, that is 0, and the B corresponds to Caesar cipher key 1, and so on up to Z. So here we would replace say A and Z to say 25 in this case. So now let's look at an example. Now we'll have the following message, like say, let's go on a new line, say common sense is not so common, and over here we will have the beginner key given as say pizza. Fine. Now for every character over here, this would not find it proper. What we would do is, let's go to Excel, and here we would enter say common sense is not so common. Now let's just place it properly so that we can place the beginner key below that. So we are going to combine that together because we just require characters to be displayed. So the column width could be or easily adjusted to the character width. Now let's just place it over here, and here we would write down say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And over here we would just give the keys for this, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 25. And when we have taken this, let's write down everywhere. We would repeat this key multiple times. Like this. So now if we are supposed to encrypt say C in the plain text with the subkey P, it will encrypt a Caesar cipher using a subkey corresponding numeric key 15, which will result in a cipher letter R, because if you see C it is 2, if you see P it is 15, 15 plus 2 comes to 17, that is R. Okay, and this will repeat the process for each letter of the plain text by cycling through the subkeys. So let us try and get here the output that we would get when we encrypt this. So if we take this, you will get it for C, the character say R, then you would get it for O as say W, then L, because M and Z is common, hence we would get the same character there also, say O, C, A, D, M, S, T, Q, R, M, O, I, A, N, B, O, B, U, N and M. So this would be actually your decrypted text. So longer the beginner keys are, they are more secure in the reason that the more longer it is, the more combinations you would have it. So the more letters in the beginner key, the stronger the encrypted message will be against the brute force attack. So over here the key that we had taken was a very poor choice because it has only 5 letters. a key with a 5 letters will have only a limited combinations, because 26 letters to the power of 5, that is 26 to raised to the 5, will be somewhere around 11881,376 value. So 11 million keys are far too many for a human to brute force, but a computer can try them all just in some few hours. So it would be it would first try to decrypt the particular message using the key 5 times A and check whether the resulting decryption was in English. It would then try it, say, by AAAB or AAC until it goes to the key pizza. And the good news is that for every additional letter the key has, the numbers of possible key multiplies that many 26 times. So once there are a quadrillions of possible keys, cipher would take a computer many years to break it. So number of possible keys based on a cipher length would be, you can have the key raised to whatever values. So the higher number of keys you have, or the bigger key you have, the more it is difficult for a computer to crack the given beginner cipher. So with the keys that are 12 or more letters long, it becomes impossible for a mere laptop to crack them in a reasonable amount of time. Okay, so choosing a key that prevents your dictionary attacks. A beginner key doesn't have to be a real one like pizza. It can be any combination of letters of any length, just as 12-letter key. In fact, not using a word that can be found in a dictionary is best. Even though the word, say, radiologist is also a 12-letter key, that is easier to remember than some unique or a random characters in that case. So a cryptanalyst might anticipate that a cryptographer is using an English word as a key. So attempting a brute force attack using very English words in a dictionary is known as your dictionary attack. Now, if we use a 12-letter word for a dictionary as a key, it would be easier to brute force than a random 3-letter key, which would have many more possible combinations. Of course, the cryptographer has an advantage that the cryptanalyst doesn't know the length of the beginner key, but the cryptanalyst would try all 1-letter keys and all the 2-letter keys and so on, which would still allow them to find a dictionary word very quickly. So now let's move on to the source code for the beginner cipher program. So let's close this and go back to our Python IDL. So over here we would go for a new file, and in this we would write down the given program and save it. Again, remember that you should have the paperclip file in the same directory. Okay, so first thing that we are going to do is we are going to import the paperclip module here, and then we are going to define the letters str is equal to all the alphabets A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z in capital. Then we are going to define the main method, and this text can be, or you can basically create here some message using the my message str, and here we are putting it in triple quotes. Let's give here, say, this is Python hacking advanced level course. You are learning. Let's give here and enter. Say you are learning the beginner cipher program. Let's close this. Then we would also give here, say, the my key str, which is equal to, let's give here a key, say ASIMOV. It's just any characters you wish to give. Then we are giving here my mode str, that's equal to currently encrypt is being set. You can set it to decrypt if you want to decrypt it too. Then we check if your my mode str is equal to encrypt, then you will use a translated str is equal to, say, let's say here encrypt message str, and here we pass my key str comma my message str. Then you check using else if your my mode str is equal to decrypt. If it is, then you say translated str is equal to decrypt. Say message str, and again here we pass my key str and my message str. Okay, then we are giving some print statements here. That is, let's give here in percentage ed, say message, and then we print here in percentage, say my mode str dot title. Then we print the translated str here. After we print the translated str, we use the paperclip dot copy and copy this translated str message, print a blank line, and finally we print, say, the message has been copied to the clipboard. Now after this, our definition for main ends here, and after this we are going to define the encrypt message str with key str and say message str, and in this we are just going to return another function, that is, say translated message str, which is going to pass key str, then your message str and the text, that is encrypt. Similarly, we are going to define another method, that is decrypt message str, which would again take the key str and the message str, same parameters, and again here we are going to return the translated message str and pass in that the key str, the message str, this time the text as decrypt. And then finally we would create the translate message str function. Let us just save this file first before we actually create it. So let's go to our advanced level course, and here we give it a name to save it as, say, it is GE beginner cipher demo. Let's make C capital D capital dot py. So we are going to save this by beginner cipher demo dot py. Now the last thing that we are supposed to do is the main function to be created, that is translated message str function. So we would create this in the next session. That's it from this session. Thank you very much.
So now let us continue to define our translate message method. So this we have done till the last session. So now over here we are saying define your translated message str method, which will take the key str as the parameter, the message str as the parameter, along with the mode str, which is either a string of encrypt or decrypt that we have already passed in the encrypt message str and the decrypt message str. Okay, so now over here in this definition we would create, say, translated str is equal to blank. Now this is basically storing the encrypted or the decrypted message string. Then we are having the key idx, which is equal to 0. We have the key str, that's equal to the key str dot convert to upper, and after this we run a for loop, okay, which will loop through each symbol in the message. So we are saying for sym in your message str, open the for loop, and here we take num1 is equal to, say, our letters str dot find in bracket sym dot convert to uppercase. Now we have here this letter str, so that is what we are finding it over here. And after this we check in the if the value of num1 is not equal to -1, then now here -1 means your sym dot upper was not found in the letter str.
So then over here we are saying if the mode str is equal to the value that is encrypt. This is another if condition we are checking. Then we say num1 say plus is equal to the letter str dot find in bracket we give the key str along with the key idx, that is add if it is encrypting it. Now another check would be in the else if part for the mode str. If it is equal to not encrypt but decrypt, then we need to subtract it. So then we say num1 is minus is equal to, here we are saying letter str dot find in bracket the key str, the key idx, that is subtract if it is decrypting. Now once this else and else if part is done, we go for num1 modulo is equal to the length of the letter str, that is handle any wraparound if any, and then we would add the encrypted or the decrypted symbol to the end of the translated by saying, say here if we say sym dot is in uppercase, then we say the translated str, that is the variable that we have taken, dot we are using the append method and we are saying letter str at the index of num1 to be appended. Then again we check the else if part and we say sym dot is lower, then we are saying say translated str dot append, here we are using the letter str index num1 dot lower if it is in lowercase. Now after this then we go ahead for saying the key idx plus is equal to 1, that is move to the next letter in the key once this is being done, and then you check if your key idx is equal to the length of your key str. If it is, then you make the key idx back to 0. Now we come for this if condition that we have written. For this if, we are giving the else part here, that is we are telling to append the symbol without encrypting or decrypting. So then we are saying say translated str dot append the value of sym, and then finally we are using a return statement dot join method and we are saying translated str to be returned. Now once this is done, then if your current program is run, okay, instead of imported as a module you will call the main function. So here we are checking if name underscore is equal to main, then we are calling the main method. So let us again just save it, as already we have given the name for the file. Now if we try to say run and run the module, okay, we are getting the error on line 55 and 16. Let us find out that first. Let's go to line 55 or else it is line 16. So let's go to line number 16 first, and that is over here we are passing the value of my mode str over here, that's encrypt or decrypt, that is what we are going to actually print it. So let us just examine this particular value that we are printing, this SED, it's percentage S and then ED. Let us save this and run. Yeah, so we are getting this particular message that has been encrypted in this case because we have given the message to be encrypted and not decrypted. So now over here let us go to understand the program that we have given. So first let's go for setting up the modules, the constants and the main function. So the beginning of the program, if you look at over here, the starting where we had started was the importing statement for the paperclip module, and a variable called letter str was created which holds a string of every uppercase letter. Then we have the main function for the beginner cipher, and it is like the other main functions that we have, which we have already seen in this advanced level and earlier to this also. It starts by defining the variables for your message str, your key str, and your mode str. So then once you have understood till this, let us move ahead. So the user sets these variables before running the given program. So the encrypted or the decrypted message, depending on what my mode str is set to, is stored in the variables named translated, and then it can be also printed and copied to the clipboard. So coming to building strings with the list append join process. Now let us understand something new in this. Almost all the programs that we have seen have built a string with code in some form. Now that is, the program creates a variable that starts as a blank string and then adds characters using the string concatenation. Now this is what is our previous cipher program have done with the translated str variable. Now we can open the interactive shell and let us try entering some details over here. Something like we enter, say, building s is equal to blank. Then we say a loop, say c1 in, say, Python hacking. And then we are saying in this, we say building s plus is equal to c1. And then we give here print the value of building s. So we get there the value Python hacking. Now this code loop through each character in the string Python hacking and concatenate it to the end of the string which is stored in the building s variable. So at the end of the loop, building s holds the complete string. Although this particular string concatenation seems like a straightforward technique, it's very inefficient in Python because it's much faster to start with a blank list and then use an append list method there. So when you are done building the list of the particular string, you can convert that list to a single string variable by using a join method. Okay, so instead of this particular code that we have done, we will write down similar code which will do the same thing as this particular code has done. So over here, we will create, say, building s is equal to open close bracket. Then we are creating for c1 in, say, Python hacking, open the for loop. Then here we are saying building s, say, dot append the value of c1 to it. Then let's go here and then we say building s is equal to single quote dot join the value of building s, and then we give a print command, say building s. It also gives us the same output. So using this approach to build up string instead of modifying a string will result in a much faster programs. And you can see differences of time by two approaches using the time.time method. Now just to test this, we will create a new file in the editor window and we would enter certain code into it. So let us go for a new file, and the first thing we would do is we would import here time. Then we would say start time 1 is equal to, say, time.time. Then we run for t1 in the range we would give here in, say, 10,000. Okay, a bigger number for it. Then we have here, say, building s is equal to the first method that we had used for I1 in the range of 10,000. We are saying building s plus is equal to, say, concatenate x, and after this you run a print command saying, say, string concatenation colon comma, here you print the value of time.time minus the start time 1 that you had. So the exact time would be printed. Now once we have done this, again we would create, say, start time 2 is equal to, again, say, time.time, and again here we would take t2 in the range, same range we will take, so that we'll get the exact difference. We have here building s which is equal to a list now, and again here we are saying I1 in the range of 10,000 again. And once we open up this, here we say building s dot, we use the append method and we say append the value of x, after which we say building S is equal to dot join the value of building S. And finally, we give a print command saying say list appending colon, and we print here time dot time minus start time 2 in this case. Now let us save this. Just we would save it in our E drive, an advanced level course, and let us give here name, say test string dot py. And now if we try to run this module, it will take certain time because we have given a range of 10,000 there. So we will get how the string concatenation works, and we would also get to see how the string list works there. So let us just wait and see the output, what it comes for string concatenation as well for the string or the list appending that we have used it there. See here, string concatenation took how much time? And again, let us now check for the list appending to work and get the similar output. So list appending took how much time? It is a lot more differences if you find out this. So now we have set here the variable. If you look at this test string program, which is your start time 1 over here, the first variable that is setting as the current time, and the code runs here for 10,000 times, and it appends the 10,000 characters to a string using a concatenation and then prints the time it took to finish the concatenation. Then the program resets your or sets another time in start time 2 variable to the current time, again runs the code and use this time the list appending method to build a string of the same length and then prints the total time it took to finish. Now every computer may differ what time you are getting. So in this case, if you just look at the output, it has taken 54 about seconds for the string concatenation, but using the list append join process, it took the same task in just 18 seconds. So if the program builds a lot of strings using list, can make your program much faster. So now we will use the list append join process to build strings for the remaining programs in this particular session. So we'll continue more on discussion of the program that we have already done in the next session. That's it from this session. Thank you very much.